Yeah, University of Cambridge is fine. Yeah, keep it simple. That's my main employment, so let's go with that. Yeah.
Good morning, everybody. Hello, welcome to day 2 of DeSci London. I hope you enjoyed yesterday if you're here, and also if you were listening on the live stream, I hope you enjoyed yesterday. So, first up, starting pretty much on time, we've got Jenny Malloy, who is from the University of Cambridge, and she's talking about common threads in open and decentralized science. Thank you.
Wonderful, thank you very much, and it's great to see you all. Thank you very much to the organisers for inviting me. So my name's Jenny Malloy. I'm based at the University of Cambridge, but I also work with a number of organisations in the field of open tools for mostly biotechnology and the bioeconomy. But I'm here really to sort of contextualise some of the common threads that I've seen emerging in the decentralised science arena, which I'm very new to, and also open science, which I'm not so new to, and is a kind of movement that's been growing for a couple of decades now, but has branched out to new realms. And so this is going to be a very short and reasonably kind of personal oversight of where I think there's some commonalities in the approach, and where I think there are questions that open science is grappling with that decentralised science should probably also be considering if it isn't already. But I think the main thread that I think ties these two movements together is it's reimagining knowledge production, but catalysed by new technology. And the open science movement really emerged because of the internet, effectively, and how that can kind of lead to greater sharing of knowledge, but originally in a very kind of one way. So sharing of knowledge freely online for people to read, so the open access movement, in order to publish academic articles and other kind of products of science that are very familiar to us, but in a way that everybody could not only read them, but also use that knowledge in different ways. So it was really a movement to kind of free copyright and enable that copyright to be licensed in ways where people could use it. But then the web moved on, and so then really open science also started being more about participation in science online, and now Web3 is offering these kind of totally new structures. And so I think that these two movements are very clearly connected. So in terms of the open science movement, what does open mean? Well, many things. And I think this is a slide from Cameron Naylan, who was a very early proponent of open access and a really deep thinker in this space, really talking about sharing what we already create. Because like I said, originally, open science was taking science as it existed and making the products of that science more open. So this is true, but I think it represents a very kind of early stage of the open science movement or community. And really the focus at the time that this was all coming about, the original open access movement, the original open data and science communities and thinking, were really around licensing. So something was considered open if anyone is free to use, reuse and redistribute it, subject only at most to the requirement to attribute and or share alike. So you can see already, it got quite technical in terms of how you would legally make this stuff available. And this is a quote from the opendefinition.org, which didn't only apply to open science, but was also, there was a big movement in the early 2000s really around openness in all sorts of data, government, businesses, all walks of life, thinking about how to make content more open. But I think really openness spreads beyond that, and that's what I think the decentralized science movement is really kind of pushing forward, are these other aspects of open. So I quite like the definitions that the International Development Research Centre put forward when they were thinking about openness in terms of information technologies for development. So number one is universal versus restricted access. You're providing mechanisms for organising knowledge production in a decentralised way, in your case, or in any kind of way, an open way, in the open case, that favours universal versus restricted access. So in my work, we work on developing toolkits for synthetic biology, which are openly available, unencumbered by intellectual property. They're in the public domain and anybody can use them. But you can apply the same principle to all sorts of digital goods. And then secondly, universal versus restricted participation. So greater involvement of beneficiaries in shaping projects using open tools. And I think that's an area where there's really very clearly a lot of decentralized science initiatives in that area. I was just chatting before the course a little bit about the Fleming Protocol and how you can actually involve people in having agency to drive forward science. And that also kind of leads on to the third point, which is this idea of having collaborative versus decentralized production. Interestingly, at the time this was written, all the way back in 2008, they didn't use the word decentralized, they used the word collaborative. And I'll leave you to decide whether collaborative and decentralized are kind of the same sort of thing, or maybe decentralized is a step beyond collaborative. But this idea of having multiple partners working together for a common goal, and I think all of the work around DAOs and distributed governance is really kind of playing into this third part. So for me, there's a really strong link between the open science kind of principles and thinking and approach and what the decentralized science community, as I understand it, is attempting to achieve. But I think that sometimes we need to go beyond this when we're thinking about where and why and how to make something open, and that's something that the open science movement have been tackling, both at just a very pragmatic level of how much stuff do you make open, because it's a lot of effort. So there's been discussion of principles such as intelligent open science, deciding how much it's worth, putting the effort into making reusable, and things like not just open source, but useful source. Have you actually documented something in such a way that it's reusable downstream, as opposed to simply slapping a license on it that technically makes it open? So whenever you kind of dive into any of these areas, there's always more consideration in terms of the actual mechanisms and the actual outcomes that you're intending to achieve. I think in terms of an observed pattern that I've seen in open science, and will be interesting to observe in the decentralized science space, is that it starts with a really passionate community. So I'm sure that all of you here are here because you see that this is, a future that you want to happen in the world. And that was very much the kind of earlier open science meetings were fervent and kind of very motivated and passionate people coming together to say, we need this change to happen, and how do we make it happen? And over time, you are successful, which is great news. And things start getting adopted and they start getting institutionalized. So, open data, for example, I would say is pretty institutionalized now. Funders have open data mandates. It's discussed. Graduate students routinely get taught how to share their data openly. And that kind of leads to some expansion of scope for the community, because that community typically has a vision of a much bigger reconfiguration of knowledge production and a much bigger disruption to the system. So as soon as the system starts actually adapting to what they're saying in small ways, I've seen a lot of people who were in that original movement expand their scope. And so this is one of the reasons that my passion now is in terms of open hardware and open biology and open tool sharing, because I see open access and open data is kind of going to happen anyway, regardless of where I spend my time. It's not there yet, but it's institutionalized enough to the point where there's professionalization and there are roles in universities that are taking this forward. And so you see the kind of real passionate advocates and activists coming out into other areas. And I think we'll hear more from Tamara on kind of some of the work that's been done in this area as well. So I think, I don't know what that's going to look like for decentralized science, but I think it's a pattern that I would anticipate will also happen as more and as you are successful and people start adopting these approaches more broadly. And as an example, this is in 2009, a group of us in Cambridge met at the Panton Arms pub and produced the Panton Principles, which were principles for open data in science. It's me and a small number of other people, including John Wilbanks from Creative Commons, Rufus Pollock from the Open Knowledge Foundation, as it was at the time, Cameron Nayland, Peter Murray Rust. At the time, there were no principles for open data in science. There was sort of discussion on forums and mailing lists. And so if you fast forward to 2022, there's been a whole shift in how people think about open data. So just to illustrate that even within that reasonably short period of time, something can switch. It doesn't mean it's totally there. There's still a lot of work to be done to make open data in science the kind of the default approach, but it did happen. So there's scope for success. And also just the sort of massive expansion of technology. I mean, at this time, the very radical discussion was, should we be commenting on scientific articles on the internet? so like the technology has just expanded, and I am not a Web3 expert in any way, shape or form, but I think I've been to enough talks about it to understand some of the disruptive potential. And it's really exciting. It was an exciting place to be in 2009 with open data. And I kind of, from the Twitter stream and live stream yesterday, I got the sense that it's an exciting place to be in this room right now, thinking about what 10 years time might look like for decentralized science. Because we didn't know at that point that open data would happen in the way that it has done. And as I say, there's many other topics that are still very much, there's work to be done and to succeed in terms of collaborative science, in terms of open hardware, open wetware, and other areas. And then I think the thing that open science has been really addressing in part for the last 10 years, in the early days, there was a lot of advocacy and kind of, we need to try these things out, we need to experiment, we need to do stuff. And so there was a lot of activity, and then really a kind of questioning of who is actually benefiting from that activity. And so I think in terms of open as an approach, actually questioning why, when, where, and how we should employ it and for what ends is always extremely important. And from what I've seen, many of the decentralized science initiatives are already asking those questions. But I think just as a sort of, this is a personal reflection on where I think open source approaches make most sense. And I think there is some overlap with the decentralized approach as well. So accelerating research and development. Again, Cameron Nayland was very conceptualized a lot of the early work in open science about reducing friction, mostly reducing friction in access to knowledge. And I think that access is still very important, but also reducing friction in terms of access to collaborators, in terms of access to funding, not an issue addressed by open science, but I know a real kind of point of focus for many in the room. User innovation, so how to get more diverse ideas and expanding pool of developers. I think that makes a lot of sense for open source approaches. And we've seen that played out, I think, unquestionably in open source software. And then it kind of allows you to focus on the value add. So in certain contexts, if you're not focused so much on kind of protecting or doing all of the things that will keep knowledge close to you, then you can really shift your focus onto how to share know-how, how to build collaborations and community, how to build trust and buy-in. And so I think those are some of the areas where open source works really well. And there's others where it's not so useful. So there may be a need for capital. Open source can be a route to profit, but it's often not a route to maximizing profits. And so that can be a challenge in terms of business models. Sometimes you do need to defend or control your intellectual property for a number of reasons. Sometimes it's to maintain values of quality, for example. I work a lot in thinking about distributed or decentralized manufacturing of research reagents and diagnostics, where quality is a really key factor. And also thinking about protecting the equitable distribution of your product as well has been used by some companies as a reason for maintaining control over intellectual property. That kind of, in essence, has little to do with some of the other motivations that are usually cited. And also, it doesn't work if it won't be used. If it's a distraction or no one's going to adapt or use it, the effort needed to document an open hardware project is effectively wasted, or any other kind of open source project. And so that goes back to this idea of kind of intelligent open source and really thinking about where the effort should most go. And I don't know what these sets of criteria look like for decentralized science, but I think it would be an interesting thing to think about for your own projects of, you know, to what decentralized science is an approach, I think, in the same way that open science is, and sometimes it's more effective than others. And so I already mentioned, but open science has tackled and not fully answered what I think are important questions for decentralized science as well. For example, for whose benefits and to what extent will this promote access and equity if those are your goals? They may not be the goals and you're applying the approach for a different reason. But for me, a lot of my work is around how to distribute biomanufacturing and biotechnology tools to promote equity, particularly in low and middle income countries, and how to create a kind of globally equitable bioeconomy. And so I employ open source approaches because, and a distributed approach, because that makes just the most sense in terms of the problem that we're trying to tackle. For example, I was in Argentina before Christmas, and we're looking at manufacturing reagents in country in Argentina in a kind of local production and distributed way. And economically, there's huge inflation, 100% inflation in Argentina, and issues with getting foreign currency to buy stuff on the open market. Biology is self-replicating, and if you know how to grow biology and make enzymes, then in principle, once you've got the strains and some fairly kind of basic inputs into the protocol, you have a reasonably infinite is entirely the wrong word, but effectively you can keep producing your reagents yourself without relying on people from outside to provide them for you. And so for a lot of my work, I consider decentralization and sort of distribution in terms of increasing autonomy. And for me, that's autonomy in terms of access to tools, and also autonomy in terms of the agency to shape the biotechnology field and agenda, because you can get on with your work and address the problems that you want to address without relying on international collaborators or funders to supply your needs. And so I sort of see there's a kind of a parallel in terms of how the decentralized science movement is trying to shift those power structures. And yeah, I'm very interested in engaging with you all today and taking some questions. I've tried to keep stuff short so that we can have a discussion, and looking forward to meeting you all. And I'll just summarize with, I think the common thread between these two approaches is that we're both trying to reinvent or reimagine knowledge production, and we're both applying kind of new technologies and tools to do that. And I think we both have some very common advantages in terms of the approach, but also some very common potential challenges and potential unforeseen consequences to consider. And so I really hope that the two communities, which already overlap to a reasonable extent anyway, can just continue kind of learning from each other as the decentralized science movement spreads, which I'm sure it will do in the same way that we've seen open science expand in the last decade, if not two. And thank you very much.
Thank you so much, that's fascinating. Okay, we have a couple of minutes for questions if anybody has. Yes, I'm going to pass the box back to you. I'll do half an hour.
Okay, thank you. So I find it really interesting how open science, I guess all movements start that way, looking towards the future, super, passionate and motivated. And then you get 30% of the way there. So I was wondering, what do you think is the biggest points in that like multiplicative factor that from the vision to 10 years later, what's actually realized? Is it regulators, pushback from institutions? How has that been for open science, and maybe how can we in DeSci try, and do better?
Yeah, I think with open science, it was definitely understanding. So open science had a focus on institutional science, which I think does make it different from decentralized science. And in institutional science, at least the open access, open data, and other movements that are really embedded, the people that have the power are effectively the funders and the policymakers that set the kind of national and international approaches. And so as soon as you get it into their policies and their funding, further down the chain, the institutions will typically kind of do what they're told. So understanding who has the power and attempting to make them change it. But I think that in a sense is kind of counter to what the decentralized science movement is trying to do. So open science really trying to centralized, looked for the central powers and attempted to change them. So I'm not sure you can follow that route, but I feel like that's really where it kind of, it managed to push things along. And then it continues to push things along, but now from a kind of seat of being more accepted, but not globally. I still end up in rooms with institutions and particularly technology transfer offices talking about their fears for open science. I'd say less so on the open access. I think other than the business model, there's limited fear of that. And there was a lot of fear in the early 2000s around open access. There still is some to an extent. Open data is a bit more tricky. But yeah, when you start talking about kind of open source, that's a real challenge to kind of embed in institutions, and we haven't cracked that one. So yeah, identify who you really want to move, and then have some targeted approaches to get to them.
Awesome, thank you.
Thank you. Okay, but for example, one more very quick question. This one. Yes, over here. Can you crowd pass or thread? Cool.
That was a good toss. So a lot of this comes down to capital efficiency, right? So where's the money coming from and what's the expected return from the parties that are providing it? And if we look at something like venture capital funded biotech, right, there's going to be expectations of return. So given there's a trade-off there between the expectations of funders and, conceivably the impact and the ability to decentralize and not expect that return, are there areas that you think you would be more open to DeSci or open science approaches that there's not going to be that expectation from the people funding it to get an outsized return back?
Yeah, it's interesting because I note that a lot, I guess partly because this event is at the Crick and just the nature of the people that I'm invited, a lot of biotech happening, and actually that's usually the field, despite the fact I'm in it, but I use as an example of a field that it's because of the capital return expectations, it's very difficult to embed ideas of openness, and I'm guessing decentralization as well. I haven't talked so much to people. I feel like that's not necessarily the case in all industries, and sometimes from the biotech end, we kind of get very blinkered in terms of kind of how business is done. So I feel like there's other industries that rely much less on intellectual property protection because they need less massive capital investment, right? And I think different levels of pace of innovation as well. Biotech is slow, typically speaking. Of course, many of us are working on making it faster. But I think one of the reasons that stuff has worked so well in software, and for example, artificial intelligence, of course, there's a lot of IP, but there's a huge kind of adoption of open science and also, I think, decentralized approaches. But partly because the innovation is just moving so fast, there's so little point in protecting something that's already going to be kind of worked around by 10 groups and completely transformed within the next 6 months. So I feel like anywhere where there's super fast innovation or where the kind of capital requirements are somewhat lower, and you can really then look at kind of as a business, if you're talking about business return, what's the value add? Because there are so many industries where money is made on marketing and branding and actually selling the product and the business functions, not so much on the kind of intellectual property around the product itself. So I don't have any specific kind of, you should be looking at this particular sector, but I think just rethinking the role of decentralization or open source in the business model and being realistic about where it's going to work and where it's not. I would love that, more biotech was open, but I think that it's tough. It's very difficult to get that to work for the reasons you said.
Thank you so much.
Thank you so much. Thank you for your questions, everybody. Thank you.
Thank you.
Okay, so next up we have Rebooting Science and Innovation Thanks to Communities by Thomas Landry.
We can say Thomas Landry. Do we have a plug for the computer? Oh yeah, it's one. Oh no. Oh no, it's here. Sorry. And then.
You'll have 20 minutes in total, including questions.
Sounds good.
So I'll give you maybe say my hand up when you've got 5 minutes left. Should I do that?
Yeah, thank you. All right, that's microphone.
Hi,
Is here.
Okay, so take it away.
All right. Hello, everyone. Can you hear me correctly? Yeah? Cool. So very nice meeting you all. Had a great day yesterday. Fantastic crowd. I'm going to share some thought about an experiment that I started about 4 years ago. It's called Just One Giant Lab, and it's kind of like trying to do DeSci without Web3 at first. And there are some thoughts and some learnings and some things I think that would be interesting for the whole DeSci Web3 movement to get. as I was saying, I'm the co-founder and CEO of Drogo, and I'm going to present you my own little story. So first, like a bit of background. I started as a researcher, an academic scientist in synthetic biology, but then quite fast, I sidetracked into exploring the DIY bio and biohacking movements. Back in the days, the very early age of DIY bio, back in 2009. That was for me my first experience of doing community-driven science. DIY bio at the time was very, very much of a small community, and we were asking ourselves questions like, what the future of biology, if we can do biology in our own bedroom, basically, or in our own kitchen. And so it sparked really a lot of different kind of perspective that other kind of perspective that you would normally have as an academic researcher. And really I found this fascinating and in fact so fascinating that I decided to leave academia for good. And so after this, I also started a company called PD with McDyess, but went back to exploring alternatives to the academic system and really pushing forward the model of community-driven science innovation with Drogo. So first of all, I would say welcome to the age of communities, right? It's a very exciting time. Even though communities have always been around, it's a very natural thing for us humans to come together, except that communities at the time, before the internet, were mostly local, right? At the village scale. But thanks to the internet, it means that we can actually feel more close to somebody that lives out, on the other side of the planet than your own neighbor. And really, this just changes everything. It means that we can now create critical mass of people, of similar-minded people, much more easily, and so we can, move forward on subjects that would have been harder back in the time rather than today. So new opportunities, and especially for doing complex projects like scientific research or innovation. And in fact, when you look at science innovation, I think you mostly be agreeing here, it's still a very boring process, very vertical. We are, at least in academia, we could almost call it a highway, right? It's once you take the highway, you have a few exits, but it's mostly all straight, right? And you're supposed to get to the end if you're not having any accidents on the road. And so the point is, I think most people here are concerned about this, is how do we destroy this verticality and decentralize the whole approach. And another aspect I'd like to point out is there is another goal for us to attain, is how to make science innovation more inclusive, more accessible, not in terms of access to information, but just who has the ability to express interest and participate in the process. Just here a few data. If you consider the amount of people that participate as an author in publications, it's about 9 million. That means that you only have about 1/1000th of the world's population that actually contributes to published science innovation. So it's very small when you almost have 3 billion people that got a higher education degree. So there is room for improvement. We can do much more. The question is how. Another thing is, you probably know about this graph, is pretty famous, but it also shows that within the system, the academic system, it can be challenging for even young researchers today to find opportunities the same way our ancestors back, like 40 years ago, for example, had before. Like the age, when you were between 25 and 35, the probability for you to get grants is very small. And I like to use an example, which is Darwin, even though it's very bad back in the day. But Darwin, started his journey on the Beagle at the age of 21. And so it would be, I think, very, very difficult to think that today somebody of the age of 21 will actually be starting a whole research journey. It's like finish your master first, right? And same for Einstein. Einstein actually published its main papers before the age of 30. So there is some here of to consider is how do we provide opportunities to people that requires them, basically. So, and then we have another trend, which is we're post-COVID, so now it becomes normal, but remote work and community interactions are really becoming a normal part of our life. And this is great again. And so what I've been interested in is how do we develop highly efficient communities that can work together on scientific projects and innovation projects. And really what we've been observing is in order to make this happen, we need to solve like many problems, especially if we want to work on complex projects. First is there's always like of transparency, as well of scalability. We need to solve this. And also, as I was pointing out before, of meritocracy. There is very much of an elitism aspect in science in general. Your original conditions really help design your own future, right? So is how do we balance that? And then a lack of trust. I've seen some people, especially in Web3, talk about trustless. I think this is a concept that very much cannot really apply to science. I think we need to build real trust, between individuals, and we can do that based on actual evaluation. I'm going to explain that a little bit after. That's the whole point of Drogo is to build the infrastructures so that the communities of the future will be able to lead scientific discovery, innovation and impact. And just to make a reference to the previous talk, it's very important that we don't try only to make things more efficient, but also like more fun, right? It's really, really important. And sometimes we forget about how important it is to have cohesion in the community so that we have fun together. I think a conference like this one is a perfect example of how we make this happen. So Drogo is not a new project. It's been launched 3.5 years ago in July 2019. It's already global. We have more than 9,000 members on the platform from more than 100 different countries. As I will show you some examples of project and its history and when it boomed. And you can start to imagine that most of it happened during COVID because it was the perfect use case for us. It's very highly interdisciplinary as well. And even though we, as biologists, most of the early projects and programs that we ran on the platform were about biology, I was very surprised that it grabbed the interest of many different kind of people. And so here you have the map, the skill map of the users on the platform. Somehow our goal is to try to set up an infrastructure to be able to host the ecosystems, the communities, wherever they are and however they are structured, that are working on science, innovation, and impact in a way that we can connect them afterwards. Because most of the communities we know, once you're in that community, it's very hard for bridging two communities together, for example. And so the point is, we need our own spaces, but we need also to have those bridges. And so it's all about those bridges that also we are trying to hone here with Drogo. So I'm going to explain a bit more like the whole concept behind this graph afterwards. By the way, I've made a little experiment. I've just created a space on the Drogo platform for DeSci London. And so if you want to try out the platform and you want to stay in touch with each other, I encourage you actually to scan that little QR code and register directly on the space and have a look to it. So here is a little graph. If you look at the dates, you could say that, okay, this is probably the explosion of cases of COVID somewhere in the world. You wouldn't be so wrong thinking this, but no, it's actually been the explosion of our users on the platform because of COVID. So 6 months before COVID happened, we launched the platform. July 2020, we have about 500 users and experimenting there and there. And then we decided when COVID hits, I mean, we exactly designed Jogo to be able to face such a situation. Like, how do we mobilize vastly, a large network of contributors that can work together on solutions to battle the COVID pandemic? And so we launched the Open COVID-19 program in the end of February 2020. And as you can see, it's just literally an explosion. And so it just shows that when you have when you offer like a door for people to express themselves and you give them opportunities to contribute, like they jump on it. It's really incredible. And so, and really at the time, there was no other really like places. Well, you had places for volunteering, and to help locally, but you didn't have like a place for contributing to actual science or innovation in a distributed manner. So it really showed that there was an eager to be able to do that. And so Open COVID-19 has been so far like the most successful program that we've run on Jogo. We mobilized more than 4,000 people, and more than 150 projects were done. And really the way it was organized is what we call as a giant lab. And the goal of a giant lab is to bring people and organizations together, and so these people and structure are able to share like funding, assets, expertise, and facilities. It's what we call support, and that support is only accessible for project that has been validated by the community, and that validation has been done by a proper evaluation process. And so the whole point is that we want to make this process as open, inclusive, and efficient as possible. And I'll just tell you how. First is we actually designed an original process, evaluation process that is adapted to community setups, which is what we call the community review. The principle is that you want evaluation that is normally a pain in the ass for any organizations to do, to make it like super streamless. We were in a pandemic situation where there was urgency. So we couldn't just create an evaluation process that would take months to take place. Also, there was literally thousands of people knocking at the door. So how are we going to recruit reviewers there to do normally their job? So we had to design an entirely new system. And the way we've done it is we actually asked the project leaders to be the reviewers themselves. And in fact, we made it mandatory. So, for example, if you're a project leader and you apply to get a grant and you have to be evaluated yourself, if you don't evaluate others, even though your project has been very well evaluated, you don't get anything. And so we ask usually project leaders to evaluate between 3 and 5 projects every time. And what that means is the ratio between projects and evaluators, reviewers, is always the same if you are at 10 projects or 1,000. So it's very scalable. And because it's mandatory, you can actually put harsh deadline, and people really are in the dynamic. So usually the deadline for reviews are like just 1 or 2 weeks after the deadline for application has been. That has enabled us to create also a new rhythm for evaluation, which is kind of like continuous, meaning that we had cycle of evaluation every 3 months. And this opens up a new model for funding as well. The funding is it was done thanks to what we call fast and additive macro grants. And so your project, you're going to apply, and maybe you don't make it, and that's fine. Normally, when you don't make it to a call, it's like, okay, I have to do something else because maybe there is no other code like this one, so I have to reconsider actually my project, whatever. Like it's like you're almost playing your life on the deadline. This is plenty wrong. So what we've done instead is, so you can participate, obviously, because you are also bringing value to the system as an evaluator. It's interesting to also have people that will not necessarily have like validated project to participate. But imagine your project is rejected. You get still to learn from the evaluators, from the reviewers, and also because you have started to interact with the community. You apply again 3 months later, and then you get it. In fact, we have so many examples in the Open COVID-19 program of projects that only succeeded in the second time, or even in the third time. They were like in the top 3 projects afterwards. So this enabled a learning process that was going to help so many projects that were not ready at the time of the deadline. The other thing is, because we use only small amount of money, microgrant, meaning like we don't provide like whole sum at first. So it's like we don't put all our eggs in the same basket. We're going to give microgrants in an iterative fashion. So what it means is, in the case of Open COVID-19, you will get up to 5,000 euros per microgrant. And if you had positive results, you could apply again 3 months later based on those new results, gets evaluated, and then funded again. And we had projects like that got funded 4 times, right? And so it really enables you to follow the project, and to have this continuous evaluation process. Second is, if a project doesn't work, it's fine. You didn't lose that much money, and you gave the opportunity for a group of people to explore something new. So it also de-risks a lot of things and enables you to fund projects that would not have been done or funded otherwise. And again, this is all about discovering talents, providing opportunities, being more inclusive. To give you some example, we actually funded a group of high schoolers in Seattle. The way it was done is, there were a group of 17 years old in Seattle. They wanted to design a software to help universities and schools to track COVID in their environment. And nobody was listening to them. They were a bunch of high schoolers, of course, right? So they came to Drogo, they created a proposal, they asked the community to review it, they got, validated. They thought that, okay, this is a great proposal, it looks very, very good. So they went above the quality threshold, they got funded. But the thing is, so it's not just funding, they got stamped, like validated by somebody that was an expert community. Thanks to that, they made a proof of concept. They installed it in one school. It worked great. They installed it in several other ones after, and they even created a startup thanks to this. And so it has completely changed it. I'm just providing them this opportunity. Another example is he's a lab technician in the Philippines, and he had an idea of to create a small system to do what we call genomic surveillance, basically to be able to detect the virus, the COVID virus in nature, in order to be able to predict where it's going to go next, and what kind of variance is out there. He wanted to do it in a suitcase for less than 1,000 euros, and completely openly as well. And so he made a proposal. It was just by himself at first. He didn't get it. Like the community thought that, okay, it looks interesting, but clearly not mature enough. It didn't stop there. What happened is, because the project was very sexy, he recruited some people from the community to work with him, and he got very interesting reviews on how to improve the project. He tried again 3 months later. He was in the top 3 project, got funded. He made a proof of concept. It was successful. He came back 3 months later with very positive results. He got funded again. So then he made a second suitcase. So there was 2 points to register data in the Philippines. That was so successful at some point that the National Public Health Agency of the Philippines heard of him, and is now actually collaborating with him, on projects. So it just shows that he was nobody at first, but because we gave him just a little bit of legitimacy and funding and an ecosystem to work with, he was propelled forward very much. And so it's plenty of stories like that. And so at the end, when you look at the impact of Open COVID-19, it's not much money that we have allocated to projects. It's 120,000 euros overall. But the impact that it had, at the end is drastic. So there was 22 functional solutions, like the diagnosis test, the genomic surveillance project I just told you about. Also, we had 3 open source diagnosis tests created. In fact, the 3 of them went to the X Prize in the semi-final, and one of them was in the final, just to show you that even though those projects were done in a community setup with not much resources, the way people were organized together was done in such an efficient manner, the level of collective intelligence was so high that they could compete with projects done by like very well-funded startups and institutions. Incredible. It's really incredible. The 10 papers published, but what's interesting as well is the level of diversity. So almost half of the funded projects were led by women, which is much higher than what you normally find in innovation programs. And also we had basically people from all continents. So it was, with not much resources, the impact that we had was massive. In fact, when you look just at the yield, if you take like the amount of funding and the impact it had, not just on science and innovation, on knowledge and people's life, Thank you. It's like we almost could say that this approach really is almost 10 times more efficient than what you normally find. And so our goal is now that how do we push this way of doing things, to other places, like to other communities, to other institutions, to other organizations. And so it's exactly why we are here at DeSci London, is that we've been experimenting with communities, and you are all trying to build communities yourselves. And so we know how hard it is. And so with Jogo, we are building the infrastructure to host your communities and to make them more efficient so that you can focus on your goals. So we'll be very, very happy actually to work with all of you. Jogo is currently Web2 based, but is in the process of integrating the Web3 elements as well to make us compatible with DAOs as well. So we'll be very happy to talk to you. Thank you very much.
But maybe just have one very quick question. Anybody has one? If not, we yeah, in the back there. And just to say that if you, we have the DeSci London Jogo community, and we're going to post details to join there if you didn't quite catch it on the slide. They're not, there's a question, okay. Okay, there's one down here then.
Yeah, thanks for the talk. How do you raise funding to fund these projects? I mean, where does the 120,000 euros come from?
So in the case of Open COVID-19 and other kind of programs so far, Jogo is currently a non-profit, and the process of also for the project, for the platform to become a for-profit on the side. It's been mostly through philanthropy. So we raise funds at foundations or public institutions. But it's the way we want to make things happen in the future is to make this more scalable. So we're actually working on elements to enable financial management as well for communities on Jogo, because Open COVID-19 was funding, even though the responsibility, like the evaluation of projects, the support of projects was done in a decentralized manner, the funding was not done in a decentralized manner. Like we had to go look for funding. And so if we could find ways, and that's what we're working on, for the community to be also responsible for bringing the funding, that would be absolutely enormous. Because we were the bottleneck, basically.
Great question. Thank you so much again. Okay, so if you can all be back here for 11, we've got a panel on ethics and DeSci. Hi everybody, so we're just about to start again. So I'm just going to hand it over to Josh, this is the panel on DeSci ethics.
Hello everybody. So thank you, Sarah. As mentioned, my name is Joshua. I'm the founder of DeSci World, and today we're talking about ethics in DeSci. So currently in pretty much every walk of life, in industry, corporate industry, there is ethics in DeSci. So currently in pretty much every walk of life,
Just stay quiet and see what
Try again.
test. Hey, so today we're talking about ethics in DeSci, and basically in pretty much most walks of life, especially corporate industry, there is some kind of ethical review board or some kind of code of ethics. You have it in medicine, you have it in data science, you have it everywhere. Currently in DeSci, a very nascent industry, there isn't really a code of ethics that anyone has come up with, that the entire space agrees with, or even multiple different projects agree with. So I think it's important that we discuss this with the leaders of the space here, about what is ethics, what it means for DeSci, and how we might implement an ethical sort of framework for the space. So I'm going to pass over to the panelists to let them introduce themselves. I'm going to start here with Martin.
Yeah, hi folks, my name is Martin Codire. I'm one of the co-founders of Fleming Protocols, and we're kind of allowing patient groups to leverage their desire to solve problems within their domains and all the data that gets produced during clinical interventions, and then leverage that to expand the product into a more commercial offering. I'm a neuroscience and engineer by background, and I'm very committed to the patient perspective of things. So I'm really translational. I view all sides as, from my perspective, as that how does that get translated into an outcome for patients, but also for society in general.
Yep, this is great. My name is Chris Burns. I'm an IP legal advisor at Molecule and an IP lawyer involved with a number of the different BioDAOs that we see emerging. My background, in addition, I have a physics background, and my sort of IP law work arises from that space. But I have a master's in theology, in religion, ethics, and politics as well, which doesn't always come in so usefully for being an IP lawyer, but delighted to be on a panel where we can talk about ethics and DeSci without even me having to just be talking about IP all the time. And so I'm particularly interested to that sense in how the property rights that arise from decentralized science, things like IP, but the cultural movement behind DeSci more generally, how it can be encoded with ethics and with ethical encumbrances that are actually contractually enforceable. I've done a lot of work in the human rights space and with environmental protection as well, and there's a lot of in centralized government, or with centralized business, corporations will oftentimes want to take an approach to corporate social responsibility that just becomes a pledge and isn't binding. I'm really excited about DeSci in a way to change that.
Thank you. I'm Nicholas. I'm a founder of LabDAO. I'm a physician by training and a computational biologist. At LabDAO, we care a lot about making tools available for scientists all over the world to especially run computational biology workflows, but then also give them the availability of wet lab resources when they have a test. So usually, if you were a computational biologist, you could work from wherever you are, but only for so long as you really want, as you sort of hit a point where you want to test your hypothesis, you need to find someone with access to a physical lab to collaborate with. And we want to make that way more easy for the computational side to find someone who can do the work. And then obviously, we have questions around who should be able to have access to physical laboratory space. What is the biosecurity risk of giving like broad access to some of these resources, and then on the other hand, also some questions around IP. How can an online community or an actor within an online community that has done most of their work within a Jupyter notebook, how can they capture some of the value? Is IP even the right tool for that, or should we just think about basically software companies? Those are some questions that we think about quite a bit.
Hi, my name is Rami Kini, and I'm the core lead over at Athena DAO. We're a decentralized community working to fund women's health research. For us in the DAO, one of the biggest things that we think around ethics is the fact that women's health data is very important to be protected, especially because of reproductive justice. So when we're thinking of data assets, we're also thinking how are we going to make sure that we protect this data. What kind of new technology can we use to make sure that it doesn't get used for surveillance, especially in certain markets? So I'm glad to be talking about this particular subject today.
Thank you. So as you can hear, there are many different ethical considerations for this space, each individual to the project. So the dictionary definition for ethics is the moral principles that govern a person's behavior, or the branch of knowledge that deals with moral principles. This is a moral question largely, but also comes down to much more specific areas. Each project here has just mentioned IP, we've got data protection, we've got handling of data transfers. So I'm going to ask everybody here on the panel to briefly define ethics in DeSci, what it means to you, what it means to your project.
Yeah, I sometimes get confused between the difference between ethics and morals, actually. But from my perspective, I look at things from with the patient side of things as a risk-reward payoff. So what level of risk is a patient willing to take personally? But also, I've seen a lot of projects kind of get stalled because the institutions that kind of traditionally deliver or disseminate technologies are concerned about reputational risk as opposed to actual risk to the patient themselves or their health risk. And patients aren't really that concerned about reputational risk. They want to see products that help themselves and that cure diseases, really. So I think that there's a line there that you have to kind of acknowledge that patient groups, we want to see celebrated entities taking risks, reputational risks, because without taking those risks, we're not going to figure out what does work in humans. And I was chatting earlier on to people about the gene therapy field. The gene therapy field suffered a major setback about 10, 15 years ago, with a famous case of a guy called Jesse Gelsinger, who was one of the very, very first patients that was ever involved in a clinical trial. And unfortunately, this guy died. He was one member of the trial, and he died because of a specific, I think it was a mutation in one of his genes that didn't function well with gene therapy. But this held the entire field back over 10 years, and no one was willing to touch it at all because they considered it too risky to their careers. Now, this patient was only one of quite a few, and the therapy actually worked in quite a few of the other members of the trial. So you've got to look at that and say, well, why are we 10 years behind the curve with gene therapies because of reputational risk for the entities and the people that were trying to do this? Patients don't really care about that. They care about personal risk. And in this kind of research that I was doing around this, I found a term called micromort, which is a 1 in a million chance of dying. And on any given day, all of us experience 1 micromort. So if you go for a skydive, that's 10 micromorts. A general anesthetic is also 10 micromorts. So you're basically spending 10 days of your life doing taking risk. You're accelerating that in 1 day. And that's a framework that I actually like to think about within, is it ethical to put a patient at risk of a certain number of micromorts, given that a lot of those patients would do skydives anyway, so they're taking risks with their bodies anyway. So I like to almost quantify it in that regard.
Yeah, so I mean, when you're sort of debating whether or not accelerationism is something that should happen or not, it's not specific to ethics, it's specific to all walks of life. Accelerationism is something that we consider quite, it's got its positives and its drawbacks. However, when it comes to DeSci, a lot of this data, a lot of this work is being done in particular with patient focus, medicine, healthcare, and accelerationism in these areas does bring a lot of ethical considerations. And Martin has given one side of it. I'm going to warn you, I don't think this panel will come together with a final solution on what ethics should be, but it's important to raise these issues and to see all sides. Laura, can you please tell us what Athena DAO, what ethics means to Athena DAO in particular with women's reproductive health?
I would say that one of the most important things is that women do get the upside of things rather than just being exploited for either the data or consumer as. I don't know if you saw in the chat yesterday, I showed you this product that it was $2.99 to test menopause. It's not, we were talking about why this is not an effective product, and it's just more of a gimmick, something that we're selling to women because they're desperate. They want to know that they're going through that period, nobody's giving them enough information, so they'll buy those products that in a way exploit them. So a lot of what we think about is how can we work with researchers or startups that are really trying to do this to help women rather just to make money from women. And then there's the aspect of, as I said, reproductive justice. In the US now, some of the apps were actually tracking data that they were selling for when women were having their periods. And this is a way to monitor women. So when we're thinking about research and collecting data, is how do we protect this women's data? How do we make sure that it's used for something that benefits them rather than just benefit companies? And I'm not against companies or actually having businesses, but how do we make them better for women in general? Also for the researchers to get the upside from their scientific research. I think one of the big things that happens is that sometimes scientists don't realize they have a gold pot and somebody who's doing business study comes and takes it over. How do you actually give them the tools to protect their IP, their intellectual property, and their research in a good way? So one of the things that we're discussing right now in the DAO is what is the limit of what we show to the community, because some of this research is proprietary. So you cannot be voting on things that other researcher could come and adapt and then make it his own research. That's one of the big things that we're discussing.
Chris, maybe you could touch on that a little bit about the IP in particular and sort of protecting that and the ethical considerations for a decentralized infrastructure in protecting that IP.
Yeah, definitely. So the World Intellectual Property Organization estimates IP in the modern economy to be worth around 63 trillion. It's about 80% of the balance sheets of all Fortune 500 companies. And that's changed dramatically. If you look 40 years ago, intangible assets were maybe 20% of the balance sheet. But we're in this economy now where intellectual property is probably the most pervasive, dominant asset class in any supply chain, in any value chain. And from an ethics perspective, I think we have to ask, one, we need to locate ourselves in the system, and all of us, I'm sure, in this room, our paychecks come because we're IP producers in some meaning of the word, at least from kind of a political economy perspective on the law. All the knowledge we produce, everything that we're doing in DeSci is how to democratize IP, co-govern IP. It's all built on a technology platform that, again, itself is IP protected. The ethical debates to date in the pre-kind of Web3 world have largely been about how do we privatize and maximize, and we see all types of concerns that arise around monopoly pricing coming from large pharma, other things like this. And then the alternative is sort of this digital flip to just saying, open source everything, put everything into the public domain. And there's an ethical position that anyone takes by nature, really by whether one chooses to have the terms upon which we create, the terms upon which we put our intellectual property into the economy have ethical implications. And I think where we can go with Web3 and with DeSci to make a much more robust and kind of interesting social conversation than what had happened in Web 2 and with really free and open source software, is to start to really think about structural inequities in the economy, things like patterns of disparity in pay between, gender bias, who gets to benefit, maybe connecting things back to historically marginalized communities who've long been stewarding the knowledge that is now being sort of commercially developed. We see this in psychedelics come up often. I really think the key thing from an ethics perspective, in DeSci from an IP perspective as well then, is really to think critically about what are our own terms of creation. What conditions and encumbrances might we want to put on the intellectual property that we create and co-govern and co-steward in a DAO, and actually put those conditions explicitly, put them onto IP licenses, and see how we can start to transform the broader economy with these strategic economic interventions into things that are really about structural bias.
Yeah, thank you. What you mentioned about making a choice between whether or not you go to a traditional IP route or you go through an open sourcing route, this is a frame that we've sort of been born into, and the idea that I would like to see with DeSci is to maybe redefine this framing such that IP could be a different concept that doesn't require full, continuous, multi-year ownership dedicated to a single person or a single organization. What open source doesn't necessarily mean giving up all of your property straight away for very little fee. I know, Nicholas, at LabDAO, you guys have a lot of considerations about this open sourcing in terms of safety. Would you like to touch on that?
Yeah, I can talk about safety, but maybe for a moment I would actually like to stay in that topic realm because it's very close to us as well. So one of our core activities is we go and we curate work from machine learning and computational biologists, oftentimes grad students if they would these under an MIT license. And this work is extremely valuable. It's fairly consumable. There are a lot of companies, oftentimes located in countries outside of the region where that work was done, that take advantage of that work. And to take advantage, I think, has to be said carefully. It's not in the sense that there's any bad intent here. It's just this is an extremely useful tool that accelerates humanity, this ability to solve some of the trickiest problems, and there's a lot of value that's created. Something that I have been struggling with personally has been the question how can I still share publicly, but I create a unit of account for what I've done and what I've shared publicly. And I think Web3 has just been this really interesting testing ground to see what happens when we create new units of account, new tokens of account, while radically also sharing everything open source. So Vitalik Buterin has this blog post which got relatively famous. It's called "Legitimacy is the Scarcest Resource." And I'm just giving a quick anecdote here for everybody that's new to this particular field. There's a technology that's called automated market makers. It's a way that you can swap tokens one for the next. The first one, the team that really built that first iteration of the code was called Uniswap. And then a couple of weeks later, a competitor came along and basically copied that code, made some small changes, and it's called SushiSwap. Now, people are still stuck with Uniswap, although there was really no economic reason why they should have stayed with it. And this is really, I think, legitimacy, and everybody has a sort of sense of ethics and has a sense of, okay, this is the team that has sort of developed the technology initially, and they have a certain amount of legitimacy in being the ones that keep driving this technology, keep driving this product forward. And if I own this particular token, I actually share more in the value creation, although there's been a competitor on the place. And I think if we can get to something similar, and with just generally the way that we create open source software, I think it would be a really interesting experiment to see that if a graduate student or a postdoc creates a really interesting model at a hackathon or just during their studies, and they launch some kind of impact certificate, similar to the way that we issue carbon certificates for that particular work, then that could be a shelling point of preferential attachment of capital and other resources around that work, where people say, yes, you might be a junior PhD student, and yes, you might not have the business acumen, but you have an asset that I can attach value to, and I'm concentrating around you, and I'd rather want to work with you than sort of just command C and work with it somewhere else. So this was a sort of a bit of an exploration to the IP space where I'm really interested in finding ways in which we can, also change the way that we think about IP and use tokens as sort of the carbon certificate of intellectual property. The next the next question you asked was the biosafety. Now, actually, I think there's the good news is there are laws, and people have thought about this for quite some time. So, first thing is you adhere to the law, and a lot of the ethical questions are sort of taken care of in that way. You have to know who is using any particular, especially physical tool. So people need to be KYC'd. They need to know who they are. In certain instances, if they want to do certain work, they need to have additional qualifications. And I think what I believe is extremely exciting is to look into technologies that enable one to demonstrate the certificates or whatever attributes one has that allow one to use certain tools in a way that is more and more independent of the sort of intermediating institutions. For example, we all usually, when we go through a graduate school experience, one of the reasons why we do that is because maybe we want to apply for public grants to eventually receive funding. However, you could also argue that someone who has 5,000 stars on GitHub should probably be able to write a grant application to the NIH and get funding for their work. But right now, 5,000 stars at GitHub is just not it's not a verifiable credential to apply for a grant. So both in terms of biosafety, but also in terms of economic and sort of creative opportunity, creating on-chain credentials is something that I'm really interested in.
Yeah, thank you. We've had quite a few people here today talking about on-chain credentials. Jan, you might see him. He has a fantastic project you should ask him about. This idea of sort of having an on-chain credential system, a KYC system that abides by the traditional legal system, is what we adhere to now. However, in the decentralized space, there is a good chance that anonymity and distribution of open source resources and open access through transactional infrastructure will allow people to take part in some of these activities without necessary qualifications. I like, Nicholas, what you mentioned about Uniswap and SushiSwap. So this idea of taking a single piece of code, forking it, and then it being reiterated multiple times. SushiSwap was the most popular reiteration of Uniswap's code, but there were hundreds really of different reiterations of this, which came and went. The social consensus from the community was that Uniswap was the most, it had the most integrity, was the best run, had the staying power. So people use Uniswap. SushiSwap was sort of alongside it. So this kind of leads to the question: who decides where the staying power should be? Who is the moral arbiter of the space in DeSci? Is it the people within it that operate in it? Is it the builders, the founders of the projects, the people sat here? How do we decide as a decentralized space with complete freedom and sovereignty to decide on a collective code of ethics, which in a traditional system, the law or other sort of legal structures would probably enforce, but in a decentralized system, how do we come to some kind of consensus?
I think that what I kind of see a little bit happening within the DeSci world, a lot of the things that we're facing have been addressed already by the traditional academic world and translational world, etc. And there are well-established norms and regulations around this, which I think we have to, for the most part, adhere to. And it's a bit like also in the DeFi world, they're kind of now figuring out that all the rules and regulations and these things were in place for very good reasons. And there's some reinvention of wheels there. And I think that we can learn from the traditional world and what's already in place. And we need to kind of look at that to start with. But then we also need to be very collaborative, really, and talk openly together about this in very open forums, such as this. And come together to agree on how we're going to handle all this. I think that even in different countries, you're going to have different ethical norms, and what's good in one place might not be acceptable in another country. So that's going to have to be factored in. And, you know, again, kind of from my perspective, we want to drive this into solutions for society. Patient diseases is my particular focus, but it could be something like better photovoltaic cells, better battery chemistries, etc. And all of these things, you know, there are actually already initiatives amongst us all to sit down and talk about this. You can find them online. But I think the most important thing is that we're continuing to be collaborative, meet up, discuss these things, and learn from the traditional existing things that are in place.
Unfortunately. So ethics is something I think we could talk about for about 3-4 hours at least. Unfortunately, we are at the time for our panel, so I'd like to say thank you to all our wonderful panelists for coming and talking so eloquently about ethics. If you are interested in being a part of this collaborative sort of experience that Martin just mentioned, after the lunch break there is a DeSci ethics workshop on the other stage, which we will be collaborating with the people that attend to try and create a sort of preliminary framework for ethics in DeSci. So please join if you're interested, and thank you everybody for listening.
Hi everybody. So we're ready to start the next panel on time. Good. So the next panel is called DeSci Bulls and Bears. So we've got Julia, Laura, Lena, Matt, and Sean on stage. So over to you, Julia.
Hi everyone, it's very nice to be here. I was so blown away yesterday. I came to see Alok's keynote and I thought it was really inspiring. And yeah, the DeSci London crew have done an amazing job organizing this conference. So yeah, we're really excited for this panel. It's as Alok said, who cares about investors? But it's absolutely true that the most important people in the room are absolutely the builders and the scientists. But this is just really to give you a flavor of the investors who are based locally or in Europe who are really interested in this theme and who are available to you if you have ideas that you want to be exploring, developing, and seeking capital for. Obviously, venture capital is only one type of capital. You obviously have grants and other forms, but this panel here will really just focus on the VC side of things. So just by introducing myself, I'm Julia. I'm a partner at Local Globe. We are based across the road from the Crick, so we're super local. And we are, we're one of the funds that are invested or that are interested in this theme, not yet invested, but are very curious. And just to introduce my lovely panelists who are joining us, Lena from Stride, we've got Max from Amino, Sean from BACT, and Laura from AWS. So I'm going to go and ask each one of you to introduce yourselves, your fund, what got you interested in DeSci, and I guess some of you have made investments in the space already, so maybe a quick word on those.
Perfect, thank you, Julia. Hello, everybody. Lena from Stride here, operator turned investor, scientist back in the day. Stride, we are artisan capital, so we're small, nimble, real fun. 100 million AUM based in London. Really have this operator mindset, investor skill set, as we say. Most of the investment team are ex-operators, so we love helping to build companies. And at the end of the day, it really is about people backing great people and builders that want to solve big issues in the real world and talk about a more fundamental issues and industry that we have in science. So very excited.
Max from Amino Collective, quite similar CV, I guess. Scientist, spent 5 years in academia in synthetic biology, then I became an operator, 4 years in the startup world, and then VC full-time with Amino Collective based in Berlin, pre-seed and seed stage. Anything in between health and bio, really, with so far one investment in the DeSci space molecule, which you've just seen Chris on stage. I'm sure we're going to talk a little bit more about that at a later point.
Hi guys, I'm Sean. I'm from BACT. So I lead the Web3 investment team at BACT, and I used to be kind of similar but much lower background than you guys. I did a lot of researches at Imperial before, in the UK dementia research center on EEG, sleep, and Alzheimer's diseases. And I did that while I was in uni. At the same time, I funded my own startup, exited my own startup, and also founded Imperial Blockchain Society. So if any of you guys are interested in Web3 at Imperial or any of the London universities, feel free to contact me. And then after graduation, I just joined BACT as a fund. We are a small seed/pre-seed focused fund, 200 million AUM, and we focus on 3 pillars: Web3, biotech, and AI. So we also invested in Molecule, which you've seen Chris on the stage. Yeah, personally very interested in DeSci because when I was doing researches, I realized there was a lot of opaqueness in the space and a lot of incentives that we could design around to overcome these challenges. So excited to see how the space goes, and on to you.
Hi, I'm Laura Modiano. I'm not an investor. I work at Amazon Web Services. However, I do work with investors, and we do have a lot of programs for founders. So my team is business development. We work with investors such as yourselves. I work with all of you. I very happily interact with Lina very frequently. So the way that we work is we support VCs and then their portfolio companies to get them from founding to commercial success in every way that we can. We have a lot of programs specifically geared to founders that they get specific support, specific access to programs because of the investment they have through VCs. In addition to that, we have multiple accelerators. So very, very early stage, we have the Startup Blocks Accelerator, which helps you to ideate, build, grow. We also have a lot of training, and then we have impact accelerators, fintech accelerators, healthcare life science accelerators, health equity accelerators, which is very related to DeSci. And we're launching other ones in the process as well, specifically in Web3, in partnership with VCs. So we're very linked and an extension to the offering of investors, getting startups ready for investment in the case of it.
Did this one work? This one? No? Yes, great. Lina, I just wanted to ask you, I know that you've recently made an investment in the DeSci space. Just for everyone, maybe you can give everyone a sense of the company and I guess your process for getting to conviction within the context of Stride.
Sure. So it's still not been announced, so words kept secret. But you know, having done a bit of neuroscience and pharmacology back in the day, I think the challenges, you know, the reproducibility crisis that we have, and it really is a crisis, has always been top of mind. 60-70% of research that cannot be reproduced done in the last decade. I mean, show me another $1.5 trillion industry with such a massive inefficiency rate, right? It's crazy. And you know, it is a complex, multifaceted issue because there isn't sort of, you can't fix one little thing because that's going to have a knock-on effect on something else in the system, right? So it does require a certain level of ambition and the technology as an enabler to really recreate and try to recreate an entire system. And so, and then we look at science, right? I mean, it has to be fair, right? Findable, accessible, interoperable, reusable. And then you look at blockchain and the underlying, you know, distributed ledger, and you're like, oh wow, like this is literally a match made in heaven. And so, in terms of, you know, a project that can really reshape an entire industry, I mean, it's a huge lift, right? Like we're really tackling here not just the way academic research is shared, but also peer-reviewed and ultimately funded. It's a big lift, but if it works, I mean, we talk about building iconic companies, right? So definitely a journey into where generalists fund. So, you know, it's good luck kind of explaining all those nuances in science to your partnership. But then, you know, having incredible founders definitely helps. So, so here we are, very excited.
Great. I mean, Max, maybe I can ask you the same question from your perspective on how you build conviction in Molecule, and maybe give some of the background, because I think you invested in the very first round. So there was, you know, it's still a nascent space, despite the level of interest here, and lots of people who have attended yesterday and today shows just how much interest there is in this area. But at the time, yeah, it would be great to just hear the story, the background, and what got you to conviction at that point in time.
So Amino invested in Molecule 2.5 years ago, which in DeSci terms is an eternity, I think. And there was an almost infamous meeting between Manu, our fund manager, and Tyler, one of the co-founders of Molecule, in South Africa. And I think they were both on vacation, but you know, they managed to meet up. And it all boiled down to, I think, two aspects of our investment thesis. There's, we either want to back companies that can create a category or companies that can win a category. And in the case of Molecule, huge question marks, of course, but the potential to do both, really. And since then, we've just seen the development over the past 2.5 years and seen the amazing projects that are adjacent to Molecule that finally want to maybe, put IP NFTs onto the marketplace that Molecule creates. And it just turned out to grow into what we see here today, basically. So we, with a lot of conviction but big question marks, we continue to observe the space, and since then, really, our conviction only grew, and we're now ready. We're about to announce Fund 2. We're ready to double down on DeSci, really. So I guess in this pre-seed stage, you need to take these kind of risks, and in this particular case, it really paid off, because now we feel like we're ahead of a lot of other funds that are now starting to maybe briefly look at the space and already have a great network of operators within DeSci that we can ask when we don't understand something, which happens a lot.
That's great. That's great to hear, and I think it has been really. I mean, it's phenomenal to see that the expansion of Molecule. I was, been wondering at what point in time do you think that they reach product market fit, which may be an interesting question to come back to, but Sean, when we were talking initially about this panel, one of the things that you mentioned you were really interested in particular around DeSci, removing publication bias, and wondering if you can elaborate on that a little bit, or share your perspective on your journey with Molecule, whichever.
Yeah, okay, cool, yeah. So this publication bias is one of the things which I've noticed when I was doing my researches back in the uni days, which is basically that we had a lot of data, but a lot of these data weren't pretty. So, in order for us to publish a paper or get some sort of citations by other people, we want to make sure that the data we publish is pretty. And then we just do all sort of things to make it pretty. But then, with that, a lot of the data that you publish isn't exactly the data which you've got. And some of the uglier data, you just discard them, or you pretend they don't exist. So that's a problem, because a lot of the times that also forces kind of people, researchers, to chase for better and better results. But then not everything is going to be perfect when you experiment, and you're supposed to make a lot of mistakes. So that's essentially what publication bias is. You're biased to publish what will make you go on a research paper. But is there any ways for us to design a system to incentivize people to publish those data which aren't perfect? That's one of the things which I think DeSci has the capabilities to do, because all of the data, even the failed data, have some sort of values in them. But who's going to buy it? What's the liquidity market here? The market for a lot of the research data at this point is rather opaque. So there's a limited amount of buyers, sellers, and what if we could open it up to a wider market? And would that help with publication bias? To be fair, we don't know yet, because the experiment is just starting with whether DeSci could help with all these things. But hopefully one day, with all of the incentivizations around how we could purchase data, incentivize people to publish all of their data instead of just the pretty data, would help us to form better results or conclusions around certain researches. So that's kind of the idea about publication. In terms of Molecule, so to be fair, when the fund invested in Molecule, I wasn't in back yet. From what I understand from Molecule, the IP NFT is going to be quite huge. And the reason why I say so is, for example, when we go for funding for a certain experiment, I think this goes with every single research institutions. part of your funding is going to go to the school or go to like whoever the administrator is. And also part of your publication results, part of your IPs, part of your future incomes is going to be shared with whoever the school name is. For me, that was the case for Imperial. And to a point, that was fair because they did help to provide us with a platform to research. But at the same time, a lot of these IPs weren't controlled by us, it weren't controlled by the researchers, it was controlled by whoever the name was for the research institute. And for a lot of the scientists, it's probably not fair, spending years on research just to get your IP controlled by someone else. So with IP NFTs, we have more flexibilities around how we want to control the IP. Doesn't mean that we could control it, but it just means that we have more options around how we want to structure our IPs and rights around researchers. So that could potentially also encourage more research fields to be developed, more research interests to be developed, and therefore potentially also propel the researchers to be produced at a larger scale. So that's kind of the reason why we keep on backing Molecule, and we hope to continue the journey with them.
Thanks, Sean. And Laura, I guess in your role at AWS, you get a chance to work with a lot of different types of companies, and for the builders in the room, how do you work with companies in helping them grow and scale, and in particular in the DeSci space?
Of course, thank you. So first of all, we want to see as many startups created and also become successful. So we have sort of a three-pronged approach. First of all, we want the founders to have all the right tools, resources, right infrastructure to build, to train, for us to help them get trained, to get certifications, to get the right tools available, the right infrastructure. We want them to become commercially successful so that there are more stories that both are inspiring but also being told within the space. And we want return on investment to the investors so that there is continued funding that goes back to support the community of founders within the space. Specifically myself, so I, until recently, was head of healthcare life sciences development in EMEA. I'm part of a broader group that looks at vertical success. We also have a Web3 team in the space. Everyone in both these teams are ex-operators, ex-founders, have deep sectoral knowledge. We have people who are biochemical engineers, researchers, geneticists. Myself, I used to be head of strategy for genetic testing in England nationally for the NHS. I used to work at UCLH. I have a colleague here, Alex, who you should talk to, who also comes from the lab space himself. Everyone in my team was either an ex-investor, ex-founder, ex-researcher, or clinician, etc. On the Web3 space as well, we have, again, ex-founders, researchers. We just hired a European-based or an EMEA-based Web3 team, someone from OKX, that really have a very, very deep knowledge to give advice to founders themselves, but also to talk to investors about honing the thesis, advice on where things are going, and to look at scale, not just at each specific company. So we can go in, we can look at what you need to build, we can look at total cost optimization, we can look at data structuring, we can look at the right tools, whether it is compute, storage, AI, ML, infrastructures. We have more than 200 products. Now we have the Amazon managed blockchain solutions for enterprise to build on blockchain specifically. We have accelerators, as I said earlier, Startup Loft Accelerator, which is taking very early stage founders, specifically within this space, trying to build and get ready for investment. So we really focus not just on the generalist, but on the very specific, and then amplifying all these stories with go-to-market, with partnerships, with the Amazon Partner Network, with Marketplace, to find every potential opportunity for commercial success and growth with people who specifically care about healthcare, life science, and food.
Great, and I guess maybe bringing it back to what's been happening in Web3. This is, I don't know who wants to answer this, but I guess occurrences in the Web3 space, have they impacted your conviction in DeSci, or how are you thinking about that? Maybe Sean, you are given how close you are from your crypto perspective, how do you think that influences DeSci as an investor or as a builder?
Yeah, so Web3, of course, has gone through the roller coasters in the past probably 2 years. Personally, I started in crypto back in 2018 when I was in high school, and everybody around me was just talking about how Bitcoin was going to the sky. And I bought some Bitcoin and I lost most of my money during that investment. That was a very painful lesson to learn. But then that was when I started to look at what else is there in blockchain beside Bitcoin. And I think we're just at the same point right now where you see a lot of newcomers coming to this space and they start to look at what's there in blockchain. And so this is why during 2018, 2019, and 2020, a lot of great startups in the space were born. And that's because that not only the fact that people who came into the cycle and decided to stay start to innovate, but also people who are investing in the space or looking around in the space are starting to explore more opportunities rather than those Dogecoins or like Ethereum or whatever, right? Ethereum is great, by the way. So I think it only helps people to put more attention to what else is there in blockchain. And for me personally, I don't think blockchain is, necessarily the next revolution for the space, as people quote, or like exactly the next revolution for the internet. But for sure, there are many benefits where we don't really see in the current internet space, such as say a lot of the things that we do in science, to be fair, is quite, like based on your relationship with somebody else or based on your connection to somebody else. So could we potentially make that more efficient in this space? That's one of the things which I think blockchain is going to be able to solve. And with a lot of encryption technologies in the space, I'm really optimistic about how we can potentially protect people's data. So data privacy is another thing in science, right? And that's something that with ZK knowledge, zero knowledge proofs, and so on and so forth, we can potentially overcome. I just think as a fund for Backed, if anything, the crash last year really helped us to kind of reiterate our focus in Web3, because a lot of the valuations have started to come down. A lot of the tourist money started to exit the space. A lot of the tourist founders started to exit the space. So whoever stays now is likely going to be who's going to be committed to the space. So it also helps us to pick better deals. And personally, as someone who's been in the Web3 space for some time, just based on my knowledge about how the space goes, I believe there will be another bull market to come, and it's probably sooner than people think. I just think Web3 space right now is kind of at its trough, if anything. We are going to see further declines for sure, but it's not too far away from the bottom. So I think that the space has a lot of potential, and a lot of great companies, especially in DeSci, which is just starting, is going to start to emerge in 2023, 2024. And we're so excited to see these founders to be in this room today and also be around the world for us to find them. So yeah, that's our stance.
Thanks, Sean. I'll come up to ask if anyone has any questions shortly, but just wanted to ask if anyone is looking to get in touch with you, what's the best way to reach out, and what are the kinds of things that you're looking for, if anything at all, to guide these founders?
Best you just grab me here and the rest of the panel, I guess. Otherwise, max@aminocollective.com. We are looking for all sorts of either picks and shovels ideas to really further accelerate the space, or more vertically integrated projects. We've heard from a lot of amazing DAOs that really zeroed in on very specific problems in the health space and beyond. This is all super interesting for us. My background is again in biotech, biosynthetic biology. So if you throw in the right hype terms, I'll probably get very interested. So yeah, happy to talk.
Likewise, Lina at Strive.vc, ping me anytime. I think just building on what Sean was saying, these hype cycles, I think of it as like black tulips in the Dutch Golden Age. It will come and go, but real builders solving real problems, difficult problems in the world, that will maintain and that will get funded. And I think at Strive is something, we didn't really jump on crypto, unlike some other funds. We didn't invest in NFTs, we didn't participate in ICOs, and I think it really is about those, mission-led teams that are really solving things that matter in the world to create a positive place for all of us. So ping me anytime.
Yes, Laura. And Sean, yeah.
Okay, cool. So you could just find me on our website, Back to VC, and if you go to I think it's team or whatever that's called, you'll find my contact there. Otherwise, you could just find me on sean@back.vc. In terms of the investments we look for, anything in Web3, we look at them. And of course, anything in biotech, we look at them. So in that case, anything in DeSci, we look at them. So if you're building DeSci, feel free to just get in contact with me. For us, it's not only about investments, but also about helping founders to potentially find better product market fit. So if you have any ideas that you want to walk through to see whether it's commercially possible or whether this idea will make sense in the space, what else do you need, or what sort of hiring process you need to go through, feel free to just shoot me a message whenever. Yeah.
Hi, you can find me on LinkedIn, so Laura Modiano, and my email is a bit more complicated, it's elmodian, without Renault, at amazon.com. There are 4 incredible investors here, and I've looked up to Julia my entire career. She really is incredible, I have to say. But the good thing about my job is that I actually work with investors across EMEA, and I've been working with healthcare life science investors specifically for the last 3 years. So outside of this room, if you want to be connected to other investors, do shoot me a message, an email, or try to reach out, because literally my customers are investors, and my job is to connect startups that have potential to investors. We love seeing great stories. In addition to that, as I said, I'm not an investor, but we do have CTO or CXO fellowships specifically for healthcare and Web3. So if we have a cohort of CXOs that are in the DeSci space specifically, we can do structured programs to support them, support you in that space, and we will tailor. We don't just deliver things, but we really try to build things that are specifically building value for the founders in order to really give you the best potential for success. So we are here to support.
Thank you. Any questions? Yes. Oh, 2 minutes. Okay, 2 minutes. Yes.
You want me to scale it up?
Yeah. Got it.
So thank you for a really interesting panel. I'd love to hear where you see what your LPs think, right, about DeSci in the context of broader Web3. There's going to be funds that are upside down, right? So like not a question about your specific funds, of course, but do your LPs look at DeSci and they call it out to you? Like, is this an area of specific growth they see? Like, where does DeSci fit into the broader Web3 footprint from an LP perspective?
I can take this one. Great question. Look, I'll tell you this: we are paid to take risks, right? And so, if you want outsized returns, well, guess what? You have to take big risks. And so, I think back to those fundamentals, like real projects will sustain. If we were, just chasing the hype, well, now we have massive markdowns, and so LPs are not very happy, and so some funds are for sure in trouble. But at the end of the day, for builders, again, I think lots of great companies are built in downturns, and it really is. We need to think about the cash flow. We need to be prudent with managing the funds, but great companies will raise, and great companies will be built. So I think LPs are all aligned with that.
Another question? Yes, Connell.
I'll yell out as well. So there's loads of interesting ideas floating around this space and loads of interesting technologies that you've touched on. But what's less obvious maybe is what are the really exciting business cases or business models that you're most interested in. So I'm wondering what you think are the most promising business models, and do all of them require tokens, or is there other ways these companies will be?
So personally, I'm super interested in how IP NFT will be interoperable with other infrastructures in the space. But things like DeFi. So say, for example, if you have an IP NFT, how could you potentially put an AMM pool, so automated market makers around that, or could we leverage that, or long short that? To that, it's not exactly what scientists might be paying attention to, at least not me when I was at school. But what I came to realize was that a lot of the financial applications around blockchain is built around DeFi, and for anything to gain significant attention, whether there was NFT, whether there was GameFi, whether there was any innovations we saw in the blockchain space in the past few years, you need to kind of find a way to be interoperable with the DeFi space. And that's one of the keys to gaining market adoption. So for me, I'm really interested to see how we can potentially do IP, NFT-fi, or something like that to play with DeFi. Yeah.
I think we're done. Thank you, everyone. We can grab this after.
Thank you, everybody, and a massive special thanks for Julia as well, because this event would not happen without her vision and support from local work. So just a couple of minutes, we're going to welcome to the stage Chi Onwurah, who is the Shadow Minister for Science, Research and Innovation in the UK. And she's going to be in conversation with Isabel Thompson.
So the podium there, so the So yes, I organised it. I'm really interested in infrastructure, in terms of facilitating science. Previously, I was working for a company that was trying to create a large space utilising shared equipment. So by having really expensive equipment in one location that startups can use, they wouldn't incur that really high initial cost, and so you'd be able to bridge the valley of death in terms of massively. Yeah, so and then I just saw creating this fund as an inspiration. So that's what I'm excited about.
Yeah, you mentioned either way that shouldn't happen. So I give you this guy. That's so that itself means I'm in my stakeholder in a second. Is she happy sitting? Would she rather be standing? Is this a talking thing? I feel like it might be a bit well, what was that? So what is on the screen? But she's going to talk for 10 minutes at one point, you say, yeah. I will let them know. So it's not showing yet, that's all right, yeah? Did it say? She's going to talk, so she has a mic. Yeah. Is this on? I'll just check that she's there. Like, are you happy to do that?
I'll get started. Are you going to introduce?
And is that
Hi everybody. So we're just about ready to start. One thing I forgot to mention earlier is if you're going to the workshops, is this thing on? If you're going to the workshops, can you please go through the... Hello everybody. Alfie, I need you to whistle for me because nobody's listening. Thank you. Okay, we're just... so we're just about to start. One thing is, if you're going to the workshops, please go through the back of the auditorium because the gates are active today. And over to you, Isabel.
Hi everyone. It's my very great pleasure to introduce you to Kiamura, the British Member of Parliament representing Newcastle on Tyne Central, and also the Shadow Minister of Science, Research and Innovation. She is a chartered engineer with a degree in electrical engineering from Imperial College London, and an MBA from Manchester Business School. She was elected to Parliament in May 2010, and prior to her parliamentary career, she has a very distinguished career working as an engineer in the telecom sector for over 20 years, including as head of telecom technology at the UK regulator Ofcom. Her broad experience also includes being a partner at Hamilton Ventures, a US technology consultancy, developing GSM markets in Nigeria and South Africa. She also served as Director of Product Strategy at GTS. She is a presidency member of the Party of European Socialists and a fellow at the Institution of Engineering and Technology. She is also a fellow at the City and Guilds of London Institute. She's an honorary fellow of the British Science Association. She's a very strong advocate for women in STEM. I'll just say that while I was preparing for this session, I watched a number of interviews with Chi, and one quote really stood out to me. While speaking with Churchill College, Cambridge about the underrepresentation of women in science, Chi said, "As an engineer or scientist, you wake up every day with something new or exciting to achieve. You figure out how the world works, and then you make it work better." I think that's a very powerful statement, and it's also a sentiment deeply aligned with the motivations of the decentralized science community. Whatever our backgrounds, I believe that we are all here today due to our desire to make the world better through science, and indeed to make the system of science itself work better too. With that, please join me in welcoming Kiamura.
Wow, thank you very much, Isabel. That was a fantastic introduction. I'm not sure I'm going to be able to live up to it, particularly as I am a politician now, as well as an engineer. I always say I'm still the engineer in the house, as it were. And it's a real pleasure to be here. This is the first time in the Quick Institute since it was a building site. I had a tour when it was being built, and it's a beautiful building, and it's a great pleasure to be here for this conference as the Shadow Minister for Science and Research. And I am going to take advantage of this opportunity that the organisation has given me to outline the Labour Party's plans, priorities for science and research, and hope, discuss the sector's challenges and opportunities, particularly around how to connect academia and industry. But first, I do want to talk briefly about why I'm here today. Now, I was initially approached by Alfie, over there, it's his fault, who is a co-founder of DeSci, and who was a fantastic advocate for decentralized science, or DeSci, representing it as a groundbreaking effort within the scientific community to use 21st century digital tools to change how research is funded and how knowledge is shared. And Alfie also told me that Professor Victor Korolchuk of Newcastle University, who I don't think is in the room at the moment, but he's based in my constituency, and he was one of the first, or the earliest recipients of a grant through the blockchain-based research funder VitaDAO, and he received nearly $300,000 for a project focused on discovering novel autophagy activators. And Victor believes that the key difference compared to traditional funding is that with DeSci, he is part of a community, a group where he can have a conversation about how to develop his project in the most promising and mutually beneficial direction. And he also emphasized that the timescales involved were much shorter than other industrial collaborations he has had with Big Pharma, for example, which have taken years. In this case, it took the conversations took place over the course of 2 weeks. Quite stunning, really, and he had a deal after just 4 weeks, which is relatively unheard of, I think, in other funding means. So, stepping back for a moment, I think we can all agree, and I certainly would say that there are challenges with the current system of scientific research funding and publication. Now, I'm going to talk about Labour's priorities and our plans to address some of them, but at a sort of high level, there are very legitimate concerns with regard to what you can call the gatekeepers of science. That these, in terms of funding and in terms of publication, that these gatekeepers are too narrow a group, that they are effectively, though not intentionally, acting as a drag on innovative thinking, and the emergence of diverse talent, diverse in gender, class, but also geographic location, ethnicity, etc. But at the same time, I do want to say that we've learned painfully, the need for quality control in terms of the accuracy of information being made available to the public in all fields. And the issues of expertise in science and the challenge of making sure highly specialized and complex research is legitimate are such that I don't think anyone is questioning the need for gatekeepers. So I'm really here, today to learn about how the DeSci community thinks about these common challenges and what roles distributed databases and distributed ledgers can play in fostering innovative, inclusive, and rigorous science. I mean, as an electrical engineer and a software engineer, I spent a lot of time working with, on, and around databases and distributed architectures. So I'm sure it'll also come as no surprise to you that I am particularly interested in the opportunity to foster diverse funding and talent emergence. Again, as an engineer, I worked in tech all over the world. I know just how much talent there is out there that isn't recognized or isn't getting the opportunities it deserves. So I'd like to see the scientific method applied here. I'd like to see documented, peer-reviewed, and replicable examples of the impact DeSci can have, as well as a definition of terms. For example, to say that blockchain is always available and accessible, which is something that was common to say, has been rather undermined by recent examples in cryptocurrency. So, what kind of regulatory requirements are there, and are they less burdensome than the current checks and balances which are part of the funding journey? And at a time when the public are told, where you're being told we have to show restraint, the failures of due diligence from this government, and I'm a politician, this is not so much a political point, it's a public accountability point in terms of having wasted billions of pounds of taxpayers' money. And the public procurement VIP lane for Friends of Tories ministers. We believe, as hopefully the next government, that public funding absolutely has to be accountable. And that's why I'm really keen to hear how this space can develop, contribute to Labour's science offering, as we begin the long build-up to a general election. So let me just say a few words about what else Labour believes in. We believe that the United Kingdom is now and has long been a world leader in science, From the discovery of gravity to the invention of the steam engine in Newcastle, by the way, well, the commercial one, Britain has a long and proud scientific heritage, and we have a world-beating science base. We rank third only behind the US and China in science and technology journal articles. And as well as pushing the boundaries of humanity's collective understandings, science for science sake is a public good, but it also represents a priceless platform for the UK's future growth and prosperity. But due to government lack of investment, due to the absence of a long-term industrial strategy, we don't turn our science base into high-skill, high-wage, high-productivity economy across our country that we need. Our great UK science startups are being bought up or moving abroad because of a lack of UK investment opportunities. And one of the biggest threats to UK science right now is our difficulties with the association to Horizon Europe. That was a Conservative manifesto promise. Ministers promised it 23 times in the House that we would associate, yet years later, we have still uncertainty and we don't have association or a plan B alternative. And that leaves investors, scientists, researchers and universities in limbo. And many British scientists are still having, they come to talk to me about, having to choose between the country they love and the funding they need. So that's why our position on Horizon is clear. No alternative to Horizon can have the efficiency, effectiveness, influence, prestige or range of Horizon. Labour would secure association to Horizon to keep the UK as a world leader in science. And by associating, we would foster and grow the international collaboration that scientific research absolutely depends on. And our association would support universities to keep the best scientists and researchers here in the UK. Now, and another key area that we believe in is the need to diversify our science sector. It's not a tick box, diversity mustn't be a tick box exercise. It's an economic imperative. Without it, innovation is stifled, valuable talent and skills are excluded from the workforce. And as Keir Starmer said, we draw our strength as a country from too few places. And nowhere is that more evident, I would say, than in STEM. 65% of our country's STEM workforce are white and male. Data from nature.com has shown that female researchers, and in particular early career researchers, have faced a decline in scientific publishing output since the pandemic. And the British Educational Research Association says that early career researcher insecurity is impacting the mental health of our researchers, with women and minorities, as always, in fact, impacted most. So we have to value and support our early career researchers, address the issues of insecurity and precarity that are the future of science. And there are other aspects of diversity which are inhibiting innovation. So science and R&D funding is very much concentrated in the Golden Triangle. Here we are in it. And that's the Greater Southeast, which receives more public funding for R&D than the entire rest of the UK combined. Now, I was at Oxford on Friday, and it's a fantastic ecosystem there for scientific research and funding. What I'm saying is not that we want to take away from that at all. We want to build on that. We want to grow that, and we want to help use that to drive innovation across the country. Our regions need to share the growth, prosperity, and opportunity science can provide, and also the high-paid, high-skilled science jobs that go with it. So a Labour government would aim for 3% of GDP to be invested in R&D, to stoke the engine of high-skilled growth, to access new and diverse talent pools, and to catalyse regions which have been left out of scientific investment. We've recently published our startup review, which was chaired by Lord Jim O'Neill, and that's got a number of practical solutions to issues experienced by startups and spin-outs, around patient capital, skills, structures, and incentives. And I'm also looking very closely at how we can, in terms of our science offer, Labour science offer, how we can better support and incentivize universities and clusters of universities to drive engines of regional growth, working with local businesses to deliver regional economic prosperity. So that's like a really top level summary of our vision for science, research and innovation. I'm looking forward to the conversation with Isabel and to learning more about the contribution that decentralized science can make within that vision. We just, to end on a very positive note, we believe the UK has huge potential for new industries sparked by investing in science and research and development, whether that be in the life sciences, in AI, and in semiconductors and material science. And that holds the potential to rebalance our economy and spread wealth and opportunities. Isabel talked about how making the world work better. And with our world-leading research base and universities, a skilled workforce, and our deep capital markets, the UK is well placed to create new clusters of capabilities where no region will be left behind. So working in partnership with business, civil society, academia and trade unions, Labour will grab hold of the national prosperity that Britain is capable of and build a fairer and a greener future. Thank you very much. Yes, that's okay, yeah.
Great, thank you very much for that. I think I'm just very pleased and excited to have someone here who has influenced a completely different space from where many people here do. And this is going to be part of an ongoing dialogue, and I think decentralized science, especially with a focus on the potential for building public goods, business models for public goods infrastructure, is a very good fit with things that should be and are aligned aims with actually all government, largely, perhaps particularly with Labour government. My first question is, I wanted to talk a little bit about your pre-parliamentary career. You spent 2 decades as a professional engineer, and I wondered if you could tell us a bit about that and perhaps how that shaped your perspective on the science and innovation sector.
Well, I could talk about that for hours. I'll try and be brief. I mean, I went into engineering, as I always say, because it was fascinated. I was fascinated. Actually, I wanted to build spaceships. I didn't actually do that, but I think there's time after my political career. But I was just fascinated by making things work and making things work better. And the driver, science and engineering is a driver of progress, of human progress, making life easier, bringing us all together. I did my degree in Imperial, and then I went into working for the telecommunications sector, working for a Canadian-American telecoms company called Nortel, and I was about designing communication systems from big switches, which serve cities, to little exchanges, which serve small businesses. And so I saw as part of that, I think my career, and I worked in the UK, I worked in France, I worked in the US, I worked in Nigeria, I worked in Denmark and Singapore. I really saw the transformation that that was an emerging sector. It went from being, let's say, in fact, it went in multiple stages, including mobile phones, say, and the internet, from being a bit of a wild west to being, one of telecoms now is one of the most heavily regulated sectors, and we see through the online safety bill going through Parliament now, the internet is beginning to be regulated. And I think just in terms of how that influences my perspective in my policy, I think it's a great question. I haven't really thought about it coherently before, so let me try and be coherent. There's 3 or 4 ways. Firstly, the scientific method, if you like. I talked about proving things, using evidence to prove things. I don't know whether this is spilling any secrets, but that doesn't always happen in politics. So that is that value of that kind of thought process is, I think, really important to me in my political career. And I think it's increasingly important when we've seen the rise of scientific advisors, chief scientific officers, etc. We saw in the pandemic the importance of having scientists giving advice, but not allowing politicians to sort of lean on science for bad policy decisions. So there's that. Then there's also seeing the contribution that that technology gets cheaper. Science loads of cost a lot to make those fundamental breakthroughs, but their implications, their uses, get cheaper and more ubiquitous. I mean, the mobile phones we use came from defense research, if you like, originally in World War II. So that idea that technology gets cheaper and more ubiquitous, but also, now I'll stop here. Also, that regulation in governments, it's not just about getting out of the way. Government does, this government does need to have technology. I always say technology is not something that's imposed on us. It is something that is a consequence of the choices we make politically and economically. And we do need to see the kind of future that we want if we're to help it come into being. And we need to make strategic choices. And that's why Labour's industrial policies around emissions, and those emissions, just for example, one of them is clean energy by 2030.
Thanks for that. I found one quote that I believe you said, which was that when you entered Parliament it was a culture shock, but that also it was perhaps the most diverse place that you worked.
That's absolutely true. Actually, working with the Labour Party now, half of our MPs are women. I'm coming from 20 years in tech or engineering, working with women. Wow! It's great, and that sense of solidarity, sisterly solidarity has been, fantastic.
One question I'd like to ask is a sort of more general question about how you would like to see the science and innovation sector support the UK's broader economic and social goals. You mentioned green energy, but there may be other economic and social goals that you think science and innovation could particularly contribute to.
Well, that's a great question. And can I just sort of say also as well, it's great that you're asking that question, because I think there are sort of, how can I put this, groups within the scientific community over history which think that the benefits of pure science, scientific research for its own sake, mean that we should not be we shouldn't be considering the implications of scientific research and the direction of science. In fact, science does have a direction, and then for me it's incredibly important. As Keir Starmer said, that we diversify those involved in the development and production of science, because science cannot reflect the aims and ambitions of humanity if it doesn't reflect humanity. And that's in terms, I think that's in terms of gender. It's also in terms of ethnicity, disability, all the protected characteristics, but also in terms of whether you call it the north-south or divide as well. So I think we really what in terms of how science can contribute, it can contribute by diversifying the science and the science that's different. But more specifically, we cannot address climate change is the existential challenge that we face. It's the planet and it's humanity, and we cannot address it without significant scientific developments and breakthroughs. And I was just, for example, looking at the figures for the cost per gigawatt of solar panel generate energy have gone from £145 to 15 pence or something. That is scientific progress in many areas, material sciences, whatever, and those contributions. And then we have, I would say also health. We have such health differences. In Newcastle there's I think 12 years difference, depending on what sort of metro stop you're born next to, and the disparities across the country are huge. The science has a huge role to play in addressing that. And then I'll just say finally, empowering people. So this idea that science is something that happens to people, I mean, one of the reasons I'm interested in, I think one of the many reasons I'm interested in decentralized science is the contribution to empowering people as to feel that, I talk about innovation nation, which means that everyone thinks that science is for them, but also that they have a say and an involvement in science, and the benefits that it brings.
That's a really interesting lens. I think we think quite a lot here about the opportunity for bottom-up empowerment of people in the decentralized science community, not only early career researchers who often are less empowered than they perhaps deserve to be, but of course things like patient groups as well. And if you can create organizational structures that are more open and that allow people to permeate through, then the hope is, of course, that we can attract more people from underrepresented groups.
Yes.
I like the idea of really leading on the empowerment angle, and not science not being something that just happens.
Not something that happens to people, and not being something that happens to ivory tower is something that we are all part of. And just having worked in IT as well as an engineer, in development and stuff, the only way to affect cultural change, beneficial cultural change with technology, is when the users are part of the process. And we are trying to do that with science.
I have so many more questions that I could want to ask. Can I have 5? I suspect that, and this may not be your area, so that's okay, but I suspect a lot of people here are wondering about regulation. And so I was thinking, crypto has not covered itself in glory in the last year, even fundamental technology sitting behind crypto. But it also, perhaps the projects that interest me most are the ones around building public goods infrastructure, open source, huge open source community. So of course it's not a single thing when it comes to regulation. And I'm wondering, UK has a burgeoning DeSci ecosystem building on the UK scientific institutions, as you mentioned, also the fintech and blockchain expertise. However, many consider the regulatory uncertainty around blockchain is holding the sector back. And I wondered, do you have a view on how regulation should evolve to enable positive innovation in the sector?
Yeah, that's a great question. I would say, and I'm not certainly not here to set up, a full regulatory also, I would say though that I think that when it comes to fintech, we've had quite a, not here to praise the government, but there has been quite a lot of innovative discussion, consultation, sandboxing, or whatever they call it, about developing regulation around fintech. And I think, the most, having worked for a regulator, Ofcom, in the technology space for a number of years, the most important thing is to recognise for innovators and your scientists like yourselves who are in this room, or the funders, to recognise that regulation, can empower innovation. It can also empower competition, because often the absence of regulation, especially when regulation delivers trust, it's the big names that already have the trust or the recognition. So proper regulation that enables people to feel secure and safe in using new technology or new instruments, new financial instruments, is a really important way of establishing a strong market, a strong trusted market in those new instruments. I think it's really important that regulation is forward-looking and that it puts, innovation and consumer benefits, consumer security, sort of at the forefront. And so, I don't like to hear this discussion that says it's either innovation or regulation. Often it's regulation and power innovation. I think there is an issue in the capacity of government regulators right now. I think that people have been taken out of many departments, many departments have been cut. And I know that in the life sciences sector, there was an issue with the capacity of the regulators, some of the regulators to respond quickly, and so that that needs to be addressed.
That's a very positive and optimistic lens. Do you think we have time for a question?
I mean, it's technically lunchtime, like 8 minutes ago, but I think let's go for it unless...
if anyone has any burning questions, this hand went up very quickly.
Can I pass you the box?
This is
we're all missing. You can just throw
You can throw it, wow. Oh, well thought.
Hello.
That's innovation for you.
Hi, great discussion as well, by the way, thank you. Yeah, so I know we talked a lot about the kind of systems and sector-wide approach in improving science, research and innovation, but to what extent do you think a more granular approach is necessary? For example, you know, at the institutional level, there's a lot of problems, gender inequality, publish or perish, bullying and harassment, things that are obviously slowing down and discouraging people from participating in science. So yeah, I was just curious what kind of approach do you think is relevant there?
Okay, so great question, and yeah, and I think you know, I've spent 20 years in technology, but spent so much time as the only woman in a room and hearing discussions which were exclusionary and sometimes often biased, whatever. Now, I thought about this a lot, and I think it's absolutely, you know, you cannot build change if you just from the top down, but it is really important. It is really important that the message and the culture and the ambition is set at the top, and that's why it's important to take. I think it is important to take a systems approach. But equally, change is built, you know, from the bottom up and from the middle out. And so that's why it's really important that institutions at a government level, at a regional level, universities. You know, I always say that I can walk into a university engineering department and tell within about 30 seconds if diversity is a tick box exercise or it's actually something that is meaningful. And you know, that combination of setting the agenda at the top and measuring the data and the success and the involvement of you know, for example, early career researchers. I think it has to be that way. And if you have suggestions as to what you would like to see change, then I'm really happy to hear them.
Not today, but yeah, I'll have a think.
Unfortunately, should stop there because I don't really want to but I think we could all listen to you so much longer. So thank you so much. That was absolutely fascinating. Thank you for coming down today.
Thank you. And do get in touch if you have suggestions. I'm very easy to find on the web.
I just have a question about one thing you said I was going to ask. About I really believe that the UK is really highly educated people leave because it's private sector and public sector. So like I know a lot of people in my brothers younger than me, they're living in the country, their wages are really low, but how will they be trying to
everyone. Just if anyone's wondering what we're waiting for, we're just waiting for Lawrence. And if anyone is listening online and just sees a screen, Lawrence will be here in a minute.
Yep.
Hi everybody, hope you had a nice lunch. So it's my pleasure to welcome to the stage Lawrence from Vita DAO, and he's going to be talking on fighting aging through a highly aligned community.
All right, thank you everyone. I just dropped in last minute. I'm replacing Tyler Galato from Molecule. I apologize, I don't have the same awesome beard, but I hope to not disappoint. If you guys want to live, listen up. I'm going to talk about aging. I'm Lawrence Ion. I'm a steward of the DealFlow working group at Vita DAO. We are funding longevity research and then incubating it and spinning it out into startups to advance the field. So I'm going to talk about why we have to fight aging, the degenerative disease that affects all of us, all of you, and about why DeSci is needed, a bit about Vita DAO's success in democratizing funding of longevity research and advancing it towards more startups for further investment, and about what is the end game. What is the natural evolution of a DAO, highly aligned community with capacity for collective action like fighting aging. And if you crowdfund land, you get the definition of a network state. And you really get you're poised to really win the crusade against aging, mainly through regulatory innovation. So everyone says health is the most important thing. Well, I know a little bit about that. I was diagnosed with a rare disease when I was a baby, and all across my childhood, I've had many surgeries, so I know how it is to not have it. And you only realize when you don't have it how important it is. And most people only realize it when they are in a poor state of health, when they're old, and at that point it's too late to do anything about it if the industry is not already well-funded and advancing. So yeah, it's aging, it's natural, it's only part of life. I remember after my grandma died, I had this very vivid realization of like, oh shit, actually everyone around me, my parents are gonna die, I'm gonna die, and of course there's nothing to do about it, so I just put it out of my mind. It's a normal psychological coping mechanism. But wait a minute, cholera is natural, cancer is natural. So we can, instead of saying, oh, if we cure aging, we have all these concerns like overpopulation or immortal dictators, or it's only going to be for the rich or so on. Well, we could say the same, right? It's like saying London is full of people, it's growing exponentially, it's full of manure on the streets, and it was stinky. So instead of saying, let's mix back the clean water with the sewage and get cholera back, No, instead we use technology. We clean up the streets, find other solutions, and the same with everything else that nature has thrown at us. We have gone out and checked each one off the list, and so that's what technology is about. We're going to do the same thing for aging. So people used to gather around their children's deathbed, watching them being consumed by bacterial disease. Imagine if we would choose to not give them antibiotics. That would seem barbaric, right? So I think the same way, if you look, yes, life expectancy has increased exponentially over time, but it was mostly due to antibiotics, sanitization, immunization, and so on. And I think we look back at this age of no anti-aging therapies as the same barbaric, where we couldn't give our wise, elderly people these therapies, and we just watch them being consumed by aging from the inside. So imagine a world in which people are just becoming wiser, more effective, then they don't die off, but they're hundreds of years old and can remember the mistakes of the past and not repeat them. Imagine a world in which we are not distracted by getting to work, by getting that retirement nut, and so we have enough money to not be slowly growing frail or poor, but thinking about long-termism, right? Problems bigger than us, problems that might hit in 500 years, like developing the technology to steer meteors away from the Earth before they completely destroy it, like climate change. If you can imagine yourself being here in 100 years, then I think you would treat the planet differently. And the same about all the existential risks about AI safety and engineer pandemics through SynBio and so on. But what about cancer? What if we cured cancer today? How much longer do you think people would live? How much would we extend lifespan? Does anyone have any idea? No, it would be about 2 to 3 years, because all of the diseases of aging go up exponentially with age. So if I asked you, how would you like to die? Quickly, of course. But then your family would be, or your loved ones would be hurt, right? Because they're just unexpected. But if you, so yeah, all of these diseases go up exponentially with age. A third of you will die of heart disease, a third of you of cancer, and the rest will be lucky to pick up some other good diseases here. And we're all going to be frail eventually. The current medicine paradigm keeps us healthy, keeps us in a poor state of health for longer. And there's no such thing as natural causes, dying healthily in your sleep. It's a contradiction. So the second option is suffer for a while in hospital beds for a decade maybe, so that your loved ones have time to digest and so on, but it's bad for you. And of course you spend most of the money, it's a waste. And this is economically unsustainable. We are spending trillions on sick care, and it's going to get much worse with an inverted pyramid. We already have more people over 65 than people under 5. And as these people grow older, actually most of the people, the young kids that would sustain the workforce are in the developing nations, and most of the old people are in the developed nations. So actually in some of these nations, which actually are going down in population, you have an even more inverted pyramid. You can get to 10 to 1, like one young person that's in the workforce has to sustain 10 elderly sick people at this rate. So we cannot keep doing this. We have to keep people healthy, viable, and youthful, and in the workforce, extend the healthy part of life with maybe no limit. And so the third option is rage against the dying of the light. Do not go gently into that good night. So how can we ever fight aging? It's so complicated. Gerontologists have been trying to understand metabolism and intervene to slow down aging, but it's a gargantuan task. it's unfeasible until maybe we have a super intelligence. So we have better approaches, like the damage repair approach, of sort of not intervening in metabolism, not having to keep people in poor state of health when pathology is already there, which is the geriatrics approach, but rather fixing the damage from time to time, just like we do with cars. And we have some startups doing that, some of which we've funded as well from VitaDAO. The other approach, which has been getting a lot of buzz, it's like the most hype around it now, the cellular partial reprogramming, with all the top billionaires funding it, and yeah, VitaDAO also funded SynBio, which I think is the best. Other approaches, lesser known, maybe the tissue replacement, especially for brain tissue, spearheaded by Jean Hébert at Einstein College of Medicine, and other approaches like hormonal rebalancing, and many others. So I'm going to also tell you about this highly aligned community for collective action, VitaDAO. The main premise is that drugs that target aging are the future of medicine. And we've seen this huge overlap between the crypto top key opinion leaders and longevity. You know, Balaji, Vitalik, actually one of the founding members of the Bitcoin network, Hal Finney, he's in cryonics now, he's a huge advocate, and many other billionaires and newly minted people in crypto and crypto bros. So VitaDAO is a decentralized collective incubating and funding longevity research projects before they're a startup usually. We are democratizing the advancement of and participation in longevity biotech. Imagine just 1 million people with $100 cannot, you cannot put $100 in VC fund, you're not accredited. You cannot put it in startups, you're not accredited usually, right? So this is a way to fund research pretty much directly. You can also fund specific projects within VitaDAO. And yes, our mission is to extend human health and lifespan, not just lifespan, by advancing these therapeutics to market. And we can scale and deploy exponentially faster than traditional startups and VCs because we're open and permissionless. We have network effects with the token, and could become a network state. So drug development has been focused on treating the effects instead of the cause of all chronic age-related diseases, which is aging itself. IP ownership has been stuck in the 20th century. You have to, it's illiquid, it's difficult to transfer, there's a long horizon to exit, you have to call up people in business suits still. And the public and patients don't have real ownership in IP, there's not a liquid market around it, there's not price discovery. And valuable IP in universities is not investable until a startup is spun out. And of course, grants are very boring, top-down, bureaucratic, risk-averse. But there are a few dozen pharmacological interventions that can slow or reverse aging in animals. And we at VitaDAO incubate and fund the best research, holding IP on chain, enabling that liquidity and fractionalization and community, and then leverage all of that to really develop those assets, de-risking them for further investment by traditional funders such as angels and VCs. And we have an easy application process, quick funding decisions, and potential for regulatory innovation, which I'll talk about a bit. We have this circular funding model where we reinvest the proceeds and further research and can multiply our impact. We're about 1.5 years old. We funded a bunch of projects and deployed capital and grown our community. Some of the featured projects you can see here. If you want to go into each one, we can later. And also, apart from the core focus, we've also started a bunch of side projects and nonprofit initiatives to support the field as a whole. They have a prize to recognize advances in longevity, starting with a hypothesis prize we just closed last year of $20K, and some new prizes up on the website, so check it out if you want to submit. We've had funders such as Vitalik Buterin, partners as like Methuselah Foundation and Lifespan.io. And we've also had thousands of people funded through the Gitcoin longevity round that we spearheaded with quadratic funding, and where people can sort of vote with their wallets on which projects deserve more of the funding from people like Vitalik and so on, instead of him having to decide. And we've also started a fellowship, also funded mainly by the Gitcoin round with these funders, and also a hackathon that is happening right this week. So we launched in June 2021 with the fair auction where everyone bid up for the tokens and everyone got the same price, raised 5.1 million, and then in November we had the first institutional members come in with 3.1 million, including Pfizer Ventures. So pharma is getting into DeSci. And so what is a DAO in the limit? If you move to the next step. Well, I think it's a network state, an online community, startup society, cloud first, land last, but not land never. I recommend checking out the Network State book by Balaji Srinivasan, also one of our strategic contributors. And yeah, it's a lot ideologically aligned, but geographically decentralized. It becomes a network archipelago. I don't know how to pronounce that, but I'm going to try. Archipelago, with a capacity for collective action that crowdfunds territories. And I think the easiest to start with the longevity one, because for us it's life and death. So we're willing to move, we're willing to take risks. And we need a clean slate. There's been many attempts with the charter cities / special economic zones such as Prospera, actually also of course Shenzhen and Dubai and so on. There's been seasteading attempts, there's been free state projects like with New Hampshire, maybe Vancouver or Vermont would be, Vermont or, not Vancouver, Vermont or Wyoming, hi Todd, would be a better choice. And also ideas around taking a country public, such as Palau, which has only 15,000 people. And of course, the ideas put forth by Balaji with network archipelago, such as kind of like embassies, right, where you have distributed pieces of like little islands within the current territories. Aging is, I think, the biggest problem right now. It's 100% that we all die from aging. 110,000 people die every day, 44 million per year, hundreds of millions of people in pain right now from aging. And that kind of comes to 1 second, 1 life. Every second, someone dies. So I started out wanting to have an impact in the field, but thinking it would be hard and boring. It's biotech, it's slow, it's pharma. But then I realized it's feasible. And then as I realized it's feasible, but what if we're going to be the last to die, last generation, last person even, right? So one day might actually make a huge difference in whether you make it across the chasm or not. And also I realized it's actually really fun, it's intellectually stimulating, it's very much exciting. So we're not talking here about immortality, like getting a magic pill that makes you live forever. The point is that you could have drugs that extend your lifespan 10, 20 years, and then in those 10, 20 years you have more technological progress and new therapeutics that extend it even more and more, and then eventually you're kind of home free. And so you have two options. You can work on aging, or you can work on another random fun side project. But if you work on aging, then you can work on another one. Otherwise, I'm sorry. and then another one, option one, I think is better. So I'd love it if you could join us in this crusade. Imagine a world in which people who are looking at sustainability can really believe and feel that they will be part of this earth for hundreds of years, how that's going to affect how we care for this earth and each other. And if not for rational reasons, think about romance. Right now, it kind of involves marriage. You get together with someone, you have a great time for a while, then one of you gets sick, degenerate, dies, you're left alone with like trauma. And then imagine a world that's forever. Imagine you can say, I love you forever, and actually believe it. So yeah, join VitaDAO, I would say. They're open and permissionless, and you can join. If you're a researcher, apply for funding. If you're an entrepreneur or you want to get help build startups, help us spin out companies, we're looking for the best people and are willing to pay a lot for that. And if you want to try out an in-person network state experiment with a few hundred people maybe soon, go to this link and apply. So thank you. If you have any questions, well, I'm also going to be at the booth, the VitaDAO booth at the end of the room, and we can sort of go into concerns that you have about longevity and many topics, many Q&A. But yeah, if you have any questions right now that come up, let me know.
Yes, we have a box there.
Hey, yeah, sorry I'm setting you up here, but you talked about the optimistic outlook of longevity. Obviously, there's concerns that some of those outcomes might not be positive. Is there kind of a discussion, an ongoing debate around longevity ethics?
Yes, definitely. There's a lot of philosophical aspects, and I'm also involved with Jellyfish DAO, where we fund movies about showing longevity in a positive light so that we can inspire people how a world, because all the stories we've had from the earliest stories we can remember, right, about the Fountain of Youth, about Picture of Dorian Gray, it's always been some dystopian thing. There's always a reason why you shouldn't pursue it. The same with Icarus, right, like pursuing flying. He flew too close to the sun, he got his wings burnt too high, and fell and died, right? But now we fly every day. And the same with these stories. I think we need new stories, new possibilities. And I have not yet seen any argument for how there would be something much worse than what we have currently today with all these millions of people suffering and dying, and how any sort of concern people have would be much worse than that. But yeah, I've been doing this for a long time. I'd love to hear some new arguments, and I'll be open to any of those questions. Yeah.
You should watch Altered Carbon.
I have watched. It's all introduced scarcity because it's like more exciting, right?
Yeah.
But it can be way more exciting to make a movie showing the positive aspects. Yeah.
Yeah, I agree. Thank you.
Thank you.
So stop believing those stories.
Are there any other questions?
Icarus.
Don't be shy. Any questions? No? Okay, well, thank you so much, Lawrence. That was fascinating. Oh, we have one here. Do we have one?
Yeah, I was just going to ask about some example projects that VitaDAO has helped on.
Yes. Yeah. So I had some slides. Yeah. So because you're interested, yeah, Rubedo is a startup working on prodrugs for pathogenic cells, not just senescent cells, which are sort of these cells that are old and not replicating anymore, but all kinds of pathogenic cells, including cancer cells and so on. So prodrugs are like smart drugs. They only get activated. They have these sugars on top, and they get activated in only the types of cells you want. The Korolchuk lab, it was an academic project, an IPNFT. We funded, and we have some great results. It's been about a year, I think, since we funded that, and would be sort of ready for spinning out your company. It is looking for autophagy activation molecules, activating molecules. SynBio, one of the most exciting things going on right now, the cellular reprogramming approach, especially going after dermatology. It's injecting these genes, the Yamanaka transcription factors, and we just the past week we've seen papers coming out showing in vivo, in mice, rejuvenation using this exact approach, which SynBio has been the first one, I think, to do, where these mice were injected when they were like almost 77 years old for a human, so like very late, with a few weeks to live, and they doubled the remaining lifespan. So you can show that, yes, you can have an old person and rejuvenate, well, an old mouse and rejuvenate that mouse, but you can do it safely, because for 10 years, it's been a very, so the science is sort of solved, right? But the engineering aspects of like how you deliver it safely without getting teratomas, without turning into a blob of embryonic cells. So these Yamanaka factors basically just make your cells younger, more towards stem cells, right? But you can do it partially, and that's the key word, transient, as SynBio says it. And with that, you promote rejuvenation across many tissues. And of course, the papers right now are not exactly fully, I mean, they've not transfected with these delivery methods all the body and so on. So I think if you just keep developing this technology and really hit every tissue, then you can have much higher lifespan increases, and especially if you give it earlier, not when the animals are about to die.
Thank you. Thank you so much, Lawrence. Okay, next we have a very exciting panel by Raymond Trevaux talking about transforming incentives through DeSci, and we will also have Christopher Hill, Thomas Landrain joining her, and Laura Minkini. Okay, hi everybody. So as I mentioned, this is Bianca on her panel, and we'll be talking about transforming incentives through DeSci. So over to you, Bianca.
Thank you, Sarah. Can you hear me properly? Now can you hear me? Perfect. Yeah. So I would like to know, like, we have like a mixed crowd here of DeSci folk. Two of you come from academia and have a PhD, and then we have Laura, who is like not a scientist. So tell me more about your experience. Like, what was the sparkle? What was the epiphany moment that made you like quit what you were doing before? What was the change?
Test. Yeah.
So the thing that came as a major shock to me when I was doing my PhD and earlier working in academia was the replication crisis. So this is something that really caused me great doubt in the pursuit of science in general. And it was existential. And I think not just for me, for a lot of scientists out there, when you see a paper and you think, well, it's a coin flip, whether it replicates or not, that really came as a shock. And around that period, there was a lot of groups out there working in open science, people that have been doing large-scale replications of prior work that we believed were part of the scientific record, part of the canon, that we've all learned these things as part of our graduate and undergraduate studies, and to just realize that a lot of these things were essentially a house of cards was devastating for me. And that was one of the prime reasons that I decided, to move out of academia and become an entrepreneur. And I can't really complain. My time in academia has been great. I've had, a lot of success. I learned a lot of skills. I was surrounded by fantastic people and some of the brightest minds I've ever been blessed to work with in my entire life. But the incentives were wrong. We had no incentive to share our code, share our data. We had no incentive to create reproducible and verifiable research. We had no incentives whatsoever to conduct large-scale replication studies. There are things that contribute to creating a scientific record that we can all believe in, stand on, and be confident about. So yeah, that was my moment.
Thank you, Chris.
Okay. So I started as a scientist, as a synthetic biologist, and I started my PhD in a quite peculiar manner. In fact, I co-founded the research lab where I was doing my PhD later on. That was back in the days, 2008. SynBio was very fresh, and there was no SynBio labs in France yet. I was preparing myself to go abroad, but a researcher from Polytechnic came to me and said, "I know you want to do SynBio for a PhD. I'm a physicist." He was a physicist, a theoretical physicist, interested to do synthetic biology. He said, "Would you like to build a SynBio lab with me?" I said, "Sure." So I ended up actually building the whole laboratory and directing the lab actually with him. So I had a lot of freedom. But even though I had a lot of freedom, I didn't have even the responsibility of a PI. So I think I had like the most freedom that anybody could get in an academic setup, to be honest, at that point. Even though I had that much freedom, I couldn't work on topics that were outside, like the topic of the institute, or I couldn't work with people who are not researchers. If you're not an academic person, it's very hard for me to bring you into the lab and working with designers, architects, I don't know. And so it was highly frustrating, even though like yourself had a lot of fun doing my PhD, I enjoyed it very much, but it was not enough. So I decided to, because I had built a lab already, so I'm just going to build another one, except this one outside an academic setting. And I did it actually in the squat. I was 25 at the time, in an abandoned building in the suburb of Paris, and using lab equipment that could be refurbished, basically in garbages. And so I built in a few months a zero-euro laboratory in an abandoned building, so I could do whatever I wanted. I invited friends over, and then we started building a community. And at some point I realized after a couple of years that I was having so much fun in this lab where I was going during the night and weekends, much more actually than what I was doing with my collaborators, because of all those very restrictive rules about how you need to work in academia, that I felt that I don't see how I could not be able to do the complex project I'm doing in an academic setting in this new kind of environment. And so at some point that was a spark. That I need to dig into this. Like I need actually to really go full time and see if I can really transform this into like a sustainable model that could scale. That was the first biohackerspace called La Payas in Europe, started in 2009, and became actually the largest in the world at some point.
Amazing. So, as I said, I'm not a scientist, but I have the utmost respect for scientists, and I come from luxury and consumer branding background. When I had sold my company, I was looking for something that could actually make a difference, because there's plastic that I sold and made that is going to outlast us all, sadly.
So I had a lot of tick boxes of how do I do something that makes an impact, that obviously it's a business eventually because you do have to make money in the end. And by volunteering my dog to retirement homes and hospitals, I discovered what I call the world of aging. When I did a market study in the age tech space, I realized that it was about managing the situation, not about changing it. I thought these people are just content with this being the way it is, which led me to longevity biotech. And I said, is it still? Yeah. And that's when I thought, oh, this is amazing. It's about prevention and regeneration. So one of the biggest pinpoints that I realized in the field was communication. I thought what they're doing is amazing, but the branding and the storytelling is terrible. So I spent 2.5 years in the field, meeting the researchers and scientists, talking to everybody and anybody I could, interviewing them. I was lucky that Clubhouse happened. Does anybody remember Clubhouse? Which gave me access to the most incredible scientists that I think now in hindsight, whoa, what an amazing moment that we could have George Church, David Sinclair, and willing to talk to us on those panels. So it was through all that, I guess, education that I became a citizen scientist, what they call. I learned a lot about biology and biotech. And when I started contributing to VitaDAO, it was what they were doing there that really interested me, because I realized that longevity has money now in a way, more than before, but they were kind of like the black sheep of science and biotech. And the fact that they could fund research that nobody wanted to fund, I thought was incredible. And when I found out that women's health research is literally criminally underfunded, I thought we need to do this for this area of research. So my incentive was to try to change a paradigm as I saw it being changed somewhere else, and use my expertise and bring it to the field to see how I can push this cause forward. That's how I say DeSci is one of those moments where you don't actually have to be a scientist or a researcher or a web developer. You can make a difference no matter what your expertise is.
Fantastic. And why Web3? What was your first contact with Web3? And are you all Web3 and a crypto native, or you consider yourself more crypto curious? How?
So I was curious for Web3 because I do realize it's a new asset class, and I did get a bit of Bitcoin, I got a bit of Ethereum, but I was not interested in the casino aspect of things. And because I do know a bit about art, I also wasn't the NFTs did not excite me. But I did realize that it's perceived value, it is a new asset class where you store value, and it's just here to stay. When I realized what VitaDAO was doing, I said, okay, this is a really use case of Web3. We should use this to convince more people. Because I know also women are more conservative in how they invest their money. They're not going to put it in a casino as easily. They're not going to buy NFTs as easily. But if you can get them involved via something that matters to them, then there's a huge opportunity. And Web3 is interesting because it is utilizing new technology. And I say that we are at that stage of the dial-up of Web3. It's still early. And imagine what's going to happen when actually advances and we're not still using very, I call it clunky tools, but in a way you feel like you're part of the future of how technology is going to evolve, so that's why Web3.
So coming from a completely different angle to this, for me it wasn't really the emergence of a new asset class per se that was fascinating. I come in from a more technological aspect, and I was very, very interested in the new systems that allow you to securely store data, that allow you to make data accessible, that allow you to do something that we could never do before, which is disentangle application layer from the data layer. And this is something that Web3 enables in a broad sense. And I would, rather than using the term Web3, which I think has a lot of associations with hyper-financializations and other types of excesses that have happened in that space, if we take the broader term, which is decentralized web technologies, this is where there's tremendous amounts of potential in restructuring the way the scientific record is curated, in creating systems to share data and to operate on data much more efficiently. And those are core value propositions that can be enabled today. And so that was when we had this process of discovering that we could actually build these things, that was an epiphany, because we realized, wow, there's something there that can be profoundly transformative in realigning incentives by making a distinction between the data layer, which is accessible to all. Everyone can have access to the data of scientific publications, to code, to these research objects that are stored in a completely open state repository, which is mirrored across 3 continents and 5 countries. While at the same time, having the unstoppable ability to interact with that data, to pull that data, to create interfaces and user experiences. I always joke, creators, like designers, have Figma. It's an amazing tool. Developers have GitHub, an amazing tool. Scientists, we have management submission systems. I mean, who here has published a manuscript through a management submission system? Raise your hand. Yeah, quite a few of you. You remember that experience. Scientists are the most important creator class of the entire world. They discover new knowledge. And yet, in terms of tools, we're the most underserved. This has to change. And this is possible by breaking apart these layers so that competition and modes aren't formed around data, but features and user experience.
All right, it's a completely different story as well. I'm a complete newbie when it comes to Web3. The first time I came into contact with Web3 was basically a year and a half ago. Even though I had many friends doing crypto, I still remember a couple of friends of mine telling me, oh, you have to invest in these things called Ethereum. I think at the time it was like €3. There was like this early program to invest. I remember I tried, but I couldn't figure out how to make it happen, so I just abandoned. The reason why I'm here at this DeSci conference is because with Drogo, we've been doing DeSci. Well, I could say I've been, working on developing a decentralized approach to science for almost like the past decade. And when I heard of this movement, I said, "Wow, I have new friends actually," and it was interesting to have a fresh, view on this problem. And so I actually, went as a curious person to the DeSci Berlin event. That's where I met some of you, and I had this very, childish eyes, like, okay, what are you doing? Like, what's your incentive? What's of interest? Why are you doing this? And I found a very interesting ecosystem that was actually not made of that much scientists originally, but people that more had an entrepreneurial mind. And I found this like very powerful because the communities that I've been part of before, most of them were scientists, at the contrary, and didn't have like the mindset necessary to be able to build product that would last, would transform. So they were mostly trying to focus on small things that wouldn't scale. And so it's a very different environment here. I like it very much. And for me, the reason why I find this whole movement interesting is because of the talents and the ideas and the initiatives, all the different tools, the energy and the risk-taking mindset as well. Jogo is built as a Web 2 platform for now. And in fact, I think we could succeed in the last 4 years in what we've been doing because we were Web 2. Otherwise, I think it would have been much harder to engage all the 10,000 people we have on the platform so far. But Web3 has matured, and we can see that there are more and more communities, DAOs being built. And so it makes now a lot of sense for us to jump into the VAS, right? And say, let's build also a bridge between Web 2 and Web 3 communities. We'll still be Web 2 as well, and there will still be maybe like Web 2 only communities on Jogo, but at least we'll be able to offer ways for people that are Web 2 to jump into Web 3 communities very easily. So that's our mission. We want to bridge communities together, ecosystems in a very easy way. So yeah, it's a very exciting time, but mostly I would say about the energy. Like this is all about social dynamics, and so you know, we give ourselves energy, basically, and it makes us want to do stuff that we would not have otherwise done if we were in our own little corner. So that's very positive.
Thank you. So I guess you all kind of like see the potential of Web3 and DeSci for realigning misaligned incentives. What are instead the limitations from these technologies? Who wants to talk first?
Well, I'm not a technologist or scientist, but I think one of the biggest limitations is convincing people that this is something that it's valuable and important. And we have a lot of education to do. We have a lot to prove in a way. And I would say that's the biggest challenge, because what we're doing is associated with some of the other aspects of Web3, which is what's happened in the last 6 months. And to really show the value, I mean, I think when we were in a panel about incentives, researchers and scientists, to me it's insane how little funding, how little money they get for all they do. And one of the most exciting things about Web3 is the incentive, building these new incentives of ways for researchers to actually have access to capital to move research ahead. So to convince people that all they see is the news or on Twitter, all these terrible things happening on Web3 and these bad coins, and to say, no, what we're doing here is completely different, and it actually could have, it could be public goods that have impact. I mean, there's a lot to work to do around that. So for me, it's, I would get back to the communication and perception of things.
Yeah, so okay, bit of a contrarian take here. I don't think we need Web3 to change incentives. I think actually, you can do this in a Web2 system. One of the things I really liked about Jungle, and I think it's something that's worth stressing out, is the fact that today peer review is there's a minority of scientists that perform the majority of peer review reports. A lot of people, you could think about that as a game where people can defect and not do their duties to the community, which is understandable. You're not paid for it. It takes a lot of time. It's a system which often you'll have the monetization of your work in which you have no royalties. Creating a system for reciprocity is, for me, a beautiful example of how we can change incentives. Because now we can have reciprocity. You need to be able to produce a certain amount of peer evaluations before you're allowed to have your work evaluated. So these are systems that, for me, are powerful. And if I zoom out a little bit more, technology transforms incentives. There's no doubt about it. The biggest societal changes that we've gone through are not top-down driven, but rather by very disruptive technologies that have changed the way humans interact. What we need to create is better tools that provide value to the scientific community, not in 10 years where everyone has adopted it. No, it needs to provide value now, value to communities of scientists. We need to be able to create better interfaces that simplifies the process of sharing data and code, that simplifies the process of creating these objects of knowledge that are verifiable and composable and reproducible. So if we can create the affordances and deliver value to communities, that will have an effect on the incentives, inevitably. And once you start moving the incentives, funders will take notice. And then that can reinforce these changes in incentives. So there's a lot of discussions about the ability of Web3 to essentially generate monies of all sorts of kinds and forms that are programmable in all sorts of ways. But I think we've seen a lot of the excesses of that on one side. And what we need to do now is take a step back and look at the broader issues that are facing scientists today. And it's crystal clear that we need better tools to share our work in more efficient ways, that we need systems of crediting discoveries that are more fair, that we need ways in which we can verify that scientific work is reproducible. And all of these things can be catalysted with decentralized web technologies.
From my point of view, as a newbie, I think the main hindrance factor for people to join Web3 is first the usability. There was a DeSci round on Gitcoin recently. We participated with Jogo as an experiment to see how it would go. It didn't go that well. We mobilized our large community, and people, answered the call. But 99% of them came back to us saying, we want to help, but we don't understand how to do it. Like, we tried, but we failed. We want to give you money, but we can't. So that was for me like a super red flag, like wow. There are, like usability. You were talking about interfaces. Like it needs to be seamless. Like people don't have to care about the wallet, basically. The second hindrance, I think, is the reputation of Web2. There are a lot of people that just see the big headlines. They don't understand what's being built, in the background, and we just associate Web3 with people that just want to basically make a bunch of money and don't care about the world. And that is a huge risk because it's all about reputation. And we're in science where everything's about reputation. So yes, it's very important that we need to send very clear signal that DeSci is not only about investments and money and making money.
That's super interesting. Also because at least for Athena DAO and like Juggle, there's a strong emphasis on communities. I don't know if for DeSci Labs we can talk about the same. Maybe I perceive it's more infrastructure. So I wanted to know, how do you perceive like the fact that blockchains by definition are both incentives machine and like trust machine, and so there is this automatization kind of aspect, but Web3 is really like focused on communities. So like your focus, your interest is more on the community side of Web3, or like you're thinking of experimenting on all the aspects that are more like let's make the system completely trustless, which kind of like remove this human interaction with people.
Yeah, it's this word, trustless. We're talking about it just before this panel. It's I don't see how it applies very well in the scientific context. I mean, it's not in science you cannot just trust a machine. You have to trust an ecosystem of individuals that think together as a group, and that's how you build reputation, because you've been reviewed by actual human beings that have experience, knowledge, and so that's why with Jogo we have a community approach of things, where we're trying to build expert communities that will be able to review work on that topic, and you're going to build your reputation and with that community. If you just try to, I think, to create a decentralized system, completely trustless, where you just send your, let's say, paper or whatever to be reviewed, anonymously in a network of people that you don't know who they are, I don't think this is going to work. Because it's basically, how peer review is done today. You don't know really who are your reviewers, what are the incentives of the reviewers, in what context. But if it is done by a community that even though you don't have to know who exactly are the reviewers, right? You can be anonymous. The fact that you have an engagement with that community and you want the community to do well and it's going to be positive, I think the way you're going to review papers or publications or proposals is going to be completely different and much more interesting in the end.
I think the big thing is reputation as well, because I say this, that a lot of people, I have this example, a lot of people don't like the New York Times these days. But if you have an apparition in the New York Times, you're going to put on your startup page, you're going to talk about it. And when we're talking, for instance, publication, everybody wants to disrupt nature, but every researcher will still want to appear in nature because that's how the systems are built right now. So for us to actually have peer review that is decentralized and is at that level, I think researchers and scientists have to have the same value come back to them that has been built in previous systems. So reputation in the end for everything that we do, these DAOs, for us the big thing with women's health is it cannot be anonymous, that we let people that are, do reviews, or we cannot just put some of the research out on the Discord with the community just like that, because we're dealing sometimes with sensitive subjects. So how do you actually build something decentralized and at the same time making sure that you protect your community in some areas that are a bit more sensitive than others? I think it's a very tricky thing, because we want to do decentralized science. and at the same time we do have to keep some parameters from previous systems.
Yeah, I think the word trustless, it has an area of application which is very well defined. It's like about replicating states across distributed ledger, and you have a consensus technology mechanism here. It does not have to do with the broader problems of human coordinations, right? So we have to like disentangle when we say, oh, we'll make everything trustless. No, that's just not going to happen. We have to be realistic about it, right? There's a domain of applications of these so-called trustless systems, and it's constrained, to the consensus mechanisms and these type of, very well-defined computer science concepts. However, I think that perhaps the better way to think about it is not trustless, but trustful, right? How can we create systems that are more full of trust, right? And that you can ascribe trust to them with a high level of confidence. How can we make, if we can prove reproducibility, replicability, and verifiability of science and the scientific record, then we're increasing the trust that we can confer to those objects. And I think that's very important. So the real question for me is not about making things more trustless. It's about increasing our confidence in what we read, increasing the trust. It used to be publishers were creating differentiated value for readers. With the open access model, this has changed. It's no longer that much about readers, because libraries are no longer clients. It's about creating value for scientists so that you're recognized by funders. So there's that intermediary functions. The question that's really, really important here is every scientist that creates a research object, a piece of work that brings new knowledge into being, how do we maximize the value of that work to the community of people that this work is aimed for? How do we maximize the trust that we can confer to this work? Its verifiability. How can we facilitate composing on that work, reusing its artifact, accelerating progress, right? So to rephrase it, it's really about the trustfulness of the scientific record. And I think this is something that DeSci can really address.
And how would you define your own words, DeSci? Because everyone seems to have a different angle, a different interpretation of what this DeSci movement is.
That's a difficult one. I think I don't want to be, I am not the person to be saying, hey, I'm going to define DeSci. No, I think DeSci has to define itself, right? For all of its different players, people care about funding, right? Funding science, that's very important. That's part of DeSci, okay? We can care about, systems to coordinate individuals like you're doing. Complete Web 2 platform, well, that is still DeSci. It could be about storing information, making it open access. Fair enabling, right? Findable, accessible, interoperable, reusable. That can also be DeSci. So I think at the end of the day, it's also the fact, the amorphousness of the term DeSci is also its power. Because a lot of us can read different things into it, just like open science. So it's important to think that this is going to be a definition that is defined over time by its communities of practitioners.
The way I look at it is now DeSci is a really giant experiment that it's really amazing to be part of, and only time will tell. But for now, I think we're all very excited. I think there's a lot of really great things happening, and yes, everybody in the ecosystem has different priorities, different prerogatives, and different missions. So as the community evolves, more things are going to get defined, and more of the labs are going to work out, more of the experiments are going to work out, some won't, and also more a hybrid of all of this will come together into something that defines the movement more clearly in the future. But I think right now it's still all up for grabs.
Yeah, to continue on what Chris said, for me the current DeSci movement is like the continuation, it's like a new iteration of what many people in the past, I would say centuries at least, have tried to do for making the science discovery more easy. It started with centralized institutions, of course, in the 20th century, because, well, that was the best way to bring assets and talents together in one place. But now we live in the internet age, so we have to adapt. And so it's part of the experimentation that we need to go through in order to better understand how humanity is going to continue doing exploration of the universe. And yeah, maybe Web3 is going to be the key to that. Who knows that? We need to understand that ourselves through experimentations.
Thank you. I guess we are coming to an end of this panel. One last question. So what are, according to you, like the next biggest challenges for DeSci?
Well, we want to be decentralized and in a way also centralized, so we actually communicate better. We don't do a replication of efforts. I think that's one of the biggest challenges. That sometimes if communities are decentralized, we don't know what everybody's doing, and then there might be a replication of efforts that's actually causing for efforts to be wasted. So how do you stay decentralized and at the same way very collaborative so that we can actually move things forward as a community?
I think very simply the biggest challenge is providing value to the scientific community. That's the biggest challenge. And we have to demonstrate the capacities of some of these technologies to provide values, to improve the quality, improve the pace of discovery. That's the biggest challenge.
And to add to that, because I would agree, is how do we go beyond just the scientific community, and how do we bring in all the people that would like to be able to contribute, but so far are being ignored by the current system. And so this decentralization approach with decentralized reputation system, I think we'll have many nobodies today, emerge and be successful. I think I could make a parallel with what YouTube has done, for example, for many creators. I think the dream would be to be able to see the arrival of many bright minds that would have not normally wished to do a scientific career, an academic career, but this time actually be able to express very original ideas.
Thank you so much, Thomas, Chris, and Laura, for this wonderful panel.
Okay, so next up we have Holt Brammer from Protocol Labs talking about hypercerts, a new primitive for public goods and science funding. So we'd like to come to the stage.
This one is probably the best.
And then there's a meeting there, so you can switch the screen to your screen. So it's a 20-minute slot, so I don't know if you want to spend the whole time talking or if you finish early.
Who knows?
Questions. But I can give you like a 5-minute warning.
Yes, please.
Yes, 5-minute warning.
But there's also,
and there's also the clock there.
yes, so till 3. Wonderful. Yes.
Okay, thank you very much. Over to you, Holt.
All right, thank you. Thank you very much. So before I actually start, who of you actually has heard of hypercerts before? Right, quite a few. So it might be a little bit of a repeat for some of you, but since not all of you have heard it, I will also try to start at the beginning. And my talk will basically explain what I mean with hypercerts are a tool to build scalable retrospective funding systems for impact. And I will first start with why are we actually excited about retrospective funding? What do we mean with a funding system for impact or an impact funding system? And then go into what hypercerts provide to impact funding systems. So retrospective funding, basically very simplistic illustration of the current system from grants. Suppose there are contributors and funders, so the contributors as projects. There's some grant, the contributors do some work and produce some impact with that. There are obviously some delays in that. And then sometimes we see impact reports on this. But oftentimes we don't actually have a really good mechanism that evaluates the real impact of the work that was produced. What we think helps with this is a more retrospective aspect to the funding system in general. And this is where we think hypercerts can provide value from the beginning. So hypercerts are created by the projects right at the beginning with kind of an impact claim describing what they want to do. Funders then fund the hypercert, which basically also means that they get awarded part of this hypercert as kind of accounting for their contribution to making this work happen. So then basically the same thing, they create the work and they produce the impact, but then there is kind of, we introduce another loop to this. Evaluators observe after the fact the impact, so you can think of a similar thing as an impact report, but importantly, they create the impact evaluation that actually signals to the funders something about the impact that then leads to another decision to fund the impact afterwards. And funding the impact afterwards is important because this gives new incentives to contributors and new incentives also for prospective funders. And I will go into that a little bit more in a second. Evaluators actually have another role here to play because evaluators can also be prospective evaluators. Think of them as scouts for new promising projects that also can help prospective funders. So those are kind of scouts as evaluators, and we think of auditors as kind of helping retrospective funders making this second decision. So why are we excited about retrospective funding? We think from the perspective of the retrospective funders, there are a lot of fields where it's really difficult to actually anticipate the impact, and it is so much easier to get to understand what the impact was afterwards. Of course, like impact measurement is not easy afterwards as well, but it's easier. And especially for a lot of like projects, they really need to be completed to really produce the value that that they intended to produce in the beginning. So it's like, that's why there's a bridge here, because half a bridge is not half as impactful as a full bridge. Then the second thing is that we create incentives for high potential public goods. So because it's retrospective, we can actually increase the rewards for the contributors based on the impact that we really observed. This ideally leads to two things: that more talent is actually attracted to this system, because now the more impact I create, I actually benefit from my own talent in this, and hopefully more talent doesn't go into the next SaaS building, SaaS startup, but into like public goods. And the second thing is that the contributors, while they are doing their project, they also have more incentives to really produce this impact to get more rewards. And the third thing, recurring income streams. So if you really have hypercerts as kind of capturing the impact that you create, and you can like sell those hypercerts over and over again, then you also can use this as a tool for recurring income streams. There are also already like some existing retrospective funding mechanisms. Don't go into detail here, but like price competitions can be part of the social impact bonds and carbon credits. Carbon credits, the challenge there is like it is only for a very specific set right now. So you can think of hypercerts as trying to expand this idea to any other impact vector. And you have price competition and social impact bonds that have currently high transaction costs to set it up. So hypercerts kind of try to lower the transaction costs for this and making more retrospective funding systems happen. So an impact funding system, I spare you like all the details, but just like the way we are thinking about it, is that there are different actors, different funding mechanisms, different coordination mechanisms, and there's a goal that is fairly specific to the domain, how we really think about the impact in this in a certain domain. There are specific questions that we really should focus on, like how do we really work on the most promising, most impactful projects? How do we get the best talent and the best, with the necessary resources to this sector, to these projects? How do we incentivize them to do the best work? And how do we then create recurring income streams? How do we create sustainability for those projects that really showed that they can provide impact? The characteristics that we want to see is that impact funding systems should be dynamic. They should be dynamic because the conditions for it will change over time, and that's why the funding system has to adapt to that. Decentralization here is also important to use the private information in a funding system. Different funders, different experts have different information, and bringing that all through like a central decision mechanism is not as efficient as actually having a decentralized decision mechanism there, similar to like a market. And it should be interoperable, basically in order to make happen like the dynamic and the decentralized aspect of this, because different funding mechanisms should be able to come into this system. Different funding sources and evaluations should work together, and it shouldn't be like that we create like different silos for this. So when we think of different funding mechanisms, there are different decision mechanisms that decide how we actually like distribute the grants or retrospective funding, and we should also experiment with a lot of different decision mechanisms on that. There are also the funding objects differ if we actually can measure the impact or the outcomes, or if we are just funding the activities themselves that we hope that they have an impact. And like for different kind of funding objects, we need different funding mechanisms. And this is why I show this slide, because for all of that, we think of hypercerts as a data layer below that. And a common data layer for this enables kind of more experimentation with decision mechanisms, because we are using kind of the same set of objects that we decide over. And we think of this really that we want to build in a modular way. That's why we try to build this data layer that also other projects can use in their own funding structures. So now, what are hypercerts, and why do they enable the system? So a hypercert really accounts for the actions that are expected or supposed to be impactful. So it is the data fields that we capture in a hypercert is who does what when, and what is kind of this work supposed to impact, in what time frame, and what rights do owners of this hypercert have. And really this is kind of then like an impact certificate, but a hypercert is just like a specific implementation of an impact certificate. And that makes impact claims identifiable, traceable, and transferable. These all kind of live in an impact space where here I just show 2 dimensions, the scope of work and the time of work. I will go fast over this, but we really think of these 6 characteristics as building really a space where different hypercerts can live in, and we can also operate like operations on that. For example, we can merge them together if they are part of a larger project, or we can then split them if we think, oh, they are actually part of like some different things that make sense to funders and to other like collaborators in a different way, and we want to like combine them and split them again, or just like the way we characterize all of this work. Importantly, and in difference to like a lot of other implementations of impact certificates, we have like the hypercert really just looking at the work. And then separately, we have the evaluations that kind of point towards the hypercert. And that enables a more open evaluation system, because different people can provide different evaluations, and they can even contradict each other, so that over time there might actually be more reputation building from evaluators, so that we can improve the system over time. And here, basically, when we have those, just like an impact certificate that tells me what the impact of something was, the hypercert just accounts for the work, and then I can myself, as a project, can say, okay, this is what I think is the impact of this, and then different evaluators can also provide evaluations. And that's kind of the more modular fashion that we want to see hypercerts, so that like different evaluations and different evaluators can improve on the methodology. So this is not all just theory, we also are building. We have a pilot app that is available at hypercerts.xyz to create hypercerts, and an update of this is kind of like a little bit of this is live already, but it's updated continuously. An important thing is also that hypercerts allow to be fractionalized, because so much about like creating impact is about collaboration, and different funding sources should work together. So we can have one hypercert that is split in 3 fractions, for example, if we collaborate, like there are 3 collaborators or 2 collaborators and 1 funder, that gets like 10% of the impact claim that the hypercert represents. But we also can think of like more crowdfunding aspect, where there's maybe like one funder that took like the most part of it, and then a lot of people from like from the crowd also participated in this, so we can fractionalize it as we like. Technically, we are building on the 1155 standard. We actually have experimented a little bit with a different standard, the 3525, for those who have heard earlier presentations of this. We define kind of what a hypercert is and what the fraction idea of that is to really allow this fractionalization based on a certain hypercert. The claim data is now mostly moved off-chain, meaning on IPFS. We will implement collision checks, because in the hyperspace, impact certificates or hypercerts shouldn't overlap, because then 2 hypercerts would actually claim the same impact. And if you have funding, that would basically be the same problem as like a double spending problem. And we also enable multi-chain support, so that different contracts on different chains can use this standard, and we all map those into the same impact space, such that we don't have like a double spending problem from like different chains. So this is what I really mean as like hypercerts as a data layer, so that on different chains for different mechanisms, so you can just exchange a hypercert for a grant, but you can also use it for like more sophisticated retrospective funding models. There it is especially useful because it really captures the impact claim over time. That's why we are really excited about retrospective funding mechanisms, but it is also useful for all the other funding mechanisms. It's not specific to that. What is next is that we release a protocol on mainnet, probably on 1st of February. We will have a first pilot to create hypercerts. The announcement is coming soon. We also would love then to hear a lot of feedback from various projects. Over the last month, I have been in contact with many of those that I see here in the audience, if that's DeSci Foundation and DeSci Labs, or OPSI or Lateral. So there are a lot of like projects where we would like to hear feedback. Is that something that is useful for you? Or how should we move kind of like your feedback back into the protocol, such that we all build on kind of the same thing, to bring also more transparency to the funding. If we can analyze like where the hypercerts, can we connect this with roadmaps, with tech trees, with discourse graphs, to really analyze like an impact, the funding aspect of an impact space and an impact area, and then building kind of like an implementation of an open evaluation system that basically just means how we submit evaluations of hypercerts, but at the same time allow like the methodology itself to be decided by evaluators themselves. And then we are thinking about like building in a specific impact area the system that we think is the appropriate for an impact area, because we really think that based on the hypercerts, there are verticals where there's really a lot of specificities to make it happen, to work with the funders, with the projects, to make the incentives work for that impact area. And we are thinking about like building that ourselves in 1, 2, or 3 impact areas, but then also collaborate with a lot of other projects to make it happen over a larger set of impact areas. And that's basically the explanation of why hypercerts are a tool to build scalable retrospective funding systems for impact. Thank you very much. If you want to stay in contact, if you want to join the discussion, there's a Telegram group where we make all the announcements, where you can also ask some questions. We have almost 300 people already in the Telegram, and we would also love to have your feedback. And if you have projects that might want to use this, please also get in contact. Thank you very much.
Thank you. Yes, we already have hands up. I was about to say I've got time for maybe one question. Where's the box? Does anybody have it? Otherwise I can pass you the microphone. I'll just pass him the microphone.
Hey, thank you, Holger. This is really promising and fascinating for us. We're big believers in the potential of these hyper certificates. There's one point, one elephant in the room that I'm really curious to hear your take about. They all need to occupy discrete space within this hyperspace. How do you plan on implementing the collision detection?
Mm-hmm. So I think actually the challenge about the collision detection will be some kind of a common ontology that you need in order to know what is similar and what is not similar. But in the beginning, I think it is something where the ontology itself needs to emerge. Like there's no central entity that says oh, this is exactly how it should be. There can be something around funders or multiple funders coming together and saying this is kind of the ontology that we use for our funding, and then if the projects adhere to this ontology, then we can check if the projects that use a similar scope of work, for example, if they overlap in some kind of have some overlap of the hypercert. But then in the beginning, what I see is more that similar to a program telling you that 2 pictures look very much the same. Do you want to delete one of them? There is some aspect of kind of the evaluators looking at this. A algorithm tells you these hypercerts look very similar, and then actually some experts say these are actually different, or I will get back to the projects and really check if they are different or how they should be recreated to not overlap.
Okay, so imagine you have correlations between 2 hypercerts, right? Let's say it's like a 20% overlap. They would need to be reminted, or the new one. Or is it like a restructuring of an existing hypercert, or is that there's a gating mechanisms preventing the mint of the new hypercert until that conflict has been resolved?
Yes, good. So that was basically the reason why we first had all the data of hypercerts on chain, because we implemented such a system where directly before you could mint it, it would check if there's an overlap or not. We have other practical reasons why we moved it now off-chain, but because it's off-chain, we cannot it's not technically feasible at this moment to do the check before it's minted. So we can actually have project or hypercerts that overlap, but we could also see that we just run automatically every half an hour an algorithm that would check the off-chain data and then submits automatically an evaluation to the hypercert that is a duplicate of something else. So you have a little bit of a delay, and you have both hypercerts kind of on-chain, but then you have an evaluation that will tell you, oh, this is it's a colliding hypercert, and the later one would be marked.
Super, thank you so much.
Sure, thank you.
Okay, just a few moments, we're going to have a panel on decentralized IP.
fine. No, that's the best. So we've got until 3:45. Okay, everybody, we're just starting in whenever we sat down, really. Thank you. Okay, thank you very much. I'm really excited to start this panel on decentralized IP, so over to you.
Hi there, thanks very much for coming to listen to us talk about IP and DeSci. Joined by a panel of IP and research translation experts today. And so I'd very much like everyone to introduce themselves and what it is they do in the sort of life science translation and IP protection space.
Can I start?
Yes.
So I'm Veronique, I'm the Director of Translation at the Crick Institute, so that's we're hosting you today. We're a Biomedical Research Institute. We have about 1,300 researchers under one roof, and our mission is to understand the underlying biology of health and disease. So we are a fundamental research institute. Our ambition is to be multidisciplinary and to help translate some of our research into benefit for patients. So my background is I've spent about 20 years in research and development in pharma companies, and then I came to the Crick 7 years ago when it was started, and I've built the translation science and the commercialization of translation at the Crick.
Hi, so I'm Amy. I am a patent attorney. I started my career, like many of you, as an academic. I did a PhD in clinical neuroscience. I quickly realised that for many of the reasons people have been discussing, academia was a very difficult environment to work in. So I pivoted away, retrained as a patent attorney, and now I work in private practice in biotech specifically, helping my clients get patent protection for sort of new biotech inventions.
Hi, I'm Chris Burns. I'm an IP legal advisor at Molecule, and I'm involved on the IP teams of a lot of the different BioDAOs, especially those that have come out of BioXYZ and VitaDAO. My work in this space is largely these days focused on trying to think of how we can fractionalize IP NFTs into sort of developing and enabling new means for community co-governance and ideally to co-commercialization of the IP that we may be generating. I'm a patent lawyer, sort of in my, I still have a private practice at an entity called Calyx Law, where we focus a lot on actually the psychedelic space in the US. But my background before that too was mostly in big tech, a patent litigator for international trade courts. I have a physics background, so oftentimes I'm way out of my league when chatting with all the brilliant life science people around here, but got really interested in IP NFTs as sort of a novel legal technology that could be used to tool up and help empower some experimental IP licensing that I've done over the past decade or so, mostly in the corporate accountability space and on things connected to human rights and thinking a lot about IP ethics and ways to connect IP into issues of community concern. So I guess that's me.
Hi, I'm Sarah Holland. I'm a patent attorney at a company called Potter Clarkson. I've been doing this for about 9 years. Before that, I was a postdoc for 8 years at the University of Nottingham. All my scientific background's around yeast molecular biology, so I'm quite well aware of a lot of the screwed up things in academia that you've all been trying to talk about, and I'm quite interested to see how DeSci might be able to help some of the things, particularly around grant funding and trying to get PhD students and postdocs recognised as researchers in their own right. Everyone defines themselves as belonging to their PI, which I hate. So I work with a lot of scientists, founders, particularly in biotech and in particular synthetic biology companies. I do a lot of IP education for academic institutes because I left university when I was 33 and I knew nothing about IP, when really I should have probably known quite a bit about IP. Yes, that's me.
And I'm Colin McCall. I'm a commercialisation lawyer focusing very much on biotech, so IP commercialisation. So I work with companies, typically companies, at all stages of their life cycle. So typically when they're at the point of spinning out from an academic or research institution, and then all the way through their various different sort of funding rounds and their licensing and IP transactions. So that's us. Just wanted to, so first thing I want to talk about actually is one of the key things that has been identified in as a challenge for DeSci is answering questions around IP, and so and the treatment of IP, and so I thought it'd be quite useful to sort of talk about what the current paradigm is in drug discovery and development, and so actually, Veronique, you're probably one of the best people to sort of talk about the sort of the process through which. At the start, how's the process start?
I guess the commercialisation of IP has two aspects that are fairly different. One is you have found a patent, or your institution has found a patent, because in the UK, your people you work for own your intellectual property. So your institution has found a patent, and either you or your institution are working together to find the funding to be able to drive that innovation that you've developed in your lab, etc., towards impact. And that's quite slow and quite tedious, I think. So that's if you find a patent, and if you haven't found a patent but you are a data scientist or you're a software engineer, and then it's a different way of commercialization, and it takes a different process, different investors, etc., to be able to take your innovation towards the market and to patients. So one of the challenge, I think, is how do we accelerate how innovation gets out on the market, and can we find new ways to do that while you maintain all the things you need to maintain to be able to do it. So I think that's two categories we could cover today. There is a difference when you find a patent and when you haven't found a patent, which is still intellectual property, but you have to treat it differently.
And I suppose one other thing is, just talking about the drug discovery, drug development pathway, it's an extremely arduous and expensive process. So it takes, it's well known, it takes several, at least £1 billion, taking into account the failures, to get a drug to market, and typically over 10 years of concerted effort. Much of that effort and expenditure takes place after the science has been spun So yeah, I just wanted to sort of hear other people's thoughts on just the current paradigm, because I'm very much in that current paradigm thing. So I'm very interested in hearing how DeSci can help.
I have no idea if it can help, because I didn't mean to say I know literally nothing about Web3 or blockchain, so today's been really useful for me to pick up some bits. But just in terms of like pharma, when COVID hit a few years ago, I had a little bit of a crisis, like, am I working for something evil and bad? Like trying to get people patents, is it a bad thing? And I spent a long time, did quite a bit of research into other systems, there's various competitions out there that tried to fund the research that is needed to bring these drugs to market, and I just could not find anything that would work or look like it would work to incentivise somebody or anybody to spend that much money to get a drug to market. So, I don't know, if people don't like patents, I still think they're the lesser of two evils, and I'm quite interested to see if everything what people have been talking about today can help.
And I think the current system works very well for certain players in certain situations, and then there are other players who fall through the gaps completely. And for me, this is where DeSci comes in, and DeSci can be quite helpful. It's almost an opportunity to link up the whole process. So if you're sort of fractionizing IP and you're putting all that on chain, you can potentially follow that right through from you as the inventor, and you've sort of got your IP that's then transferred. It's transferred to the institution. It's transferred. You've got funding bodies. There are sort of these mechanisms where you can link it all up. You can link it up to potentially other incentives. You can say if you've got IP in something that's gone to market, then potentially that could be as valuable to your reputation as, say, a Nature publication. And it's sort of, there's a lot of potential there. I think mechanisms are not necessarily in place right now, but I think there's a lot of potential there for it to sort of bridge some of these gaps and some of these holes where people are falling through the gaps almost, and you've got sort of very interesting basic research where there's not necessarily a clear commercial use case, or you've got some of the less ethical practices, shall we say, of people who will buy up IP so they can kill it because there's something that's maybe a competitor. And it's sort of, it provides opportunities in those spaces, but I wouldn't go as far as to say that the current system is fundamentally broken. I think there's been a lot of discussion around how academic incentives are fundamentally broken, which I probably would agree with, but I don't feel that the patent system is fundamentally broken. I think it has a certain use case, and that use case can work very well, but a patent isn't the right option for everyone, and that's also okay.
So I think that's really helpful. So what I'm hearing there is the system is not necessarily broken, but there are ways in which Web3 can perhaps augment the current system. So, Chris, is that something that you would like to?
Great. Yeah. So it's interesting. I think so far we haven't yet seen an IP NFT run through a full life cycle. We've seen, less than a dozen, I think, be minted, and meaning IP NFTs as has sort of arisen in the BioDAO space. Some of the paths to monetization there might well end up leading to an exit where maybe a DAO does fund some sponsored research, takes ownership of at least the commercial rights of the IP, even if it's not perhaps legal ownership of the underlying IP itself, which may stay with the university. And then that IP ultimately, after some further development, after some of the data around all that research continues to come in, could still well be sort of have an exit to a large pharma company in a very traditional way, who could then fund the rest and take that drug to market. I'm sure that it will happen. There's also a lot of interest in trying to solve more than that, to try and say, well, we don't want the type of market power consolidation that comes from patents that go through this path in the first place. And I think there's so many million amazing ideas happening in the space, including things like hypercerts and other means of doing retroactive funding to help fund public goods and really try and solve these problems that are really kind of structural failures in the broader economy, not just in IP system, but something where we just have a hard time getting incentives aligned to even do research for neglected drugs or whatever it may be with the current system. And so I think that DeSci, just as a new space for experimentation, is kind of all of this is on the table. Another point that I just want to add is me having spent so much time in the tech world and in the IP system in the tech world, which at least in the US, it still dominates the vast majority of patent litigations. 50%, I think, of patent litigations in the US are through non-practicing entities or things we might call patent trolls. Another 15% or so are operating companies that are wielding tech, computer, software related patents. And then it's a smaller world, but obviously still a very high value IP. That's life science and is biotech. But typically when you ask people in the tech world, is the IP system broken? And you could go from Samsung, I think the largest owner of IP on a patent by patent basis out there, down to a startup, and everyone would say, oh, it's terrible. It's completely broken because of the costs that are attendant to IP litigation and sort of engaging in the IP justice system more generally are so high that we have whole new markets arising around IP risk management. And then every year they're lobbying, trying to say we need to change this, that, or the other. And then on the other side of that lobbying aisle saying, no, it's working and we need it to work because we need to be able to bring life-saving drugs to market and we don't have any other good ways, is typically big pharma. And I guess I just find it exciting and maybe inspiring, again, as a hat tip to everyone in DeSci, that this instinct to say we need to change something about how the IP system is working in decentralized IP is actually coming first from the side that in the larger market has been a bit more protective of it. It's actually bench scientists saying, no, we want to do IP in a different way. And it's not coming in the first instance from the tech world, which is where one might expect. I just add that because I think it's interesting, but I probably don't have more to share other than those thoughts. So.
Yeah, sorry, Bernie. Yeah.
I was just wondering if we need to make the differentiation as well, which is I think the scientific community now, we all buy into open science and putting our data openly out there. I think everybody a bit to that now, everybody wants to do it. And when we do that, it's free for everybody to use. There is no intellectual property on that data. It's what people do with it that can become intellectual property. But I think as a community, we need to put data out there for everybody and then let everybody has a chance to work on that data. And I think that's really important. And the one missing link, I think, also is how do we annotate and integrate our data? Because at the moment when we publish, it's very difficult to integrate. So there is another role of I think us as a community to have a better platform for integration. And we were talking about reproducibility and credibility, and that's also important, the annotation. Because I think that people can't reproduce because not everything is there in the method, but if everything was there. The other thing that I think is really important in the intellectual property side is actually there will be a lot of saving of money if we did publish what didn't work, but we can't patent it. So that's another side of the data that I think we should put all together.
And so that brings me on to another point in that, so the making of scientific research data available to all, and that's what we all bought into. But if you're going to, if there is some sort of very valuable research and results that come out of that data, then you need to patent that before, or at least put in an application for a patent before making that underlying data available.
You could decide to do that, or you could decide not to do it.
Yeah. So if you want to protect it, you need. If you want to get a patent, ultimately you have to. But if you're open-minded, very open science-minded, then perhaps you wouldn't. But Yeah, I mean, do you see the way forwards as people increasingly not looking to patent certain sort of innovations?
I guess we've made a point, which is the need to have a patent is there to prevent other people to do the same thing, and that's where you get investment behind an innovation. So there is a need to do that, unless society turns upside down. I think that won't change. To get investment, you will need to have secure IP in some shape or form. Either you haven't shared your data, or you've put a patent application in.
And that is the point, isn't it, around drug development. It's so expensive to do. There's only one recognised way of recouping the massive costs, and that's through having exclusivity when you finally do come to market. And the best way of ensuring exclusivity is through the patent system. And I think it's a tried and tested model, and it's kind of a number of us here are saying we don't think that's broken, but I'd be very interested to hear from others in the audience in a bit as to whether they think it's broken and what other sort of alternative methods there might be. But I guess, Sarah said you don't think there's any better way, but is there anybody else on the panel here who thinks that there might be a better way?
I guess I would say I think there's a need for more experimentation. I also think that generally speaking, the original purpose around intellectual property being something that's about sort of promoting progress, science, and useful arts is at least how it's put in the U.S. Constitution. I think the financialization of how knowledge production the financialization of knowledge production in the current economy, I think, has pushed the whole market pretty far away from revisiting those sort of origin pieces and by content of research in life science. Because we're making medicines, I think it's easy for this part of the market to say, well, we are still promoting health, things that we need, things that are good. But I think I'm suspicious of whether the way the IP system operates can't be improved, I guess. And I'm certainly open and eager to listen to stakeholders in this space who have commented on how it's broken, which do include a lot of historically marginalized communities, indigenous peoples who are very worried about biopiracy, who've never really borne the fruits of a lot of intellectual property that's been extracted from those areas. And those are the difficult stories for IP lawyers. We know it happens and it's always painful, and generally we say, well, it doesn't happen too often. But I do think, generally speaking, that all the experimentation that we can do in trying to build a new economy, I guess there are efforts, I think, to try and do this without patents. And I guess I'm optimistic in seeing what they may sort of show.
So I guess I don't tend to think it was better or worse. I think this is an option, and it's, as I said, an option that works very well in certain situations, but I don't think that means that we shouldn't be exploring other options. And I think also we need to appreciate that drug development is a very unique case in that you've got these sort of very, very high startup costs, very high failure rate, very high levels of specialist knowledge and training, and that just isn't the case in other industries, and the considerations aren't the same. The other thing I wanted to say is I think there's something of a jurisdictional difference, which so Chris is talking about the US, and I think there are actually quite a lot of differences between Europe and the US and the rest of the world in what IP exists and how patents are treated. And a lot of companies won't even bother patenting outside. They'll sort of patent in Europe, the US, Australia, Canada, Japan, China. They won't have even bothered filing patents in Nigeria or Argentina. So it's a lot of this IP is sort of existing in certain jurisdictions, and it's regulated very differently
different jurisdictions. I think places like Brazil and India have specific provisions about indigenous knowledge and how you can use it that again don't exist in the US. In Europe, we've sort of got cost awards that discourage some of the frivolous, ridiculous patent troll litigations that you get in the US. I think there are sort of a lot of very specific problems, and I think when we're talking about IP and different IP systems and what works and what doesn't, we almost need to be very modular about it and say this, in this specific circumstance for this group of people in this place solving this problem, this is what will or won't work, rather than sort of trying to make these sweeping statements about everything's broken and let's have a solution that will fix everything, because that's kind of just not the reality on the ground.
I mean, one thing that sort of occurred to me is that are we trying to sort of rebalance some of the sort of incentives and rewards of development, in that is there a concern that the people who come up with the sort of the founding kernel of the innovation that ultimately becomes a blockbusting drug for a Pfizer, let's say, is there a concern amongst this community that perhaps too much of that reward goes to the likes of, well, to the big pharma, and not enough of it goes to the founding academics? And is there a way? I'm seeing nods in the crowd here, and so if that's the case, is that perhaps a use case for Web3 somehow to allocate credit in a different way?
Shall I go again?
Go on.
I think to me this is probably one of my favourite use cases, is that if you've got mechanisms, you've got accountability, you've got a way of tracking, and quite often that's just completely disjointed, and you've got your early stage research where people are completely motivated by publication, by prestige, by reputation. They've not really given any thought to commercialisation. That will then go through the tech transfer office, it will be spun out, it will be sold, it will go to a company. That company will do the future development, and there's no disconnect, no aligned incentives, so the people who did the original development are just not thinking about the commercial side, and the people who are doing the commercial side that's all that they're interested in. And then when you sort of get other players coming in, you've got sort of the patient advocacy groups who maybe contributed to the funding, and if they're funding the early stage research, that then gets picked up later by another party who just have, I think this is probably one of my favourite use cases, is this idea that there could be a way to keep everyone in the loop throughout the process and keep all those incentives aligned, and the people who were involved at the very beginning and did that sort of core work, when that becomes a blockbuster drug, the money doesn't just go to Pfizer, it goes to everyone throughout the whole process.
Pfizer.
Sorry, Pfizer. We love you, Pfizer. But not to name names, it's just because Pfizer are the ones who've jumped into the space. But the profits don't just go to them, it trickles back down the chain, and everyone who's involved is either seeing profit or they're seeing the sort of reputational rewards there. They're getting something that's equivalent to a Nature paper, in that their drug was bought and sold and they've got that acknowledgement, if that's what's more important. I mean, it's a contract, you write into it what you want. But I think that's a really, really interesting, important use case.
So just listening to what you said, we can do all that already, can't we? I'm named as an inventor on something, my name's on the patent application, that's on the record. If people wanted to do it, we can keep a record.
That's only true if it's patented. That's not true if it's data.
It could be, no, but there's nothing that being
difficult.
written down when I've got this data, I'm going to license it to you, I was the originator of the data, and I want to be named as that, as the license goes through to the ultimate end user. So I don't know, I feel like everything that people talk about makes it faster and smarter and quicker and more permanent, but then it's up to us to kind of say, that's what we want to do, and then just do it.
I feel it's difficult for data. So if you've generated, I don't know, proteomic data, 100,000 data points, and somebody develops something on the top of it, it's very difficult for the researchers to track how their data has been used into a product, and I think that's where the blockchain could And some companies use it already, like Federate Learnings and all those things. So I think people use it already. I think finding a way to do it that is efficient would be great. I agree with you, when people have found a patent, you're an inventor, you can track. But it's also a way to tracking your impact, which is very difficult, because when you start something, let's say somebody developed a drug based on a gene you've invented or something, it would take 20 years. So how do you know that, you know, the gene you discovered somewhere 20 years before, you've been the one? I mean, if you're a poor nurse and you know, you discover cell division, it's different. But I think it is important to have tracking your impact too. So all those things I think are important for us to think of a community, tracking your impact. It's very difficult, it takes a long time. So Greg Winter, you know, antibodies, well of course everybody knows he's impacted the world, but it's not obvious. So I think there is some really interesting things to discover how to do better.
Can I just say one more thing? Sorry, I feel like it's just me talking. But I think as someone said earlier, you don't necessarily need it to be Web3 based. Like Web3 is a tool. It's a tool that can sort of make things potentially easier, but that doesn't mean that that's the only way to do them. And I agree, we could definitely do this without Web3. We can do this completely. We could do this with pieces of paper. But I think what Web3, it's almost the mindset. It sort of offers an opportunity to rethink. We're designing these new tools. We can think about what we want to design into these tools so that we can make things more efficient, more seamless. And ultimately, if you're sort of in the publish or perish world, people are looking at your H factor, they're not necessarily looking at what patents you filed and where you filed them and whether that innovation did or didn't get. Whereas if you've got a system that's automatically pulling all that in and you've got that sort of feeding into your H factor already, that's sort of, it's just making it so much easier. I think a lot of incentivization is just about ease. It's about lowering the barriers to resistance. If something is seamless, people will do it. If it's difficult, then they won't.
So yeah, just sort of putting into that sort of barriers. A lot of what I do in my practice is due diligence on IP assets around programs that are being out-licensed. And so a lot of that is around chain of title. Now, I wonder, is there a way Web3 can sort of impact and sort of reduce, and getting me involved on that and my team is an expensive process and it takes time and it's not massively exciting. So there are other things that I'd rather be spending my time on than looking through chain of title documents.
So when I was, before Web3, doing some large defensive patent aggregator deals, we may have 60,000 patents that had to be done in a single deal. And it would cost easily 50,000 to 100,000 in due diligence costs, make deals be much slower. It was all because chain of title around who actually owned a patent was so difficult to track down. Even when an entity, if you're a large institution with a lot of IP, you might not even know or really be able to show yourself that you have the right chain of title. Maybe someone at some point forgot to get the right assignment from an inventor who was working for them, or if the patents had already been through some transactions, it can be even more difficult to kind of track that down. So I think simply using distributed ledger technology, both to track IP ownership, and also I think where I get especially excited is to use DLT as a licensing ledger and actually have people understand and be able to see easily through fractional tokens or some other tokenization model who actually already has a license, where there might already be encumbrances on a certain piece of IP. And if you did that and just ran ETHScan or anything to kind of see what encumbrances, who owns things, and what are already out there, you're saving tens, if not hundreds of thousands of dollars in a robust IP transaction, and less, but still a significant amount for smaller transactions. And so that alone, I think, the idea of bringing IP into Web3 and really approaching IP in ways we might be able to build things like trusted IP networks, IP commons, different things that have robust licensing schemes, but that can also be organized around decreasing the cost of doing business, just generally with IP, decreasing the risk and costs attendant to an IP dispute, decreasing licensing transaction costs, improving and sort of decentralizing the due diligence that might go into IP quality control, having a DAO filled with the most brilliant minds out there help validate whether a patent should have issued.
That's really interesting. I mean, yeah, because there are a lot of bad patents there. Apologies to my colleagues who I'm sure haven't drafted any of those. But yeah, how do you see sort of Web3 sort of improving the patenting system, as in making sure that bad patents don't get onto the books?
You know, in my ideal world, and something that we've been chatting about in different channels, is to think in the first place of what might happen if we took a DAO, even maybe created some bounties to put some economic interest behind it, and just kind of watch what happens during prosecution of a patent, and you're getting office actions back saying this claim is invalid because this prior art reference, or this claim is insolubly vague, different things that have to go into the technicalities of applying for a patent. And meanwhile, you know that the poor examiner in most offices, sort of cross-jurisdictionally, are maybe spending less than 10 hours on a review. They're incentivized to grant. They certainly don't have the amount of education and talent, not to say they're incredibly well-educated and talented, but compared to the people we have in this room, compared to people who are leading bench scientists, what if we just took 3 people from those DAOs and just saw if they could outperform what examiners typically doing on some determination on the merits? Should that patent have been granted? Such that all of a sudden when a patent is granted, if you have another DAO giving some quality control stamp to it and saying, this is actually good IP, this is something we believe, if it were litigated, would probably stand up. And this other one, if it were litigated, we think that thing's done. That type of work is being done in patent IP insurance companies now, actuarial models. There's big market money behind wanting people to outpredict what happens with IP when it gets asserted, just because the problem is so notorious that, again, in the US, half of all patents that are asserted and actually get a ruling on the merits are found invalid. A coin toss. And those that have been challenged intentionally inside the patent office, in the first couple years in the US under the American Invents Act, it was 93% invalidation of claims done through inter partes review proceedings, these means of challenging patents. And selection bias, you're going to challenge the weakest patents, but that level of problem, de-risking IP justice and the cost of doing business, I think Web3 has the most. I'm very bullish on what Web3 has to offer there.
Is that the Web3 part, or is it people in the DAO, which to me is separate?
Yeah, I think having people organized in a DAO, I think one of the biggest obstacles that arise when you're trying to do collective bargaining outside of Web3 is trust. The entities who do it, RPX, some of these other ones, it's a black box that you can't tell the other members what another member's paying, even though you're all getting rights to the same deal. Not because it's not economically rational. Like, big corporates will do what's economically rational all the time, but they can't go into their C-suite and tell them, well, we're paying more. I'm Apple, I'm paying more than Samsung, or I'm Pfizer, I'm paying more than Moderna or something for this. That's where all of a sudden the things kind of stop transactions that otherwise should happen. But if you can have a trustless but transparent platform like a blockchain to pool money, sort of pool risk, decentralize the costs of it, and have that interaction just be perhaps through an anonymous wallet that maybe, there's so many different ways you can go about enabling the kind of game theory that you need to solve for that stops a lot of effective patent risk management and the like now. I think Web3 can help unlock that.
I'm conscious that we've done all the talking, but yeah, interested to hear if there are any questions from the audience. That yes, there are a few.
There's a lot, right? We've only got a few minutes, so
Yeah.
guys are going to have to be quick. You can go first. So we've had.
Isn't it kind of good that patents are expensive? Because otherwise it's like, if they're cheap, you can just patent everything, right?
You still have to get it through the patent office. It still has to be new and inventive and patentable. So maybe it's good. It'd be better if it was cheaper, so people can patent all the technology that should be patentable.
I think it also means that the only people who can access the patent system are people who are already wealthy, and I think that has some very significant structural implications for how IP participates in some, what I would say is structural sort of bias and problems in the economy more generally, but I appreciate the point.
Would you talk about conversion of existing patents or only new methodology moving forward?
Sorry, can you ask that one again?
Conversion of existing patents into NFTs, or sort of, are we talking about a new methodology moving forward?
Yeah, you can put existing patents on chain. Like the protocol that Molecule is launching it's really just a process of taking IP, the legal rights, and tokenizing those legal rights. But those legal rights can be anything from a sponsored an IP assignment and a sponsored research agreement to, in theory, IP ownership even inside a corporation amongst shareholders. Or perhaps it might be, I mean, one could even tokenize an individual claim. You know, they have full flexibility in taking the exclusive right that is the IP right, tokenizing it, and then playing around with it, regardless of how sort of mature or at what point a government has or hasn't sort of validated the existence of that exclusive right. Yeah.
Thanks very much.
One more, yeah. Oh, good shot.
Hi, good throw. So is anybody doing the work to sort of forecast? So a lot of the sentiment is around actually restoring a sense of power to a distributed research community in a sort of adversarial way to established industry. Is anybody doing the work to sort of forward forecast potentially any sort of gaming of this new legal technology by industry once they get on board, so that actually researchers aren't detrimentally impacted in the long term?
I think that's got to be one for Chris. I mean, you've got Pfizer on your...
Yeah, I think there's a lot of thought being sort of done around this, and I've no doubt that if the technology gets adopted the way we hope, it's going to be gamed and there's going to be terrible, you know, it's like any technology. I think similar to what happened with the internet. You know, I mean, right, so Google went from do no evil as a motto to then silently cutting that out of its whole corporate charter, you know, once it actually became such a dominant market player. Open source software, the same thing. You know, it starts with an idealism around copyleft that says, well, everything's going to become copyleft, and then copyleft became a virus in terms of the software in the eyes of many large corporates, and now open source is oftentimes just used sometimes to, well, can be used to simply reify existing market dominance. And so for scientists, I think, unless DeSci makes a point of saying, we start to own and occupy the IP that we create ourselves as individuals, which sounds very labor, you know, IP producers unite kind of idea. Yeah, I mean, sure, count me in, you know, let me know. But without that, absolutely, I think there'll be bad things that come from it, just because it's freedom in human nature. I don't know.
I mean, one of the concerns there might be that, you know, vested interests might sort of gain access to the IP rights and then, as you put it earlier, Amy, kill it. Is there a way that we can sort of prevent that from happening?
I think again, I'm really big on trying to create tools for the autonomous scientist that allow scientists producing IP, DAOs, broader community, to encode ethical encumbrances onto the IP right itself. And these things can get really clever, so that should the IP make its way into the hands of an entity who behaves in a particular way, which can be prescribed by careful sort of thought what that behavior looks like, then you might say there's a free license for everyone, or there's springing licenses, there's different mechanisms that can be used. This is how patent trolls, which are sort of the most notorious and kind of most simplistic bad actor with IP, behave now. There's networks with 2,500 plus members who have top, I mean, again, larger than big tech, but this is coming into life science as well, who promise that should their IP ever go into the hands of a troll, it's a springing license for everyone else in the network, so the troll can't sue them. I think we need to do types of things to be very intentional about how we ensure our IP doesn't just, we don't open it up in a way to reify the bad behavior we're expecting, but bad behavior, people are creative with bad behavior as well. So I think it's going to be much like one does with security software. It's an ongoing game. You know, who can write the next best virus, and then who can write the next best layer of security software to beat it. I think that's the level of what we'll be operating in, what I would refer to as these IP networks.
Thanks very much, everyone. It's been a pleasure chatting
Thanks everybody, if you come back at 10 past, it's the PM break.
It might. So like maybe what, like 2 more minutes, let's see if... No. We're just... Are you going for the drinks tonight? Probably not. Oh, right. You're just gonna have a nap on the train. Yeah. Okay. Are you having the difficult rest of the week? Will you be able to kind of... Okay. No, I'm based here. I'm based here, and yeah, I mean, it's just like, you know, we have just, you know, regular work starting from tomorrow. We have this like company retreat in a week and a half, and so I want to finish as much as possible before that, and then just kind of do more networking with the company, and yeah, and then leave Denver basically. So yeah.
Okay, everybody can sit down, please, and also, yes, thank you. I was just about to answer that, AV team. Thank you. So we're going to get started. So we've got Arta from Ceramic, and he is going to be talking about composable sovereign data for the new web.
Thank you so much. Welcome everybody. Thank you for coming. Thank you for the organizers for setting up such a great event. I'm going to be talking about composable sovereign data for the new web today, but mostly, you know, explaining what we mean by those terms in Ceramic, and why we hope that some of the tools that we built might be actually useful for the DeSci community, and why we want to help in the first place. So I'm going to start by introducing myself a little bit and saying, explaining why me and my friends in Ceramic community have been trying to do our best to support the DeSci community as much as possible. So I'm a software engineer, and I've been working in tech for around 15 years now, in different setups and different companies. But until my mid-20s, actually, all I really wanted to do was science. I started my research in early 2000s in formal logic, foundations of mathematics, computability theory. But then after a few years, I realized that unfortunately, it would just not be a sustainable way of life. And so, as you know, the personal computing started to really grow up, customer-grade products started to grow up, I decided to move to the second thing that I had always loved doing, basically solving engineering problems, writing code, and building tools for people to help solve their problems. Yeah, and as I said, I had been doing this for quite a while, but a couple of years ago, when I started hearing about DeFi and, you know, about blockchain as a set of technologies that are actually not only about financial incentives, but also around, you know, decentralized data, some other tools, empowering more people from more places to do interesting stuff. I started learning about the space. At some point, I met people at Ceramic, started talking to them, and then I realized that some of the passions that I had personally, like, were first shared with people at Ceramic, but more importantly, that, you know, as opposed to my previous years in Web 2, when I felt, that the areas of problems I was able to tackle were severely limited by, the interests of the company I worked with, but mostly by just the type of people who were around tech that was not super diverse. As opposed to these times, like starting to be around people in Web3 and in DeSci, I started realizing that this is really a very unique situation in which people from all different kind of backgrounds and areas try to collaborate to solve their problems. And one of these different interesting areas is DeSci. So for me, it's personally like a way to kind of try and help people solve some of the problems that made me leave academia like 15, 20 years ago, which is like super exciting. And I'm very grateful that I have this opportunity. And I'm not the single person in ceramic. Also, like, our whole team is very passionate about this, including the founders. And to support that, I wanted to share our mission with you today, which is to catalyze the community-driven data ecosystem that helps developers build a more open and vibrant web. And again, putting it in the context of DeSci, I feel from talking to many of you and listening to the panels over the last couple of days that having a community-driven data ecosystem and great tools to be able to use this ecosystem might actually be something that could be useful to solve some problems of DeSci at least. So yeah, ceramic, we have a team that has quite a lot of expertise working with Web3 technologies, specifically around decentralized identity, decentralized data, for quite a while. First, let's just quickly skim through. I think like this is something like super familiar with all of you. This has been mentioned several times in this conference. Like, why have we set out on that mission that I mentioned to create a data ecosystem, community-driven data ecosystem for an open web? Why that mission? What kind of problems are we trying to solve? So yeah, basically, two biggest problems that we feel are really limiting many areas in DeSci as well right now are, first of all, like lack of user agency. So like basically people create some data, share it online, but they don't own it. The moment it's shared, their agency basically is limited to like number of likes or like some external basically mechanisms, and the creators of tools are only indirectly interested in how these mechanisms work for data creators. And the second problem is also like that data gating, of course. So both of these topics, like user agency, the topic that has been raised several times in the context of IP here, data siloing or gating, also mentioned several times in this conference when it comes to access to data sets, being able not to repeat the same experiments over and over and over, and being able to spend more time on the creative work and synthetic work trying to figure out what we can build more. So this is the problem we're trying to solve. And what we believe sovereign data is and how it should work is basically summarized on this graph. And I'm not going to go through all of these pods one by one. I think that, again, all of you are pretty familiar with the current state, and what our goals more or less are. So we generally try to give more broader access to more people to data, give them agency over their data, help them build all the tools that are needed to solve problems that stem out of this approach, so problems around identity, reputation, and search and stuff like that. The way we solve this, or we try to solve this, is basically on several layers. So First of all, what ceramic is basically a data protocol and a set of tools to build data according to this protocol. So it's ceramic protocol and ceramic network. And you might ask how it fits in the broader ecosystem of several other tools that are also trying to solve problems with decentralized data, or actually try to provide decentralized data. So we've heard from several friends here already, from Bacalhau, from IPFS. There are many great projects that are trying to make access to data easier, access to computation easier. What we are doing is we build on top of IPFS, and we provide structured, like the ceramic protocol is about defining structured and mutable data on top of IPFS, basically. So what that means is that, you know, when IPFS is great for storing all different kinds of data. Whenever you store something on IPFS, you get a content identifier. You can share this identifier with somebody, whoever has this identifier and access to internet. They can use IPFS network to fetch the same data. They will know that it was the data that you uploaded, and it's all fantastic. What we add on top of that is like we help build basically semantics on top of this. We let you define data types and data schemas so that you can create like a document of a certain type, and then you can update this document, and each of these particular updates is stored on IPFS, but it provides like a stream of updates for a given piece of data that again you can share, and it enables collaborations on this data, enables history, versioning, and stuff like this. And then even the next layer on top of this is our current product that we're working on. It's just called ComposeDB, and it's currently in a public alpha. We plan to move it to beta a few weeks before ETH Denver, so beginning of February. And what ComposeDB is all about is basically providing tools on top of ceramic that just let you focus on defining your model structure, your data structure completely, and then make it as easy as possible to create this data, query this data, so that you don't have to worry about indexing, latency, performance, stuff like that. But you have access to like a full graph, basically, of the data that you want to operate on and you want users to have access to. And of course, this is all fully decentralized, which means that the data you create using ComposeDB is available on Ceramic Network, so other apps can also use this. When you create a new app, you can start using the data that's already there, and so on and so forth. The types of use cases that we feel it enables and that hopefully can be helpful for DeSci are basically all kinds of use cases that require collaboration on structured data. So to try and tie that in with some of the discussions that we've had over the last couple of days. So peer reviews, literature reviews, as I mentioned, reputation systems. Right now, as far as I understand, I'm still learning from you about what you actually use in DeSci right now, but I understand it's basically like a mix of something like Google Docs, Dropbox, email, forums. Very siloed, very centralized, and you don't really know what's stored where and how long, and so on and so forth. We want to empower developers to collaborate with you, with scientists and other builders to provide tools that basically do similar things, first of all, so that you can start moving to like a decentralized setup, and then also start using some of the unique properties of the new web, Web3, and crypto to actually provide significantly more value than the existing tools. Yeah, this is our mission. This is why we do this, and this is why we hope it can be useful for DeSci, and why we want to work with you and listen to you and hear about how we can help developers build better tools for you, so that at the end, a few years from now, we can meet again, and you know, the vast majority of scientists here actually start using web-free tools and know what data is stored where. They can store their own data. They feel they have ownership of this data. They can share it with whoever they want, and so on. I also have an example of a really cool project, one of the really cool projects that have already started building on ComposeDB. We have quite a few great examples of projects that had been building on previous iterations of ceramic tools, like Gitcoin, for example, but we already have also great examples of projects who have been building on ComposeDB, which, as I said, is in alpha. So I'm not sure if you had an opportunity, I hope you did, to watch Martin's presentation yesterday about Lateral. Lateral is a great project that basically consists of two tools right now, one of them pretty well established and the other one using ComposeDB in early stages of development. So first, basically the first tool lets you upload your papers or somebody's papers as PDFs, and then basically create like a project database for the papers that you have uploaded, define the problems that are being solved, the data that supports particular theories, the theories themselves, and then the new tool that the Lateral team is developing right now is basically they let you copy the graphs of relations between, you know, data and evidence supporting data and theories and claims from the first tool and put them on ComposeDB and share them with the broader community, so that basically you can really open up and start building this huge graph of knowledge and evidence and claims and theories, and easily search for, you know, either theories or claims similar to the ones that you have been working on yourself, or just find evidence supporting particular claims you're interested in. So yeah, I really encourage you to, if you haven't had a chance yet, to reach out to a Lateral team and to Martin, check out their tool. I hope that it will be very useful to at least some of you. If you want to get in touch with us, please do. We are really looking forward to meeting, of course, builders who have ideas about useful tools that they could build related to decentralized data and user-owned data in the DeSci space. We're also interested very much to hearing from scientists and everybody else in the DeSci ecosystem, just to understand better the problem space and where it's going and how we can help, because we also spend a significant amount of our time supporting developers and helping them figure out the best ways of solving problems. We have a grants program as well, so we're working with early stage projects that want to build on ceramic. So if anything that I have mentioned today sounds interesting or sounds like something that might help solve some of your problems, please reach out. We're looking forward to meeting you and learning from you. And with that, I think we have still a couple of minutes, 2 minutes for questions. Yeah, so if anybody wants to ask something, I'm more than happy to answer.
Yes, we have a hand here. Go for Alex.
Thank you for that. As a community, how do you approach the schema design for things like composable data flows? How quick are you in terms of agreeing on new changes to schema?
Well, to be honest, we're not very quick right now. These are still very early stages. We're trying to figure this out for ourselves. And, you know, as you can imagine, because, you know, that's a great question. And as you can imagine, like, I guess because you asked this question, like, there are many trade-offs to make. Developers mostly want to build something quickly, and they tend to reuse some of the pre-existing kind of their previous experience from building data models, which had been from Web 2 mostly, right? And there are really not that many great cases of really composable, reusable data in Web 3 either yet. So we see it as part of our mission, you know. This is why we say that we want to catalyze the community-driven data ecosystem. So this is like one of the most important parts of that vision. And you know, when it comes to how we actually have been approaching this, like so far we just, you know, going to events, invite people to reach out to us, and we work with the projects who build on our technology. And whenever we see that there is a potential for, you know, several projects to reuse some model, we just try to help them communicate, and we just try to help them be mindful of, you know, how it will benefit them and everybody else in the long term. So it's really about, you know, preaching for composability and reusability, and then really on high level and on low level, just trying to figure out, going through all the possible options for a particular use case and trying to predict how it works. So we will be building experience like this, and at some point we will also open up tools for the community to really kind of like start doing this themselves without us being the middleman.
Thank you.
Thank you. Thank you very much for your question. Unfortunately, we don't have time for any more. But thank you very much for the talk. Thank you, everyone.
Thank you.
One of those computers that you should always have plugged in.
Sweet.
This guy for you.
Time is 30 minutes, right?
2 minutes.
20? Yeah, it's,
I can do 10, 5, and 1 minute. Does that work for you?
yeah, we'll do questions at the end. So.
Yeah, so if you want to, like, yeah, go a little bit. Go for it.
What's the clicker? This one?
Yeah, it's this function. So, do you have a USB port?
I don't. Perfect.
But you might want to plug in the charger to that whole.
Yeah.
Sorry.
Sweet.
Hit continue. Hit this and then just hit skip. And then select your keyword. I think it's probably Eurostandard. And then done. And then you should be able to.
Sweet. Although, let me see. Yeah. This looks more correct. Oh, what's it? Oh no, one. Lily. No, I can also just do it from here. No, I cannot just do it from here.
So, our next talk is Learnings from Initiating BioDAO by Vincent Heiser from Molecule. Vincent.
Perfect. Can you all understand me in the back? Yes? Sweet. Yeah, so I'll just briefly talk about kind of lessons learned from helping create VitaDAO, and we'll do the first part on just giving like a very 30-second intro on VitaDAO, and then going into the lessons, and then leaving a few minutes at the end for questions. So for those that don't know it yet, VitaDAO is a biotech DAO focused on funding and advancing longevity research. So we started, I think, 1.5 years ago, and actually what was funny was like I was kind kind of thought of doing like a science DAO, like way before I also met Paul and Tyler, and then found them via Twitter, and then they told me about the idea, so I helped to join to create it. So it was, yeah, and that's kind of like the model. You might have seen the presentation before, and kind of creating this sustainable funding loop of funding research, using the proceeds to fund more research, and in general, like not just fund research, but also, of course, could really create a Schelling point and community for people interested in that space of longevity research to get involved and learn more about it. So I'll start, and actually I added like a lesson 0, which I thought was like almost like I assumed to be at the core of it is obviously that the core of a DAO is about the people and creating a strong community, and at the end of obviously it's creating a strong also scientific community that is positive sum, which I think might be different from other scientific communities, which might be more zero sum. And I think one core thing I realized is, of course, like the onboarding, that like a lot of researchers might not be crypto native, so but still really interested to get involved in a community. So I think it's really important to get the onboarding right and as easy as possible, and creating easy touch points to get involved, and even simple stuff like time zones. Like if there's like specific onboarding call that is always like in one time zone, but then like a whole like continent can't join because like there's never like a onboarding call in their time zone, like even simple stuff like this. And really having people that that onboard other people. Like I realized this myself with like the greatest contributors usually joined because there was someone taking the time to get them involved, get them on the right project, and really empowered and also connected in that community, and giving them also a sense of ownership and rewarding them. Like I've seen this even myself in other projects where like people put in an insane amount of work and then like zero recognition, zero compensation, and like they were also quickly gone. And so I think it's actually really important to have this feedback loop and create like a fun also and high empathy engaging community. But so I think it obviously starts really with a clear purpose and mission, and I think like longevity is a good example of this, but I think a lot of DAOs actually lacked this, and I think which might be one of the reasons why a lot of DAOs died. And even though they might have had their meme moment, like buying the constitution or doing a specific action, it wasn't really long lasting and not a strong like long-term purpose and mission. And I think actually the crucial thing is to define it well. Like it's in a sense like having a sense of like what would success look like for the DAO. And I think a lot of DAOs I'm still talking to like can't really clearly communicate like what their theory of change is to an extent, and like what their well-defined purpose is with like specific measurable and achievable kind of goals and metrics. And then I think the important thing is what I call the definite optimism. It's like having a concrete vision of like what success looks like beyond just like pouring more money into funding. I think that's not usually what, like obviously it's like clinical outcomes, for example, in science DAOs oftentimes. And the second one is also keeping the focus on that mission. I think it's easy actually for people to get drawn into something like a Vita DAO and then like lose focus of like the overarching mission and get like stuck in the minutia of like optimizing a specific small thing, but like completely forgetting about like not just like again like pouring money into research, but actually advancing the research. And I think it's not very impressive like to I think like failure would look in a bio DAO would look like having $1 billion, funding 1,000 projects and hitting 0 clinical outcomes. And I think it's like important to be explicit because like there are examples of organizations that had like successful clinical trials with like $1 million, and that is much more impressive to me than just like sinking a lot of money into research. And then of course really on that focus on the mission, like enabling kind of the high impact initiatives within the community, and really going for the underexplored, potentially impactful initiatives, because I think there's also this adverse selection that like probably the research that no one wants to fund like might have also good reasons not to be funded. Like what I mean is there's also obviously competition for funding. Like there is funding in longevity or neuroscience and all of these areas. And my kind of like default assumptions, like the best research will usually end up getting funded. but so it's actually, one needs to look hard to find, I think, the worthwhile research fund sometimes. And then I think prioritizing high agency contributors that actually take initiative and have high intrinsic motivation, because it's also easy once you have a token and money that you like attract mercenaries and not like missionaries who are actually in it for the mission. So that leads also to culture. So I think ultimately it's important to have like a shared values and like that also are enforced, that like if someone like breaks them, that they're like not like, and I think that's also like an interesting one, because of course you can't even like what's the right word, like kick someone out of your DAO to an extent because it's an open community, but there needs to be, I think, like a strong set of cultural norms that are enforced in a degree, and really that help to like create a strong scientific culture, but also like a culture of trust, because I think like there can be a lot of like people in crypto that like don't have the strongest values and that are not that strongly enforced actually. So I think it's actually even more important for crypto like DAO, which every science does, of course. Yeah, and I think another important one on culture, I think, is really to like support like diverse set of opinions and backgrounds, and foster kind of like a culture of feedback. And then like one thing which I'm still which I think is like never-ending learning is like incentives. And I think a lot of people think like incentives is purely money, as like in this emoji, but I think it's actually just like one tiny part. I think actually a lot of the most valuable contributors, again, are like in it for the mission. And you can, of course, also, like someone who's really passionate about a topic, you can almost like demotivate if you introduce money as an incentive. So I think actually there's so many different kinds of incentives, and I think it's important to not just think of like tokens or money as an incentive, but also other ways to create incentives and reward contributors. Yeah, so I think the focus, and I think like Charlie Munger, like from Berkshire Hathaway, said it nicely. It's like if you can work on incentives, you should work on nothing else. Like in the sense, if that everything is driven by incentives, like our scientific system, politics, like businesses, markets, and ultimately, I think the power of crypto is actually that one can re-engineer incentives, like even between, like going towards like public goods funding, and like there's novel ways to explore incentives, and I think it's something that we should, as a space and generally explore more. Yeah, and then I think the main one is like clearly recognizing contributions is really crucial, because I think in a lot of other contexts, like maybe the PI or like the head like of the lab gets like a lot of recognition, but then like all the researchers in that lab that do the actual work like don't get really recognized, and I think it's also something where the DAO shouldn't be about a person or even like a few people, but it should really be about the people that contribute and that make it happen. And yeah, I think goes back a bit to culture, but I think it's important to have like this like clear, transparent, consistent policy of compensation. So it's like understandable for contributors like how incentives work and are enforced. And then yeah, the fifth one was what I also briefly mentioned before, is attracting kind of like the right people and really retaining them. I think it's really easy for to have tourists in DAOs that like just switch from DAOs to DAOs to see like where there are like opportunities to contribute, which is also fair, but like for the valuable contributors, I think it's easy to also lose them quickly again, especially in such a competitive space. Like literally we had like billion-dollar crypto projects like compete for our talent to an extent, and then you also see then like kind of like the people that are really in it for the mission like are easier, harder to poach away than the people that like are in it potentially also for like advancing the career and whatnot. Yeah, so I think this point on like focusing on people that are really intrinsically motivated. And I think the core is, of course, that like at the core DAO can be a positive sum environment. So I think it's important to strive towards that and like remove the blockers and politics that can quickly bubble up in bigger DAOs. I think actually like that was like also core learning in retrospect is that ultimately, like a DAO is really like not able to make a big impact without legitimacy and awareness. So I think, like to an extent, can of course be engineered, but it's also like actually much harder to engineer than I think most people assume. Of even like just getting the right people involved for the right reasons that bring on the other right people that bring on other right people. And I think we had this early on that we had like I think in the first month that we started, or second, Aubrey and Vitalik kind of like respectively, I would say like the two most well-known people of the fields of like crypto and longevity to an extent, join us for an interview, and that kind of like brought just like a lot of awareness, but also a lot of people becoming aware that this is even a thing and join in to help make it happen. But I think they only joined because they knew people that were involved, and they only joined because they knew the people that started it. And ultimately, it's this chain of I think legitimacy that people can underestimate. Where it's like sometimes hard to break into if one is not, for example, deep in crypto or longevity. It's harder to build up this web of contributors. And I think the core lesson there was also, to an extent, leverage existing communities. So, for example, we engage fairly deeply, obviously in that sense, with the Ethereum community, with the like the whole community that Aubrey and others in longevity had, but also, for example, with the Reddit longevity community, we engage fairly deeply. And I think like a lot of DAOs that I see are like not getting to that like traction of like engaging these big communities and getting them involved. And yeah, I think it really also goes to awareness. And how much time do I have left? Okay. Yeah, and then the other one is on moving quick and adapting and iterating, which I think is, of course, like a classical also startup learning, but is ultimately, I think, also the big potential of a DAO that one can run a lot of experiments and ideally like learn quickly, improve, and do new experiments. So I think it's, of course, on every kind of aspect from DAO governance to the research, important, I think, to like not get overly hang up in discussions. Like I'm oftentimes just like literally talking to no one, just like putting it on the governance forum. Then it's like, okay, like it goes up on chain next week. And then I don't even need to discuss to people, like it will be discussed in a forum with like everyone that wants to discuss it. But it's a very nice and straightforward way to avoid kind of like the inertia and slowness sometimes that even like creeps into like a big group like this, where it's like sometimes easier to build consensus in public because then people like have a more refined actually way to improve a proposal than having to convince everyone. So I think that goes also in this direction of breaking up proposals, of course, which are the heart of DAOs, into very small proposals that because sometimes it can happen that like people just like throw in like 20 ideas in like one proposal, and then I'm like, okay, like I don't like some of these ideas, so I'll vote no. But if it's like break up into smaller proposals, it might be easier to get to the source of like what people agree with and what they don't. So I think that's also like I did this in other DAOs where I just like did a proposal and like suddenly the whole like developer team that is building it like reacts and then goes up on chain like 5 days later and something happens. And it's like much harder to do that in the, of course, real world or companies. I think that was like a great blog post, which I think is also important lesson and learning that like DAOs are obviously not corporations or companies. So Vitalik did this blog post with the same title, and I think the core there, or the core learning, is really that it shouldn't, and obviously usually doesn't have like central like leaders that can make decisions. Like it's ultimately up to the community, which I think is even different from like shareholder capitalism in a sense. Like Facebook, like Mark Zuckerberg is still calling the shots with his like voting shares and whatnot, even though it might have some like resemblance to DAO. It usually doesn't in practice, but on that one, I think the core is really on focusing on enabling the small, empowered, and autonomous initiatives. And there's like a great related blog post called Outcome-Based Resource Allocation by Peter Pan, who's like also long involved in a lot of DAOs, that he wrote for SafeDAO. And that point made, like what is the core insight there is that ultimately you have, similar even like to a company, you might have like a goals, mission, and metrics of what success looks like, but I think different from it, you have specific strategies that might achieve that. For example, strategies to advance or solve longevity, and then they are broken up into kind of smaller initiatives that like individuals could take on. So it could be like scientific communication to spread awareness on longevity, and then an individual could come in to propose an initiative for that. So I think there's like a nice visual to resemble this, that there can be these like independent pods to drive specific initiatives. Yeah, so I think then that was like actually what I just mentioned here, is that it's important to, of course, strive to be as open and autonomous as possible, like the A and O in the DAO. And ultimately, that everything that can be fully transparent and open should be, and having like clear documentation, as well as like these very clear processes that also really enable a DAO to become increasingly autonomous and also decentralized. Ultimately, I think a lot of them like start out, obviously it's like a very small group of people that like starts to maybe initiate a specific DAO, but I think it should strive to create processes where it's not centered around specific people, but where it's like really as autonomous and decentralized as possible. Yeah, that was a short one on like, of course, there's like regulations and risks. So I think it's important to read up on them and to ensure compliance, even though like the asterisk, I think is to an extent, like, I think a lot of things also wouldn't be possible if you were like asking every lawyer in the world, like you would never have created Ethereum or Bitcoin or like even Airbnb and Uber if you would have asked every regulator. So I think one needs to, of course, like be compliant and everything, but also I think another important one is to have really strong security measures also for the community, because a lot of obviously scientists and stuff like might not know of like the huge amount of like scams and social engineering attacks, and we even had like the most sophisticated people in our community get like scammed or phished that were like early in Ethereum. Like it's very like there's a huge, especially once there's like a honeypot of like a lot of money and like a lot of contributors, there's a huge incentive obviously for scammers and others to get involved. So it's important to educate the community, especially if they're non-scientific. Yeah, this one is on just making sure that DAOs is accessible and inclusive. Really on not being overly elitist and just enabling crypto people to join, but also really people that are completely new, even to longevity or to crypto in our case. So I think it's important in that sense to break down the barriers to get involved. Yeah, and that's my last one on that it's important that ultimately DAOs win because they are positive sum and like co-owned and driven. And I think ultimately it's hard to compete like say in our case, collection of like 7,000 members with like a company of like 2 people. Like it's I think that's the power that like needs to be of course like reinforced by really putting people at the center of it, and yeah, having this like intentional onboarding and really bringing people on from just being curious to being more involved. Perfect. So yeah, that was the summary of the points. And if you want to join us, obviously the links are kind of like self-explanatory, but I put a link tree here. And if we have maybe a few minutes for questions, can also ask any questions.
Thank you very much, Vincent, for that. That was super interesting. So yeah, any questions from anyone? No?
You get to catch this if you have a question.
So I've got one. You were sort of talking about Bio.xyz as a place for BioDAOs to come and sort of flourish. Are you doing cohorts, and how do you sort of see the relationship between these BioDAOs that are coming to you asking for advice? Is that sort of as like another layer of DAOs? It's like inception of DAOs, and do you find that the communities between each other help each other in that sense?
Yeah, so kind of like with BioXYZ, we are funding BioDAOs with like $100,000 and hands-on support in kind of like these cohorts, a bit like a Y Combinator for DeSci and BioDAOs. And I think the core insight for me has been really that a lot of the stuff we built on VitaDAO, for example, like the tech side or the legal side, the governance side, is obviously replicable to other scientific fields. But I think a lot of, like there's not huge value in like reinventing the wheel on stuff like building 10 different like ways to view like the DAO's treasury or something, or like, but it's a tech effort that like if you do it once, you can use it twice. So I think like the goal is really to replicate this and then just enable like the DAOs in our accord to kind of like fork it. But like everyone in the world, like we basically open source, like it's on GitHub, like the whole VitaDAO tech infrastructure and other things. And the goal is of course also on the legal front, on the tokenomics side and others to open up kind of like the playbook to that people can like really focus on the science and like building the scientific community and research. So yeah, we have the next cohort I think in June. So if you're
well, there you go. If you want to start buying out. So that's like just infrastructure and advice really for people that are interested. Super. Well, thank you so much, Vincent. It's a pleasure having you. Oh, cool.
Oh. Thank you. I just have a question on the voting methods. Have you found any sort of best practices and learnings on voting procedures, what you have in terms of quorum and thresholds that you have to get over, what's worked, what hasn't worked?
Yeah, so we have, I think, like a threshold of like 5% of the total votes need to at least vote for quorum, and I think that worked well. I think there's like other, like ultimately I think the core with a lot of these things is just like observing like all the governance experiments and other DAOs and like what works and what doesn't, kind of like which patterns emerge, like delegation, other things. So I think we like continuously improved and like took those into consideration and also want to like explore novel ones, like even like quadratic voting and other things. But I think a lot of it is also like still very early and unproven. Like if you look at like all the DAOs, like they basically are pretty much all the same, like from their approach. So yeah, we definitely like incorporated a lot of learnings and improved the governance process. But ultimately, you can read up also on it on gov.vitadao.com is like the governance forum, which has some of the details. Yeah, but we raised actually the quorum, and for example, now I really focus on delegation and then like onboarding the right researchers, but also ensuring that they actually get a ton of tokens delegated to, so they have like a decent vote. But it's really like a lot of these small experiments just on governance, and then ultimately we have like half a person on governance, so it's like not sometimes enough people to like do a lot of experimentation, but yeah.
One more from me as well that I just thought of. So obviously Molecule are very large players in this space, and so a lot of these learnings come from them and yourselves and the learnings from VitaDAO as well. Do you also sort of reach out to other projects not necessarily affiliated to Molecule or that specific ecosystem and sort of speak with them about how they're doing and what works best for them as well as your own sort of personal experiences?
Yeah, totally. I think it's like to an extent so early in the sense, like we want to, for example, also, as you said, like we're talking to a bunch of them. I think we probably talked to all of them by now. And ultimately, also through other initiatives like GitCon DeSci Round or like BeakerDAO and other things, like kind of like ideally enable and fund all of them, like including like events and everything, and then really also enable them to like just use, like fork all their learnings and insights and frameworks, even if they completely want to go their own path. And of course, even like in a distributed way, like which is also interesting, like we can also obviously contribute alongside others in DAOs, but the goal is really like on BioXYZ itself, like to decentralize it, like so the mechanism is kind of that the bio DAOs, like a VitaDAO or like others in the program, also have an ownership in the collection of DAOs, so they can, for example, take on tech initiatives together. Like if they need like a new bio-DAO voting system that like costs whatever, like 100K of tech work, they can split the cost between all of them. So the goal is really there is to have these, yeah. Exactly, that's kind of like the goal, to really drive down the cost, because I think a lot of bio-DAOs couldn't afford to do like a lot of bigger tech experimentation, but if they all team up and like pool the cost. So.
Brilliant. Well, thank you very much. Another round of applause for Vincent. Next up we have a panel, researchers in DeSci, with Lily, Sarah Rouse, Rodrigo Ledesma Amaro, and Victor Carolcho. Stick around for that.
Grant, can you hear this microphone? Test. Okay, I think we should just jump right into this. So I know it's getting a little late for some people, but I think that this will be an engaging talk. I'm really excited. The name of this panel is Researchers in DeSci, and it sounds generally very broad because it is. We're going to be covering some broader topics. Do we have any scientists here in the audience? Can you raise your hands? Oh, wonderful. That's a great number. I think that's higher than many DeSci events that I've been to, so this is great. Basically, the idea of this panel is we want to go over, we have 3 scientists here. We want to go over how they're engaging with their specific DeSci projects, but we also want to talk about what a DeSci future could look like for a researcher. And then I'm hoping to get some audience questions, so keep that in mind as we're speaking, and if you have any specific questions for these scientists, we'll have some time for those near the end of the talk. So I'm going to start with getting all 3 of you to introduce yourselves. Can you tell us who you are, what your affiliations are, and just a little primer on the type of science that you do, just so we have a bit of context there.
Shall I start? Actually, you know the scientists? Could you put your hands up again? I just want to know how many of you are like already involved in a DAO, or if it's like your first kind of experience. So if you still have your hands up, you're involved in a DAO, right? Okay, so most people are not involved yet. So we can recruit you, is what I mean. So sorry, I'm Sarah. I'm affiliated to Imperial College London. I have a research group there. So I went through the traditional path, I guess, of master's, PhD, postdoc. Now I'm an independent fellow, which means I have funding to run my own group. We're looking at, we have a few different projects. One of them is linked to mitochondrial dysfunction and aging, which is kind of how I encountered VitaDAO to start with. But yeah, I ended up in this space because I had a joint interest, so my day job was science, but I was also very interested in crypto at the same time. And I guess it took me a while, but at some point I was wondering why I couldn't bring these things together. And then I found out that people were already doing that, which made me very happy. And that's kind of how I've ended up here. And just co-founded a new DAO, which is in space biosciences, which means studying the impact of spaceflight on human health.
Hi everyone, I'm Rodrigo Ledesma Amaro, and I'm also affiliated at Imperial College. I'm a lecturer in the Department of Bioengineering, and my research is in the space of sustainable bioproduction, industrial microbiology. So we engineer microorganisms, mainly yeast, to be able to do things that they don't do naturally, like producing biofuels, pharmaceuticals, chemicals, foods, etc. And yeah, my group is fundamentally experimentalist with some computational aspects, and my experience with decentralized science is really new, and so maybe my perspective here in this group is the one who is kind of newer to this, and I'm going to tell you what this has been like to me. How I got in touch with the DAO, it was through industrial collaborations with Maximum, who is here around, and he put me in contact with Albert Anis, who at that time was founding DeSci, and this is how everything started.
like Sarah, that my entry point into DeSci and interactions with ether down molecule was slightly different. So I was kind of looking for ways to make our science more translational. So a lot of academic science is very fundamental, and that's what I like to do. But I also want to see impact, and sometimes impact is used in an artificial way, and we, as academics, were forced to produce impact, and sometimes you kind of have to bend a little bit truth and stuff. But I think a lot of people like myself are actually interested to see real impact of what you're doing. So I strongly believe that the molecular pathways that we're working with have great potential for targeting for different diseases, for increasing longevity and improving human health, and it's almost like a sin to me not to do something about it. The problem is the academic funding system and the conventional sort of ways to work within academia that they're not necessarily built for something more than just discovery science. And in a way, I was looking for ways to either create a spin-out company or work with industry. And incidentally, it was not because I was interested in crypto or Web3 or anything like that, but it was by a chain of events I was introduced to people from Italy. I really liked the sort of idea and the collegiality and the ethos behind what they've been doing and trying to do, and clicked, and I was very keen to start working with them, so I'm happy to discuss and elaborate as needed.
Awesome. All right, well, let's just dive into some questions then. So Sarah, you were crypto before you kind of jumped into the DeSci space, but Victor and Rodrigo, it sounds like you didn't have that kind of introduction to that space. Did you have any like apprehensions, or was there, when you first heard about this, you know, did you have any concerns that, you know, oh, is that Bitcoin thing? Is it gonna lose me a bunch of money?
Yeah, maybe a little bit, but I think the concerns were disappeared really early when I was explaining what it could mean, right, in terms of especially IP. I think the part that really convinced me to be involved in these type of projects is trying to improve the way IP is managed and distributed. And in particular, in my research, the way universities manage IP is one of these blockers towards commercialization and translation of science. And the idea of exploring different angles and different ways to do that, I think, was very, very attractive.
Yeah, well, I agree on that, and also I think the academic system in general, from funding to publishing results and ownership of both information and IP, etc., is very messed up, and I think a lot of academics agree on that. So I think trying to change it somehow in a productive direction is something that everybody would agree with is a good idea. So I don't think I ever had an apprehension anything, because I feel that we need to make a change. Whether this is the right change or not, we will only find out once we see the outcome. What happens in 10 years? We wanted to discuss that, but I think we need to start making changes. And of course, there is a lot of effort trying to, you know, make information accessible, open access publications, and data accessibility, etc., within the conventional framework of systems that we have already. But I think this could be a really interesting way to either add to that or literally replace what we have currently.
Sarah, I mean, this is obviously a bit of a critical question for those two. You kicked off SpaceDown, so clearly you think there's an advantage to operating in a DAO-like way as a scientist. If you were trying to sell scientists on DeSci in general, or maybe DAOs, just like 1 minute, like what is your best pitch for that? Can you give me like a 1 minute pitch on that?
In 1 minute? mean, I think everyone here's kind of seen from the last couple of days, right, that there are many facets of academic or traditional research funding that we could improve upon. So obviously, like the peer review system, how much time we spend writing grants, and the incentives, and also just how we work together, right? So one of the goals of Space BioDAO, which is, as mentioned, what I've just started, is to try and use data in the most effective way. So using different teams, using different methods, but working on the same data set. So we're getting the maximum impact from one experiment. So yeah, I don't know how I would give exactly a 1-minute pitch. I think I would find out what bothered you the most about academic research, and then I could tell you 5 reasons why you should get involved with the DAO instead. So yeah, I'm happy to do that if anyone wants to say.
Here are the top 5 reasons. So, good parts. There's obviously good parts. But this is all super new. I mean, we're talking to 3 scientists here. It wasn't super easy to find 3 scientists that are actually involved in some DeSci projects in a significant way. And that's something that it's a little bit of an undertone here, but obviously this is such a nascent field that like a lot of these projects are very conceptual, and we're just starting to see everything come into play, and things are being built right now, and there's scientists that are actually getting involved with this and seeing real benefits from it. Obviously there are challenges. I think a couple of you guys referred to yourselves as guinea pigs earlier, which is, I think it's a good and a bad thing. You get to see something from its birth, right? Can you guys think of any challenges that you've had as some people, scientists getting involved with the DeSci world?
I just realised that maybe scientists are the main group of people who like the idea of being a guinea pig, right? We're like, amazing, we're in like our own experiment about how we do experiments. So yeah, I would see that as a positive for sure. But maybe it's not.
I guess you probably have more challenges because you're still in the process of getting the project off the ground. From the point of view of a scientist that is funded by the DAO, the DAO, and Molecule specifically, because Molecule was an instrument that allowed our finance and legal to easily implement funding, because obviously if you come to a conventional faculty of medical sciences in a provincial university in the UK and say we'll pay you in cryptocurrency, they'll probably laugh in your face. But because there was already a platform to make it work and accessible for our administration, it was a very smooth process. And ultimately, to me, as an end user of that, I didn't really see any difference in a way to any other funder, other than actually being part of that sort of like-minded community. Because even from the inception of the project, so the DAO was involved in actually, it was a conversation. It wasn't me presenting something and saying we want to do this, and then somebody goes behind closed doors and put an answer yes or no. It was actually a number of conversations that allowed to sort of target what we wanted to do in a most sort of beneficial for everybody way. And even since then, now we have this sort of constant contact with people now, which is very important as well, because and it's not so to me that's industry, right? Because it's not academia but industry, and it's not too dissimilar to other industrial partners that I have. Is that I always find that industrial partners tend to be more in contact with you and want to actually work with you, which is surprising considering that in principle they're supposed to be profit-hungry, companies and stuff like that. But that's not how it is. And in fact, we actually, a lot of the science that we do is actually informed on and helped with, and we're guided by some of the ideas from people in industry, including people down in this case. So I'm always saying this: it's a win-win. There's a lot of see any downsides really, not yet. I don't know, maybe maybe if we don't deliver on our promises, and then that's a different thing. But I think because we have this sort of community and a safety net, I think to me that's a safety net, because we are constantly adjusting and working together to make sure that we have delivered on what we've been planning to do.
Yeah, I agree with that from my perspective, which is like I'm basically very early on, so we haven't actually started any project yet. We have a great idea and we are trying to get it funded, approved by the university, approved by DAO. And I think some of the challenges we had is not because of the DAO structure, or it's just because both parties are new to this. Valley DAO has been created relatively recently, and this will be the first academic research project they fund, so they kind of need to get to know how to do that with all the advice from the other DAOs, of course. But for us, for me or my TTO, it's also the first time they need to negotiate this kind of thing. So there's a lot of conversations going on about what happened with the IP, what happened with the funding, and those are the things that are taking a bit longer. In the science was very easy to agree. It's a great idea. We like it. We want to fund it. Let's talk together and let's make it better. And let's see who can take this forward in the future and commercialize. And then all together. So there's a lot of transparency and conversation that you don't usually have with normal funders. And that's something really great. But we are still like trying to
work through the paperwork.
Yeah,
makes sense. I think so. It's pretty obvious that like some things are going smoothly, some things still need to be, and the processes have to be developed. Right, this is the first time that this is happening in that university, so super exciting. But so I guess thinking along into the future, let's say everything goes exactly as we hope it will. What excites you the most as a scientist? I mean, this is the end of day 2, right? We've heard a lot of ideas going around, all these talks, panels. Do you have anything in particular in the DeSci space that, when you hear about that, you're like, yes, this would make my life, my career just so much better?
So maybe it's something related to what I was mentioning before, this communication when you build a new project and the community is involved, and you know from the beginning that there are people that if you succeed, they are going to help you to take that forward. At least in my field, how we usually operate is we write a grant, we make the product or the process, and then we try to see if anybody cares about it. Can we commercialize this? Is anybody out there wanting to license that? And very often not, just because we didn't start with the right choice. And here it's a bit different because there's input from the community very early on. There are people that are interested in investing in the technology it's developed. So kind of you start with the security that there will be someone who cares, and that if you do well your part, then it can have an application.
Yeah, I would probably only add to that. Yeah, this idea that we can have all these stakeholders involved in the project, so they don't have to be scientists; they can just be interested in even how DAOs might be used, like across multiple areas. So yeah, I think that's probably the most exciting part of it for me.
Well, if the general sort of question is what excites you about all this in general, what would be nice if I stopped spending half of my life doing stuff for free. I'm not talking about necessarily financial reward or anything like that, but I feel like I'm so busy in my daily life. I'm really full with stuff, and then when I actually try to think, what have I done? This was all helping to read a grant or revise something, or all of these things they're not necessarily expected to be part of my normal academic life, but I spend a huge amount of time on that. Plus, obviously, writing and rewriting grants, etc. So, from what I understood about how potentially this could develop, I feel like it's in the right direction. It would be good to actually somehow try to optimize the ways how this entire shipment is working, and so make work
You've actually already sort of touched on this, but I was wondering, what is that one key message that DAOs that approach scientists need to really hammer home in order to get you excited? Before my current job, I was sort of scouting technologies to access them within the setting of a company, and it always sort of boiled down to time and money. I wonder if that sort of resonates with you, if you think this is what others also will get excited in a sense, or whether there's something else that maybe DAOs can deliver that maybe a company cannot.
I'll start, I suppose. I like this time and money. That's exactly how I see my life as well. And the problem is, the frustrating part for a scientist is that most of your time is going to be wasted, right? So you write 10 grants and you get money out of one if you're lucky, right? Just answering this specific question, I feel like sometimes I'm not even going to bother with investing my time because I will not have anything back. So, but actually, I feel that it's worth investing your time into something like interaction with DAO or industry. I find it big pharma very slow. I have some contracts with large pharma companies, and it took me years to get to that point. With a DAO, at least, it was a process that was weeks, a very dynamic conversation, but weeks. And that's where it's exactly, you're absolutely right. It's about investing your time into something that is more likely to be useful. I hate wasting time, and so this is a good way to actually cut to the chase.
Just very briefly, I would say for me something that excites me in the DAO ecosystem is the network that creates, and how you can very quickly access to many different people with many different backgrounds and interests, and how you can just get to know an investor really quickly in the space that you care, or a company that can invest in your project as well. And I think that facilitates what will normally happen, but slower, so that will accelerate probably translation and research.
I'll just pick one of the random areas, right? So we could take the example of early career researchers, like postdocs, and the kind of funding scenario for them is that they're probably not eligible for most grants to be a PI. And if they are, they can only apply if their contract is long enough to kind of cover the end of the grant. It's actually the case for not any non-permanent academic staff. But yeah, in the case of these DAOs, we can support early career researchers, right? So we can recruit a whole new generation who are probably the most innovative, right, of the researchers, like right at the start of their career, trying new things. So that kind of like, we're just opening up the opportunity for a whole, extra group of researchers who otherwise get stuck in this system of trying to, break through from that level of postdoc to the next level. So yeah, that's one.
Other questions?
So I'm a master's student at Imperial, and so if you are a master's student at the moment, would you pursue a traditional academic career path, or would you fully dive into DeSci? Like, how would you build up your career as a researcher?
Who wants to go first?
I can answer. I guess it depends on what you want to be when you're older, right? If you want to do active research, like get your hands dirty in the lab, or yeah, do the R&D yourself, then I think you're going to get trained through a traditional academic path. How that academic path is funded, that it's open to the two different aspects. You can go the self-funded or getting like fellowship from the government, or you can, as Sarah was mentioning, like getting funding through some of the DAO. But I think at the end of the day, I mean, you cannot do a PhD in valid DAO only. You need an institution that has the accreditation, the power to give you a degree. So I guess if you want to do the actual research, you need to go through that, but you can get funded and get inspiration by the community.
You can't do a PhD yet.
Thank you.
Hi, I'm also from Imperial College, and I'm one of those early career researchers that you have mentioned earlier. So I have two questions, and one of them is that was there any project which was funded through a DAO and it's executed and everybody was happy and it's already like a closed deal? So was there like any project that is through the entire life cycle of a scientific project that was funded through a DAO? And the other question is that like, so you're a practicing scientist and you get some funding through DAOs, but then are you like delegating some of your time in the busy work of running that DAO, or is it like completely decoupled in your experience? I mean, I understand it's probably different from DAO to DAO, just like what I'm just wondering about is that obviously there is a lot of like housekeeping work in traditional academia, and are we just not replicating that, or at least some of that, in the DAO infrastructure? Thank you.
It's definitely extra work, also starting a DAO, yeah. But you're doing different things, and it's more of a kind of community, like I said. So we have working groups tackling different elements of that. And I think it's probably most people who've had interactions with DAOs see that you can kind of put in as much time as you have. So there's not a sort of strict, you have to do so many hours. You just kind of take on something if you can do it. So that's generally how it works. And then in terms of the whole life cycle of a project being funded by a DAO, I would probably be better off referring to the molecule guys, but I think it's too early still for any project to have been completed. Is that right? But some of the milestones will have been reached. Actually, I wanted to ask if we know the success rate of these DAO proposals to being funded. Does anyone know?
Yeah, I think it's like in the earliest phase. I think we looked at 300 proposals or something by now, and I think only like 40 ended through the review process on-chain, like on-chain to be voted on. And I think out of those, actually 90% or something passed, but so 80% kind of didn't make it through the review process. Like, but that is like also up to the community to decide. So it's like multi-stage, but in the first stage, a lot of stuff gets cut, and then in the later stage, actually the community is super supportive of a lot of stuff.
Yeah, so like an expression of interest model, I guess.
Yeah, but that expression of interest is very, very simple. So even simpler than any expression of interest that I'm aware of. In my case, it was a conversation.
We have time for one more question.
Okay, I will ask a question then, and it's a question for the audience. If you are a scientist that is here and you've been here for the past couple of days, I know there's a few people that have raised their hand. The really heavy DeSci ones, I'm going to say like maybe not you guys. Is there anyone in the audience here who has felt like they've changed the way that they think about DeSci? Either they were skeptical at first, and now they're less skeptical, or perhaps the opposite. They were really interested in it, and now they have more questions than answers. Any scientists? I see a scientist holding the block.
Sorry, I zoned out. What was the question?
Do you feel like your faith in DeSci has grown or has subsided a bit since you've been here?
Well, I've been here for 2 days, and in these 2 days it's been definitely growing, at least in my eyes. Like I came here I'm very frustrated with traditional academia, but I wouldn't say that I had any meaningful exposure to DeSci before, so like I'm very new to the thing. I like a lot of the conversations here. It's a very compelling vision. I feel like, sort of like this is where we are as academia, and it's obviously a bad place. this is where, you know, the picture that this community paints, and that's an awesome place. But then, you know, there's a long way between, and just like, you know, how we, you know, slice it up step by step, which is going to be a difficulty. So I'm on board with the vision. I'm like not sure, you know, of how exactly that's going to look like, you know, in a more gradual sense. But yeah, I mean, I'll definitely try to engage with some of the DAOs that are relevant to my work and see if anything comes out of it.
Okay, thank you. What's your name?
Balázs.
Thank you for letting me put you on the spot.
I just wanted to add to this. It does resonate actually, because my question was, is there any way that this, in addition to this new sort of way of working being an addition to what we have now, can be also affecting the way how we work with sort of the traditional rules? Like, can these sort of practices be not imposed but somehow inform the ways that are currently embedded in the system? I don't know, at the level of policy or something going through government, etc., to make the conventional rules of academic funding, publishing, dissemination, etc., more decentralized and more like reasonable, and sort of moving to adjust conventional ways as well, because it's a huge layer of life, and it would be a shame if it was just remain the same, and then we had something in parallel, and then needed to sort of play both the games. I don't know if there's any way to.
Just to add to that, I think it's sort of really positive that we've had Chi come and speak. I've obviously been in communication with you about how we can try and inform government and people in power about what's going on here. I think there's definitely a balance. It's fantastic to see so many new ways of doing science here, and you know, you can't help but think how these ideas could potentially be applied to current systems in place. So if anyone knows anyone in like the UKRI or NIH, and they're interested with just the model of the funding, rather than, yeah, I mean, at least that, I think it would provide value just to sort of deep dive into a conversation with traditional funding. Maybe DeSci London next year, if we could get a few of those, if we've got people in high places. But yeah, I think that those sort of talks need to happen, and it'd be really interesting to see what comes of them.
Very nice, tight way to wrap that up with a call to action from Alfie. So go talk to him if you know anyone like that. He's right there. I just want to say thank you to all the panelists today, all the scientists that we have here, the decentralized scientists, I guess we could call you, perhaps, maybe. All right, and yeah, thanks again.
Thanks, everybody. Next up, we have Christopher Hill from DeSci Labs.
So, let's hope it works.
Do you have notes that you want to use, or are you just going with the, like mirrored is okay?
Mirrored is the best.
Okay, perfect. So this should just, so in a minute that'll go away. This will pop up, everything you see on here.
It's all mirrored, right?
Screen. Yeah. And you kind of want to stay within this little box because that's
sound, right?
Yeah, sound and it's live streams.
Cool.
Okay, are we ready?
Great. Hello, everyone. It's great to be here at the Crick Institute today. Thank you so much for the organizers for making this happen. So today I'm going to talk about infrastructure for verifiable and composable research. The scientific record is the engine of progress of our species. Today, it lives in the crowd. It suffers from loss of artifacts. Data, code, other incredibly valuable scientific outputs end up in hard drives in universities somewhere. We lose these invaluable artifacts. It suffers from content drift and link rot. The internet, since its inception, was not designed as a substrate for the scientific record. It suffers from brittle PIDs, who were state-of-the-art in 1996. That's how old they are. They're essentially lookup tables, and they break and they require constant and expensive maintenance. As a result of that, the scientific record is not verifiable. We mentioned the replication crisis and the incentives that surround it. When you read a research paper and you understand that it's a coin flip to know whether you can trust, whether you can believe what you read, this is one of the most pressing problems that we all face. Scientific record is not machine readable. It's expensive to maintain, and it creates bad incentives for researchers. It's a complex, multi-agent system that produces the scientific record. We have scientists who are knowledge creators. We have publishers who are knowledge curators. You have analytics providers and indexers who are there to curate the publishers. And at the end of that, you have CRIS and RIMS, current research information systems. This is how the work of scientists become points and metrics on dashboards of funders and institutions. Now, if we pull the logs from this machine, we all agree that something is deeply broken. Research productivity has gone down. Grant funding occurs to older and older and older people. We have a drop in disruptive science. Something doesn't work. At the same time, I'm incredibly optimistic about what we can do for our scientific record. We live in a rare moment, a conjunction of policy and technology. The OSTP memo in August 2022 changed everything. It mandates open access to peer-reviewed manuscripts, to data that's been publicly funded, without any embargoes possible on these research outputs. And it needs to be machine readable and fair enabling. The FAIR principles stands for findable, accessible, interoperable, reusable. These are the properties that our scientific outputs should have. But today, we're not close. And so it's a momentous time, and that's why I come here with a message of deep optimism. Because there's goodwill at every layers of this incredibly complex system. Everyone is facing a common challenge. We need fair enabling infrastructure, and we need to upgrade our unit of knowledge. The Center for Open Science has a theory of change. We have to build infrastructure to make the impossible possible. We have to create good user experience to make it easy for scientists to share their work. We have to provide values to scientific communities so that we can then make it socially normative to do these right things. And we have to make it rewarding. And this will come naturally if we can satisfy all of these levels. So what should our unit of knowledge be? There's this concept, this idea of research object. Today we've been over-indexing on research papers and under-indexing on all of the other fruits of the scientific pursuit. When we publish a paper, there's so much behind it. There's computational pipelines. There might be regions, research data, video of our procedures, peer review exchange, pre-registered analysis plan, contributor maps, grants. All of this form what's called a PID graph, a PID graph. And it's incredibly precious. And today, we're not nearly there at this ideal. This is very important. Fair enabling means PIDs plus data, plus metadata, plus methods. That's what it takes to make our work optimally reusable so that we can accelerate progress. And where should we store these research objects? Should we put them on a silo in AWS? No, nobody wants that. They should live in an open state repository, a common repository that is accessible to all. And this is one of the most powerful promises of the decentralized web. The idea that we can break the data layer from the application layer to create a common data pool that is open read and open write. And we can take these research objects and store them in incredibly secure and efficient data structures called Merkle DAGs. And we can index these DAGs on a blockchain, on a ledger, to create PIDs, persistent identifiers. This is the master key of the scientific record. And then we can create granular PIDs that allows us to address any linked data object in that entire research object. Today, a DOI costs $1 and is a link between a publisher's website and a string that follows the DOI schema. We can do better than this. And these research objects stored open state need to be composable. So what does that mean? Imagine an infrastructure that is fair enabling, where every type of services can operate on that tree of knowledge to curate it. eLife has long talked about being an overlay platform on a preprint. But who wants to be an overlay journal on top of a PDF with a DOI? No. The overlay systems of tomorrow operate on an open state repository with the code, with the data, with all of these artifacts, so that we can have more than simply peer review. Today we need data curation, data stewarding, we need image certification. We can have all of these services operate on a composable system using the primitives that have been so successful in the software development world, which is Git. But none of this will work if we don't make it powerful. We need to deliver value to scientific communities now, not tomorrow, today. So what does that mean? We can make it so that these PIDs preserve data in a way that protects against content drift, link rot, across 3 continents, 5 countries, with a hot copy. To store 1 petabyte of data on AWS will cost me $500,000 a year to make it available to my scientific community. It shouldn't be the case. With this system, we can have sponsored storage for 18 months and then a competitive marketplace in which service providers compete for the best prices so that we can essentially accelerate the pace of sharing and reduce the financial barriers across sharing incredibly large data sets. And we need to make it powerful by defining methods to interact and operate on that data. Methods for fair digital object reuse. Data has gravity, so if you have a petabyte of data, it's much more efficient to send the program over to where the data lives than to download the data locally. It's what some of the amazing folks at Protocol Labs have been building with Bacalhau. So in this case, you can take a PID from a research object on DeSci and immediately send a program over to it to run your calculations. But you can also think as PIDs as importable objects. So you can directly, imagine if you could type import DOI fetch DOI/data/measurement.csv, and you'd run that command in Python, and you'd have that data set directly into your IDE so that you could produce new knowledge and discover tremendous things. This is this idea of citations as function call from Balaji Srivanasan. We can do this. We now have the technology to make it possible. But beyond being powerful, none of this has any chance of succeeding unless we nail the user experience. This is fundamental. We have to make it easy for scientists to use. Today, we're familiar with manuscript submission systems. This flowchart up here is what you have to follow in order to make your data available. It shouldn't be this way. It should be easy. Creators of all forms have fantastic tools. Scientists have manuscript submission systems. Developers have GitHub, designers have Figma. We need to find scientists where they are today with the tools that they use and that they love. We were talking to editors of scientific journals. The #1 request when a scientist says, I would like to share my data. It's like, can I send you a Dropbox link? It's like, no, we're not equipped for that. Please follow the flowchart. It shouldn't be this way. It should be easy. We should create tools that integrate everything that scientists love and know in order to create composable research objects that are stored open state. So I'll give you a little demo of what we've been building. Just a second. Okay, So you're on a website like this, NIH Library of Medicine. Where do you want to go as a scientist? Well, you want to run away. You want to go to this button, right? You want to go to the PDF. That's where it's like, oh, finally, I got my content. I can read it. That's where I feel good. I'm in the right place. So what do we have here? We have an embedding with a PID, this persistent identifier. We can click on this embedding. We have decentralized registry. We have here in this case a cover art generated by AI on this paper. And you're back into that comfortable area. Now, the difference is you have a mysterious icon, which actually has all the richness tied to this research object that you've created. You can have code, you can have reproducible notebooks, you can have data, you can have videos. You have this ability to create these research objects. We also have attestation and verifiable attributes. Imagine if you had institutions and service providers that could certify that your data is fair with verifiable attestations. This is possible. Imagine the richness of having an entire economy of systems operating on top of an open state repository, that you could incentivize them openly to perform this verification. You could also create verifiable research easily. You can add annotations, give context to your readers. You can embed provenance to your figures and your result in a really simple way that allows you to reproduce these results, all in the comfort of a PDF viewer. So here, as we can see, we're running an embedded notebook into this research object viewer. You can reproduce these results. You can interact with the code. We also have version histories, perfect version history. It's all based on CIDs, content identifiers. You have provenance, who, what, and when altered and proposed a new version. You have source with all of the contributors. And now, let me show you some new features. We're close to releasing our beta. At the root of every research object, there's this graph of knowledge, where you have all of these artifacts. You could think of that as a file structure, as a folder. We all have research objects as scientists, except they're living on our desktop. So now you have a node drive, a fully fledged IPFS drive with the ease of use of Dropbox, where you can simply post your data, where you can simply post your code. You can have all of the components that live in the back end of your paper. And it's that easy to do. You can create metadata. You can essentially have fair data in an easeable way with schemas that can be community defined. And you can reuse them. So here you have the CID of that particular data set. This is the address where this data lives. You can send a program with Bacalhau today on this to run new computation. And that file could be a petabyte or more. It would work. And you can import them. You can import these data sets, this code, using dpid fetch. As simple as, in a way as simple that it is to import a library in Python. Imagine if this is how we could interact with the scientific record of tomorrow. So DeSci Nodes is an experimental platform that is being built in conjunction with an open protocol with the open state repository. It's there as a proof of concept, an experimental proof of concept of how we could build research objects and how we could deliver value to scientific communities. It's built like many things on the shoulders of giants. This is a very famous trilemma in computer science called Zuko's triangle. Zuko proposed that there's 3 desirable properties in any naming system. It's human meaningful, security, and decentralization. And he said, but you can't have all 3. Pick 2. So for example, DOIs are only human meaningful, but they're not even human meaningful because they follow a specific schema. They're not secure, they're not decentralized. They require constant maintenance. CIDs are secure and decentralized, they're not human meaningful. With DPIDs, we can have the three properties. And this was an observation that was published in a famous blog post by Schwartz. Aaron Schwartz, the open internet activist who solved Zuko's triangle. And now if you combine Zuko's triangle, the solution to Zuko's triangle, with the invention of Juan Benet, IPFS, content address storage, you now have a system that is extremely powerful because it combines all of these properties and allows us to store data securely in a way that is accessible to all. And this is the ideal substrate for the FAIR principles of Wilkinson: findable, accessible, interoperable, reusable. So remember this. One DPID, Decentralized Persistent Identifier, gives you a PID, data, metadata, methods for every artifact stored in a research object. And it comes with the properties of preservations. Multiple copies keep things safe. 3 continents, 5 countries. It has provenance. Every new version that is posted on this system gives us a trace of who, when, and what. It's interoperable. We have methods. We can send programs over to where the data lives. We can import the code and its functions directly into our IDEs to make our lives better. It's composable with verifiable attestations and Git primitives. And it's accessible. This repository is open state. It does not depend on the willingness of a silo in a platform. Anyone can access this repository and build a new generation of platforms to serve scientists that will today compete on user experience and features, not on the moats created by data. So what could the future look like? Well, imagine if the scientific record was composed of constellations of composable nodes that build off each other, that compute off each other to produce new, verifiable, reproducible knowledge that is accessible to all. We live in a momentous time. It is a conjunction of technology and policy. It is a rare window. The scientific record is our greatest achievement, and we are here to find new ways to preserve it, to secure it, to make it more reproducible, to curate it pluralistically, and create incentives that reward the quest for truth. So thank you. Thank you for the incredible DeSci Labs team. Thank you to Sina, Philip, Adam, Carla, Eric, Remo, John, Shadrach, Richard, Andrew, and Mike, who have made all of this possible. And also to our amazing partners at the DeSci Foundation, a group of amazing meta-scientists. Protocol Lab for being such a enduring and wonderful partner for us, and the Center for Open Science for being such a great source of inspiration to everything we're building. Thank you very much.
Amazing, thank you very much. It's a very long and worthy round of applause as well. So just got maybe a couple of minutes for questions, if anybody has any. Yes, we have 2 down here. That was my fault, actually.
That's right. All right, you can hear me. Yeah, thanks for the awesome talk. And thanks for mentioning Aaron Schwartz as well. There's a whole story there. But yeah, thanks for that. Yeah, my question is, why isn't this done in IPLD?
It is IPLD.
Boom. Okay, cool.
Yeah, just seeing the whole graph of everything made me think, are you excited of doing meta studies and meta-analysis on once there's, millions of these nodes all open? Yeah.
Yeah, of course. I think perhaps more important than doing meta studies right now, more important is to create a group of stakeholders that includes meta scientists this time, because the governance of such a protocol in open state repository is going to require credible neutrality. And the people that should be sitting at the table are, well, the stakeholders, right? And meta scientists are core stakeholders, right? The people that have blew the whistle on the replication crisis, the people that have been doing amazing work on studying the incentives of the scientific record, those people need a voice. And yeah, I'm very excited about giving them a voice.
Awesome. Thank you.
Are there any more questions at all? We have one down here from Isabel, if you want to throw them.
Yeah, all right.
It looks great, and so you said you're launching the beta. How, if anyone here has looked at it and be like, I want to try this, what's their path to giving it a go?
Yeah, join our Discord channel and get in touch with the people at DeSci Labs. That's one way. You can also email us. You can get in touch with me at the end of the conference. I'm happy to talk to you, and because this is the most important. Like the lifeblood of these systems are communities, right? But in order to form communities, you need to form infrastructure. So it's really this combination of both forces that is so necessary. So if you're a scientist, you want to try things out, you want to help us build it. We'll take your feedback. We'll make it better. And I think we have a chance to really change things.
We've got one more behind. Very quick though.
Just logistically, Mike, just keep your eyes out for DeSci.com. So this is where we're going to have the link to the beta. So we're planning to release it at the end of January, maybe a few days more or less. But this is where you will have access to the nodes, and then you can just start using them.
Thank you. Thank you so much, DeSci Labs. Thank you. And in just a few minutes, we'll have Nicholas from LabDAO speaking, who's our last speaker of the day.
So once you plug it in, this is enable team, and I'll switch it on.
I have 20 slides. Yeah. I think. Yeah, then I have that too. Yeah. I mean, I'm flexible with timing.
Yeah, I just wanted to check that out.
All right. Shall we get started?
Yeah. Hi, everybody. Okay, well, we're going to get started, so please take it away.
Hey, everyone. This is a long conference day, but you're at the end. So we're going to be talking about how to build an online scientific organization. I'm Nicholas. I'm a physician and computational biologist by training and a founder of LabDAO. So at the outset for this talk, I just want to actually use this slot, the graveyard slot, to do a bit of a recap of what is decentralized science, what did we actually learn. I think one of the key three core messages of decentralized science is the idea that we can build more accessible funding opportunities, and that this because we have on-chain wallets, so everybody can be sent funds and everybody can spend money in an extremely transparent way. We can have new forms of distribution and ownership, be that through hypercerts or IP NFTs, and we can experiment with new forms of accessible tools and data through platforms like Bacalhau, IPFS, IPLD. Now, let's get to a bit of a personal story about why I'm here today and why I'm not in academia anymore. So this is a plot that shows the inventor net migration patterns across different countries. So on the y-axis you have the migration patterns of inventors, where an inventor is defined as someone who has been publishing a patent in the past. And then the x-axis, you see different nations. And what you can see when you look at this is that the dots are the net position. So basically, are you a net exporter or net importer? And there are actually just a couple of countries, the United States and Switzerland really, that are net importers of inventors, and all of the other countries are overall net exporters. And that is because human capital, just like financial capital, goes where it gets treated best. And inventors want to be in an environment where they have access to tools, access to funding, access to great colleagues that stimulate them and make them do their best work. So I was born over here in Germany, and then my parents took me to California as a child. We had to go back. I studied medicine in Germany, started doing science there. Was somewhat frustrated with the system, but didn't know any other alternative until I went back to the States for grad school and worked there for some time at the Broad Institute. I think my first grant that I ever got was an AWS grant, $10,000, just sent to a student, and they're able to do whatever they want. It was one of the most awesome experiences, so I don't know whether the AWS person is still in the room, but hopefully she, through some avenue, hears that. And then, however, because of a visa issue, I had to go back to Germany, and I was like, well, this kind of sucks, because all I need is a laptop and an internet connection, but now I get sent back, and I lose all my access to a really stimulating scientific environment, and I'm back in Germany, where I felt like the community was actually not that supportive. There was not that much funding to do very translational research that comes out of computational biology. So at some point, the question was, well, if more and more inventors are able to work completely online and in the digital realm, can't we build a place for inventors that's completely online? A scientific organization that's completely online, where you use tools on your computer, you have access to physical laboratories if you need so, and your IP is generated within an online community, and you're in full control of how it is used. And in essence, that's basically trying to build a group of people that can actually do decentralized science. But decentralized science itself is actually not that much of a new idea. So it really started already in 2010. When you look at this plot, you can see percentage of between city collaborations of all the patents that have been filed to the US Patent Office. And you can see that the proportion of patents where you have people from more than one city collaborating with each other has really consistently been increasing since 2010. Now, not only are more and more scientific projects collaborative and inventors work together across distances, but also I'm going to learn this at some point in this talk. These teams are actually more disruptive. So this is another study where they actually analyzed the patents that were filed by teams, and they looked at how disruptive are patents. And surely there was just a couple of weeks ago another paper in Nature that made the waves with basically inventiveness and disruptiveness in published papers and patents decreasing over time. In this particular study, they used an analogous method to measure the disruptive potential of a patent. And while in the past, in the 1980s, when you had an international or cross-city collaboration, the probability of you having a disruptive patent was actually lower than the average. Since, again, the 2010s, your odds are actually higher if you're a distributed team, if you bring in different influences and backgrounds. So we really should start with projects. Projects are the base currency of science. So it all starts with an idea. It all starts with a conversation at a conference where we say, oh, what if we combined X with Y? Or the time when you read a paper in the afternoon and you think about, well, with this new method, what if we did something different? So at LabDAO, we really went one step back and said, okay, how can we create a product that makes it very easy for a scientist, no matter their maturity and their traditional training framework, to share their idea and to be able to receive funding for it. So when you head to the LabDAO website, which is now updated and live, and you click on Create a Project, you will create, with your GitHub, a wallet. You don't need to stress about any of the crypto elements. It's just by using multi-party computation via Web3 auth, you have a wallet instantly, and you keep it secure with your GitHub account and a local key that's stored on your laptop and sent to you via email. Now with that wallet, you have suddenly access to all of the nice things that Web3 allows you, which is you can manage your own project funding, you can own project-related certificates, you can demonstrate achievements through Git POAPs, you can also access certain token-gated tools, and you can vote eventually on the organization's directions as well. So then you go and you create a project, and this is all IPFS and grants protocol compatible, so you can take this description of your project and make it visible on platforms such as the Gitcoin grants protocol, which is set to be released in a couple months. And if you hit the QR codes, I have some buried throughout the presentations, you can test these tools yourself. So I think this has been actually one topic that's been a bit underreported at this conference. Is like, what is actually the future of scientific funding? How does it look like? And how do we actually create these bridges between the foundations, the investor DAOs, potential VCs, the existing large national funding agencies? And I think it goes all the way back to Alok's talk at the beginning of the conference. So this is one extremely popular mechanism in Web3 to fund projects that has been basically pioneered by Vitalik and Glenn Weil in 2019, which is called quadratic funding. The idea that if you have a verifiable way online to show that you are a real human, we can change the way that donations work. So usually if you would like a project, you would send money to it. But obviously if there is someone who has way more capital than you, they will have way more power in steering the direction of that project. However, what if we introduced a quadratic penalty where the big player, for example, a Wellcome Trust in the future, if we can convince them to adopt these technology, where the Wellcome Trust would say, okay, we're taking a step back. We're not picking winners here. We are a matching pool, and then other individual agents that are qualified, but also maybe just citizens, can fund projects that they really care about. And the citizens will actually, through their vote, govern how much funding the Wellcome Trust allocates to each of these individual projects, and thereby enabling a society in which also citizens can have a say directly which projects should get funded. This is already live on Gitcoin, and it's actually working pretty well for them. They're just piloting with UNICEF grants this quarter, and they have a couple other rounds coming. And I personally believe that this is something that if we talk to regulators, if we talk to the public funding agencies, we should bring this up as a prime example of how also public and private can work together, which is what I'm going to get to now. Because not only is quadratic funding super useful, but when you tie that up with certificates, be they hypercerts or IP NFTs, I think you have a really interesting match. So what if every science project had certificates owner that can steer the work of the project, and basically those certificate owners, they would earn that certificate when they would participate in this funding round. I think there's some really interesting second order effects. First, every scientific project would be directly registered. So if you think about these open science goals of pre-registration, that's baked in. Because the scientist wants money. Well, if you want money, you better register that thing on chain. And you also know all your stakeholders directly. If you want to eventually demonstrate that you support a scientific project, you show your certificates. If you want to show that you worked in a scientific project, you show your certificates. If that project turns out to spin out a biotech company and you ask yourself, well, how do we structure the cap table? Well, we better look at the certificates. So basically, just like carbon certificates and putting a price on carbon has a real potential to help us save this planet, I think creating certificates for just open source work in general has a real potential to get us out of this mess that we have between this world that runs on citations and the world that runs on the US dollar. So let's run through two potential scenarios for two different scientific projects that would follow this model where we marry quadratic funding and impact certificates. So project A is a project that is scanning the C. elegans brain and really trying to build a high-resolution atlas. A lot of people in society would agree that that project has high value, but you wouldn't be hard pressed to find a venture firm that would underwrite that risk, because the time discounted value of that project is just too low, given all the uncertainty of what how that information would translate into something tangible like a product. So probably would end up with a lot of people in the public over time just giving a couple bucks, and then the Wellcome Trust here in the gray bar would end up giving the bulk of the funding. Now, if that scientist has to eventually report to their shareholders, to the certificate holders, The Wellcome Trust, here in gray, would be the primary shareholder, as it should be, right? The science funding agency is the one that one should answer to if they end up being the funder of the science. So we have a lot of small transfers, a large relative match, and ownership is with the public and a large matching pool provider. Now let's take another project, Project B. Project B is a highly applied project. It's looking for, it's testing a new gene therapy for a monogenic disease. Before that thing sits out there for like 2 weeks, two venture firms just around the corner of this institute have already scoped it out, have placed massive bets, concentrated positions. There have been few large transfers. The Wellcome Trust just does a very small relative match based on these formula, and the ownership is with the high conviction funds, as it should be. You don't want to have a lot of debt weight on your cap table when you really want to turn it into a company. So I believe this is one potential formula how we as a community that are interested in decentralized science can address both people in the private markets and in the public sector about, you know, what is the utility of all of this that we're cooking up. It's not only the sharing of data, but it's also the accountability of projects, making them countable, creating certificates that measure actual value, and then giving the funders of these projects some form of utility on top of that. So we're at LabDAO helping scientists, especially young scientists, go that route. These certificates are still a bit nascent, so they haven't been rolled out yet, but definitely these teams have been participating in Gitcoin rounds and have been able to raise in aggregate about $40,000 for their respective computational projects. So one project I'm just going to highlight here is from Mike Pica, who is in industry actually, and has a passion for science and wanted to create a discourse graph, a knowledge graph for aging biology. And this is currently live. It's based on Obsidian, a discourse graph, which is a form of a knowledge graph where you separate different hypotheses and claims and evidence, and it's browsable by the public. And eventually the idea is if you create an on-chain instantiations of it through the tools that Martin and the team is working, you eventually can also reward contributors with certificates that have done that kind of work. Now projects and talking about what you want to do is just one part. But if the moment that you actually want to run some code, or you want to talk to someone who has expertise, or you want to run wet lab experiments, you have to sort of leave that community. It's not very useful to be in DeSci. So the second aspect that we arrived at relatively early was the idea that, okay, not only do you need to be able to talk about your project and raise some initial funding, but you also need to have access to tools to enable your science. So what we've been providing is notebook infrastructure, a place for your work. If you're a computation biologist and you're a member of the community, you can access this server today and you can start working on the stuff that you're interested in. But beyond that, we're also containerizing some applications that we believe to be extremely relevant for community-driven, especially translational science. So this is work done, for example, at Regina Basulai's lab at MIT, DiffDoc, that we've been containerizing and made sure that it runs properly, and we were very happy that we have the support from both the Bacalhau team and the DeepCam community in making all these things work. And then when we go into like some use cases that we've been exploring, I'm just going to pull this one up that we did 2 weeks ago. It's now submitted, I think, first at bioRxiv and then eventually other venues as well. This is a compound that came out of a lab at Washington University in St. Louis, in Tim Peterson's lab. It's a compound called BioIO-011, and that compound was identified in a CRISPR screen. Nobody knew really, was it binding the proposed target and where exactly was it binding, and we used some of these new models that we've been putting together to at least generate a hypothesis that we now have to follow up on. Now, we don't want to stop with just dry lab. We want to go all the way, so we made sure that we're ready for wet lab, and I'm very happy that we can announce a partnership with Zero-Matic and other Zero aggregators that allow us and all the members in the community to access also contract laboratories to do physical laboratory experiments based on their designs. Now this has all been an effort from a loosely connected community, which I think is the most impressive piece of this all. So when we launched LabDAO, it was very clear that we wanted eventually just be this network of agents online and not a for-profit company. And it was extremely hard to convince people that this was something that should exist and they should support. And I'm extremely happy that this community came together. They're building all these pieces, and we were able to find people that also really want to make this exist in the world. So happy to announce that we raised an initial funding round, and we're going to be keeping this work. And this is also because of a lot of community engagement coming from all of you at DeSci London. So I think I'm going to stop with thank you, everybody that attended, and thank you. This was such a great conference.
We've got time for questions. So does anybody have any questions? Does anyone have a burning desire to have this box thrown at them and they haven't had it thrown at them yet? If so, raise your hand. Or just if you have a question you want to ask as well. Just raise your hand. Yes, over there.
I have a question about the wet labs. Does, like, let's say it's within a university, is there now a negotiation between IP rights and if you lose our stuff, and how does that,
So it depends on what your affiliation is as the one that's doing the work. So we make sure that in these relationships with a contract research organization, for example, you negotiate the IP terms. So some CROs want to have some equity or some future royalties from the work, but that is all now yours to decide, which is, I think, what's extremely important. I think, giving a university or someone who's providing infrastructure for you to do your work, giving that person or that institution some equity is not the worst thing in the world if you have the option to opt in or out. But I think a lot of us, especially the students, find themselves in situations where they just sort of apply to a grad school and nobody calls the tech transfer office and asks, well, if I come up with a startup while I'm in my PhD, how much equity are you going to take? Those questions are not getting asked, and these universities are not doing a really good job as giving us the deal terms of doing a PhD at their institute. So we want to turn this completely around. When you're with LabDAO, you control your equity. Eventually, maybe that we will introduce a tier where we want to also ask you to give us some for your project in token space, but you will know upfront, and then you will be able to negotiate with every other player that you want to involve in that project.
Very cool, thank you.
Thank you. Are there any more questions? No? Okay, in which case, thank you very much, Nicholas. And Alfie, did you want to say some closing words? Thank you.
Well, I'm not going to keep you guys too long here because obviously there's some free drinks to get to. But I just thought I'd say a massive thank you for everyone turning out. It's been brilliant engaging and speaking to everyone that's sort of come A, internationally, and B, from London. It's made me really excited about the future and what we've got planned at DeSci London. And I want to also say massive thank you to everyone that's helped out as well. This has been a complete grassroots community effort. I mean, you can see by the number of sponsors, and you've got to bear in mind that we did this during the whole FTX crash. It's been a real effort and community effort to bring this all together. So thank you to all the sponsors, thank you to the people that were helping out, and thank you for the community to showing up, asking fantastic questions, and of course also the speakers as well, which have been giving just the most interesting talks possible. So yeah, super happy with how it's gone. I hope you guys are too. And I think I also do need to announce the poster competition winners as well, which I'm not sure if you guys were too familiar. There are some posters that are outside that were sort of created to showcase some of the sort of projects that are going on in space. And so although there was a turnout of 2, it's a lot of effort, and I just want to thank both for spending the time putting something together that I think I've had multiple people go up and interact with and find value in. So we decided to go, I mean, a little bit harsh given there were 2, but we wanted to award Valley Dow with the winner prize. So well done, Valley Dow. I'm not sure. there's no physical prize to collect right now. Yeah. We're going to mint an NFT, and so you're going to have a DeSci London NFT to put in your ValiDAO wallet, which is very exciting. But yeah, thank you so much. And I would also like to say, if you're interested in what we're doing and want to help contribute, I will be at the after-party drinks, and please feel free to come up to me. Thank you very much to AWS for sponsoring that as well. Yeah, I hope you've all had a fantastic time, and I'll see you soon. Let's see if we don't